What is going on, peeps? It is Aldo at Zero to Mastery, and today I'm excited to introduce to you our latest crash course, Vue 101 by Luis Ramirez. And if you haven't noticed, we're dropping a crash course every month on the latest and greatest technologies. So make sure to subscribe and hit that bell icon to stay notified anytime we drop a video. Also, if you end up liking this crash course, it'd really help us out if you smash the like button. Think of it as your good karma deed for the day. Now you're probably asking yourself, who's Luis? And why should you trust him to teach you Vue? Well, you'll find out for yourself in just a minute. But rest assured, you're in very good hands. Luis is a senior developer with over a decade of experience in the industry, and he's also worked on some very large-scale projects. Have you ever heard of Manning Publications? Well, if you've ever tried to learn to code by reading a book, there's a very good chance that book was made by Manning Publications. And there's an even better chance that Luis assisted the writing on it. So not only is Luis super knowledgeable and a talented developer, but most importantly for you, Luis is a passionate instructor who goes the extra mile to make sure you understand what's going on. Luis's students don't just learn technical skills. They walk away with the critical thinking skills needed to solve any problem with confidence. This crash course starts off with the basics that you may find a bit boring. But the boring stuff's important too, so stick with it, because before you know it, Luis and you will be in the groove and you will be hooked, I guarantee it. Now, before we get started, I'm going to hand it over to Andre, our lead instructor and founder, to quickly walk you through the roadmap of exactly what you'll learn in this Vue 101 crash course.
Hello! We're super excited to start this course with you. I hope you are too. But as you know, before we do, what I'd like to do is to give you a roadmap of what we're going to learn, the order we're going to learn things in, so that we have a path to success. So let's see what this course will look like for you. Now, obviously have to start off with the Vue fundamentals. These are the core concepts of Vue, so that by the end of this section, you can start building things in Vue. For those that are already experienced in Vue, this will just be a quick refresher for you. Now, after the fundamentals, we're actually going to go straight into a project, and this one's called the Perspective Playground. It's a really quick mini project we're going to build just to get you excited and show you how fast we can build things with Vue. From there, we're gonna dive deeper into the developer environment. We're gonna learn all the tools that Vue developers use. Things like Webpack, SASS, PostCSS, ESLint, Vue CLI, and so much more. We're going to make sure that you're gonna have a professional setup. We're then gonna dive into beyond the fundamentals, more advanced topics of Vue, and how we can build larger and larger applications using more advanced techniques. A lot to cover here, and it's gonna be a lot of fun.
Hey there, it's me again. Are you pumped yet? I know I am, and I hope you are too, and ready to crush this crash course. I know you probably want me to stop talking so you can start learning Vue. Fair enough, but one last thing before I hand it over to Luis. If you end up liking this crash course and want to dive deeper into more advanced Vue topics, then I highly recommend you check out Luis's complete Vue Bootcamp course, where you'll get to build a massive Spotify clone project that'll teach you things like user registration, authentication, routing, state management, form validation, and so much more. It's a really wicked project that's guaranteed to make your portfolio stand out. You can check it out using the link in the top right hand corner and in the description down below. But that's enough chit chat from me. Let me hand it over to Luis so you can start learning Vue. Enjoy.
It's time to start digging into Vue. We have 3 objectives for this lesson. The first is to load Vue onto the document. Secondly, we want to start using Vue by creating an instance. We'll explore what that means in a moment. Lastly, we want to verify Vue is working. We won't be able to move forward if Vue is not correctly functioning. In the resource section of this lecture, you'll find a zip file. Download and unpack the files anywhere. It doesn't matter where you unzip it. I recommend working in a directory where most of your development projects will live. Once you have that done, open the files in the editor of your choice. There's not much going on. The HTML file has a basic setup, nothing that will be unfamiliar to you. Along with the HTML file, I have included a style sheet. The stylings I'm adding have nothing to do with Vue. I added them in to provide some spacing for the elements we'll use in the next few lectures. It isn't necessary to have this, but I think it'll make things visually clearer. If you don't want to bother with CSS, you're free to delete this file. You will also need to remove its inclusion from the HTML file. Lastly, we're loading in a script which is empty. We'll be writing some code soon enough. One thing I want you to notice is the div tag with the ID of app. This element is where we'll be writing most of our application code. You'll soon understand why we need an element to house our application in a moment. With the necessary files ready, let's load Vue. In the resource section of this lecture, I provide a link to the installation documentation page for Vue. There are several ways to download Vue. Most developers prefer to use the tooling to scaffold a new project. It's great that there's an official toolset for Vue, but we're not going to start using it. We will in a future section. We want to focus solely on Vue. For this reason, we're going to use the simplest method for loading Vue. We'll use a CDN. I find the CDN to be much simpler for getting started because it allows us to focus on Vue without all the bloat. It's truly the best way to experience Vue without committing to an entire toolset. If you're not familiar with the concept of a CDN, let me quickly break down what a CDN is. CDN stands for Content Delivery Network. They're a vast network of servers that host static files like CSS, JavaScript, or images. One of the main issues of delivering files to the user is how long it takes for the file to reach them. A CDN will store copies of your files on different servers across the globe. Before a file is delivered to the user, the network will figure out what server is closest to the user. For example, if we're in New York, the CDN will deliver the file from a server located in New York. If we live in India, it'll deliver the file from a server located in India. CDNs are intelligent enough to deliver the file from a server closest to the user. This decreases the time it takes for a page to load. The Vue team has opted to upload a copy of Vue onto a CDN so that we can quickly get started without installing additional tools. A CDN works out of the box. Using the recommended CDN is a great way to get started with Vue. On this page, there's a section dedicated to using Vue without build tools. In the first code snippet, there's a script tag. Let's copy it to our clipboard. You do not need to copy the entire example. After copying it, paste it into the HTML file. Make sure it's loaded in before the app.js file. By adding one script, we've included Vue. This simplicity is one of the things I love about Vue. A lot of other frameworks require you to use a CLI to install many tools to get started. It's quite a hassle. However, with Vue, everything works with a single script. Vue does come with a CLI. We'll be taking a look at that later in the course. We're going to approach things in the most straightforward manner possible. The next step is to control the element with Vue. Even though we've included Vue, it does not automatically do anything to the page. We're the ones responsible for telling it what to control. Doing this is very simple. Inside the JavaScript file, we're going to call a function called Vue.createApp. The Vue object is defined by the script we added in. It has a function called createApp where it'll tell Vue to initialize a new application. The application it returns has the capability of keeping track of data and manipulating the document. This function has one argument, which is an object of configuration settings. We'll pass in an empty object. We'll add some settings later. The next thing we need to do is mount the application. The word mount is something you'll come across frequently in the documentation. It's used to describe the process of Vue inserting itself into the document. At the moment, we created an application, but we didn't tell Vue where to render the data. We need to instruct Vue where to mount the application. The createApp function will return an object with a method called mounts. We can chain the mount function after creating the app. This method has one argument. It's the element the application should mount itself to. The format for the value must be a CSS selector. In the HTML document, we have an element with the ID of app. We'll pass in #app. Be sure to pass this in as a string. That's important to note down. We've created our first app. It won't do anything, but let's check if it works. To view the file in your browser, you can double-click on it in your File Explorer or drag the file onto the browser. Typically, we would deliver our application from a server. Servers are computers that are capable of handling requests for an application. We're working locally, meaning we're working on our personal computers. The Vue team has developed a solution for creating a server on our machines. That's something we'll look at in a future lecture. For now, opening files directly in the browser will work. We won't be using features that require the necessity of a server. As you can see, nothing is happening. Let's open the console to check for some errors. I'll be using Chrome for this course. I recommend you use Chrome as well because it comes with the latest features of JavaScript and the best tools for development. You can open the console by pressing F12 on your keyboard. If you're on a Mac, you can press Command-Option-I. The console will not output any errors. Let's check the Elements panel for a moment. Nothing changes here either. Alright, so nothing is happening so far. How do we verify if Vue is controlling the element with the ID of app? There are a couple of ways, but I think the easiest way is to use the official dev extension. We'll take a look at this tool in the next lecture. We've taken the steps to integrate Vue into our document. Before we move forward, let's take the time to check the application with the Vue Dev Tools. It's a crucial step because the official developer tools will allow us to debug the application. In the resource section of this lecture, I provide a link to the Vue Dev Tools extension. The Vue Dev Tools extension provides information about your application. It's effortless to use, and it will be beneficial later down the line. Scrolling down, we'll find a link to download it for either Chrome or Firefox. I'm going to download and install this quickly. You should do the same. I've finished downloading the tool. If I were to refresh the page, nothing would happen. Why is that? In the corner of the browser, a new icon will appear that will be grayed out. This icon will light up green if we have a Vue application loaded on the page. We're creating a Vue app in the browser, so why isn't this turning green? The developer tools are unable to detect a Vue application. It's because of security restrictions in regards to opening files directly in a browser. Browsers will typically limit some of its features when delivering a file locally as opposed from a server. In the address bar, you'll see that we're accessing our page via the file protocol. The extension, by default, doesn't support this protocol. We'll need to activate it ourselves manually. Right-click on the icon. Select Manage Extensions. A new tab will open with the settings for the extension. We want to check the setting that says Allow access to file URLs. Make sure that this option is turned on. The settings will save automatically. Once that's done, let's try refreshing the page again. In some cases, you may have to exit out of the browser and reload the page again. The extension's settings may not have taken effect until you have done so. Nothing on the page will change, but the icon at the top right will light up. That's a reliable indicator that Vue is functioning. If we were to click on it, it'll tell us that Vue has been detected on the page. We've verified Vue is working. The developer tools have so much more to offer though. We can view the details of the application from the Chrome developer tools. Open the developer tools if you haven't already. A new panel will be available called Vue. Click on it. If we were to click on the Vue panel, we'll find information about the application we created. At the very top of the developer tools, we can switch between tools. On the left side, a list of active applications on the page is listed by the tool. It'll even tell us the current version of Vue we're using in our application. Typically, you will find at least one app. Next, there are menu items for different categories of tools. Each tool can have another subcategory. We want to focus our attention on the Inspector Components tool. Not much info is available, which is expected since there's not much going on in the HTML or JavaScript file. However, under the list of components, there is an element called root. We haven't talked about components yet. You can ignore this term. It's something to revisit later. The root component refers to the element that Vue is controlling. It is the element that contains the overall application. This is very important to understand. You may only have one root component with as many children elements as you'd like. If you wanted to, you could have Vue control the entire page by assigning an ID to the body element. Then you can update the mount method to control the body element. It's common practice to load a Vue application within an element rather than the whole page. One of the benefits of placing it inside the div tag is to allow for multiple instances of a Vue application on the same page. I'm getting a little ahead here, but you can have numerous Vue instances within a single page. That's awesome. Anyway, getting back to the task at hand here. To verify if Vue is genuinely controlling the element on our page, we can select the root component. On the right, we'll see a button called Inspect DOM. If we were to click on this button, we'd be switched to the Elements panel with the element selected in the document. This behavior verifies that Vue is working. Congrats! You've made your very first Vue application. Admittedly, it isn't anything exciting, but it's a start. Let's quickly review what we know so far. To get started with Vue, we need to load it in. It's as simple as adding a script tag to the document. After installing Vue, we need to instruct it what element on the page it will control. Inside the JavaScript file, we created a new application by calling the createApp function. We pass it in an object to configure how the application will interact with the document. We didn't bother to configure Vue. It's something we'll get to in the upcoming lectures. Afterward, we chained the mount method. This method will tell Vue to insert the application into the document. It has one argument, the selector for the element where we want to insert the application. We want it to control the div tag with the ID of app. We can verify if Vue is active by taking a look at the Vue panel inside the Developer Tools. The root component refers to the element that's being controlled on the page. That's it. Nothing groundbreaking, but Vue is pretty simple so far, isn't it? In the next lecture, we'll begin making our application more dynamic. We have a very basic application. The next step in our journey is to add some data. Data is an integral part of any application. Data can be rendered onto the page like a username or profile picture. You can use the data to affect how the content gets rendered on the page. For example, we can restrict access to areas based on the data in our application. Adding data to a Vue application is simple. Inside the script, we can add a property to the object we passed into the Vue.createApp function called data. We'll set this property to a function. During the initialization phase of our app, Vue will search for a function in our configuration object called data. If it finds the data function, it'll call it. Vue expects an object to be returned by the function. Let's return an object. The object we return from this function will represent the data in our application. We can add any type of data we'd like. We can add strings, numbers, booleans, objects, and arrays. Let's create a property called firstName with a value of John. The object returned by the function will be registered with the Vue application we're creating. Vue will let us render our data into the document. That's something we'll want to do next. We want to render the nameData property onto the document. We can do that by writing a JavaScript expression. Here's a quick refresher on expressions. A JavaScript expression is a single line of code that can be evaluated to a single value. The value can be a number, string, or logical value. There are all kinds of expressions. Here are some examples. Arithmetic operations, basic string manipulation, and logical comparisons are considered expressions. All three examples will evaluate to a single value. To add a bit more clarity, here are some examples that aren't considered expressions. Variable and function declarations are not expressions. The same goes for conditional statements. Vue enables us to use expressions in the document. Let me show you how. Switching to the HTML document, between the div tags, add 2 pairs of curly brackets. Vue will treat the content inside the div tag as a template. This will only apply to elements that are selected by Vue. In our script, we selected the element by chaining the mount function. Expressions can be used inside templates. An expression can be added to the template by writing a pair of 2 curly brackets. Inside the curly brackets, we can write an expression. For example, we'll add 2 numbers together. Whatever this evaluates to is what will get rendered onto the document. Vue will take care of finding the expression, grabbing the results, and then insert it into the document. Let's give this a test. We'll refresh the page on the browser. The expression will get evaluated. The result of the evaluation is what gets outputted instead of the curly brackets. That's thanks to Vue. However, we don't want to perform a basic math operation. We want to output the name we have in the data object. Let's head back to the editor. Back in the HTML document, we're going to replace the expression with the name of the data we added, first name. That's all we need to do. Let's test it out. Refresh the page. The name John will appear on the page. With very little work, we've created some data and displayed it on the page. There is quite a bit going on here, so let's go over it one by one. The expression is the name of the data property we defined in the Vue instance. All data properties are exposed directly by their names. We don't have to use the this keyword. Vue will be able to make the connection on its own. After evaluating the expression, Vue will replace the curly brackets with the value. You can think of the curly brackets as a placeholder. You may also hear this as being described as string interpolation. These two phrases can be interchangeable at times, but there is a difference between them. Expressions are the code inside the curly brackets, whereas string interpolation is describing the process of replacing a placeholder with a string value. Therefore, you can say, the expression first name is interpolated into John. A bit of terminology going on here. You'll hear people throw around both terms when discussing Vue templates. It's important to know what they mean when they use these terms. There is a limitation as to what you can insert in the curly brackets. Anything other than an expression is not allowed. You can't perform declarations or conditional logic. What do I mean by this? You can't define a variable and expect it to work. For example purposes, I'll replace the current expression with a variable declaration. This expression will not work, but let's see what the result of this declaration will be in the browser. Nothing appears. If we were to look inside the console, then we'll find an error. It tells us that we must avoid using JavaScript keywords, so that's one limitation. Another thing you need to be aware of is that expressions will always be outputted. You should always be careful what you put inside the curly brackets. This isn't a place to run code behind the scenes. That should be done in your JavaScript files. I'm going to revert this to the expression we had originally. Expressions can't be used outside of the template. The template would be the element we selected in the mount function. If we were to attempt to create an expression outside of the template, it would be ignored. For example, I'll copy the expression and paste it above the div tag. Going back to the browser, the expression will appear unprocessed. Expressions are only possible within Vue's template. The expression we tried creating outside the template was left alone. I'll go back to the document to remove the expression. One last thing. It's crucial we declare the data inside the data function. Vue will not search for data outside of the configuration object. For example, let's say we create a variable called last name. Its value will be doe. Then, switching to the document, we're going to create an expression after the first name. This expression will output the last name variable. Let's refresh the page to see the final result. We'll see the first name appear. The last name does not get outputted. If we were to look at the console, you'll see we get this error. It's telling us that we're using last name in the template, but it's nowhere to be found in the data. This variable exists in our code, but Vue does not recognize it because it wasn't defined in the object returned by the data function. This is important to understand. You have to set your data from within the Vue instance. Any outside code will be ignored. Let's switch back to our editor. We'll remove the last name variable. Instead, we're going to define it inside the data object like so. Let's refresh the page one more time. The name is fully appearing in the document. The errors have disappeared in the console. That's fantastic. Vue makes it incredibly easy to render data in our application onto the document. There will be times where we'll have data that we won't want to render on the template. In these cases, we can use the Vue Developer tools to check the data. Open the Vue Developer Tools panel. Clicking on the root component will show us the data in the instance. Along with viewing the data, we're allowed to make changes. Looking at the data, we'll find the first and last name properties. This is a great way to check if your Vue instance contains the data for your application. That wraps it up for this lecture. We'll continue in the next one. Vue does a pretty good job of keeping itself isolated from the rest of the page. There's nothing wrong with that, but you may want to control multiple locations on the page. This isn't common practice, but it is possible. Let's say we want Vue to control 2 elements on the page. One solution some developers attempt is to use multiple elements with the same class name. However, this will not work because one Vue instance cannot control multiple elements at once. Let's look at what would happen if we were to attempt that. Inside the document, we're going to change the attribute from ID to class. Then we'll duplicate it. We'll also need to update the Vue instance. Rather than using the ID selector, we'll need to update this selector to a class selector. Let's see what happens after making those changes. After refreshing the page, the first element will have the name inside the template. The second element is not processing the expression. Instead, the expressions get outputted as plain text. Not what we wanted. There aren't errors in the console either. So what's the problem? A Vue instance can only be mounted to one element. We're allowed to have children elements, but there can only be one root element per instance. If multiple elements match the value we pass into the mount function, Vue will assign itself to the first element it finds. This is why the first element displays the name, and the second one doesn't. What if we wanted to show the name in both elements? We would have to create another Vue instance with similar data. Let's give it a try. How about you try this as an exercise? Assign both elements unique IDs. Then create a new instance for the second element. Lastly, try changing the data for the second instance. You don't have to change the property names, just their values. Pause the video and give it a try. Welcome back. If you were able to do it, then congrats. If not, that's fine as well. Let's do it together. First, we have to update the elements on the document. We're going to assign ID attributes to both elements. The second element will have an ID of app2. Next, let's switch over to the JavaScript file. Update the instance to select #app rather than .app. After that's done, we'll make a copy where the selector will be #app2. Lastly, to show we have 2 unique instances of Vue, we're going to set the first name data property for the second instance to Jane. That'll do it. If we did everything right, we will be able to refresh the page with both names appearing. There we go. We have two unique instances of Vue. Even though they have similar names in the data object, they're completely isolated from one another. The first name and last name properties are unique to each instance. If we were to open the Vue Developer Tools, we'd find both instances appearing. Creating two instances isn't common. Typically, you will have a single application on any given page. I wanted to show you this as you may come across situations where you'll want multiple Vue instances. For example, you may be working on a site where you'll need to create a couple of small widgets. In these cases, you can create multiple instances to manage your widgets. We're going to focus on one instance. I'm going to comment out the code for the second instance in the HTML file, as well in the JavaScript file. I recommend you do the same before proceeding to the next lecture. In this lecture, we're going to learn how to access the data after the instance has been initialized. In some scenarios, we may need to update the data in our app at a later time. For example, let's say we wanted to change the first name to Bob after 2 seconds. That's possible, but first, we need to store the app we created in a variable. We're going to assign the app to a variable called VM. We can call this variable whatever we want, but it's common practice to use the name VM, which is short for Vue Model. Those two words describe Vue pretty well. The word Vue describes the HTML we have in our document. It's what the user sees when they load our app. The word model describes the data stored in our app. Vue is a framework that focuses on the view and model of an application. The phrase Vue model is describing the relationship that Vue establishes between the two parts of an application. This is why most examples will use the variable name VM. After the variable assignment, let's invoke the setTimeout function. We'll give it a duration of 2000 milliseconds. Inside the function, we want to change the first name to Bob. To access the data from within the instance, we'll need to set vm.firstname to Bob. Let's stop here for a moment. At first, you may be thinking, this shouldn't be possible. The first name property is inside the data object, so shouldn't this line be vm.data.firstname? Usually, yes. But Vue does something magical behind the scenes to allow you to access the first name property from the object itself directly. It saves you time from having to write a long line of code. It's a process called proxying. I'll talk about what proxies are in a moment. First, let's check to see if this works. I'm going to refresh the page again. After 2 seconds, the name will change from John to Bob. Surely enough, it does. We can use the Vue Developer Tools to check if the data is changing internally. According to the tools, the data has been updated correctly. This behavior is precisely what we wanted. Vue makes it incredibly easy to access the data from within the instance. Let's take a moment to talk about what's going on behind the scenes because it's important to understand. First, we have to understand what proxying is. A proxy is a figure that represents the value in a calculation. That's the official definition. Let me break down what that means in relation to Vue. When Vue is initialized, it'll store your data in a property called $data. Therefore, to get the first name, we can use the following: vm.$data.firstname. This line will return the first name from the data object. The problem with this approach is that we have to type quite a bit of code to get the data. It isn't that annoying, but it can be simplified. Vue simplifies the code you have to write by creating proxy getters and setters. They're merely functions that'll take care of grabbing or updating the actual data. This feature keeps your code readable and straightforward. It's done behind the scenes for you. We can access the data directly from the object rather than access it through the $data object. Vue is capable of calling the correct functions that will access or update the data. The purpose of this is to make it convenient for you, the developer. Proxying is something you never have to worry about setting up. It's a feature built into Vue. This proxying feature is one of the reasons why developers love Vue so much. It's almost like magic. Let's take a look at the code that makes this possible. I'm going to comment out the set timeout function so that it doesn't disturb us. Then, let's switch back to the console of the developer tools in the browser. Inside the console, I'm going to log the VM variable. We will be able to see the contents because it's a global variable. Right away, there will be a lot of properties and methods defined in the object. Most key names start with either a $sign or underscore. As a side note, Vue likes to assign its own properties with these characters as a way to let the developer know their names reserved by Vue. You shouldn't try to override these properties. Getting right back on track, scroll down to the very bottom. We want to search for something called getFirstName. Vue creates a set of getters and setters for every data property we create. They are proxy functions that take care of retrieving or updating your data properties. Whenever we type vm.firstname, the corresponding proxy function is called, which will get the actual value for you. Same thing for when you're updating a value. You can think of a proxy as a middleman for your data. Proxies work straight out of the box. You don't have to worry about setting it up or executing any additional code to get it to work. By using proxies, our Vue data is exposed directly from the object. That's one of the brilliant things about Vue. It allows you to keep your code simple and readable. We don't have to dive into the object to search for our data. Don't worry about all the nitty-gritty details. It's more important you understand the overall theory. Vue is here to make our lives easier. I wanted to discuss some of the theory behind it to get a better understanding of what's going on. That wraps it up for this lecture. We'll continue in the next one. The app we built displays the full name on the page. Inside the code, we're using two expressions to accomplish this. It would be nice if we could make it into one expression. We could update the data object to hold the full name, but that's sometimes unrealistic. When we retrieve the data from an API, we'll most likely have to combine the data to get the desired result. That isn't too hard to pull off. Inside the template, we can combine this into one expression by removing the curly brackets and adding them. We'll use a string template to accomplish this. This is a valid expression. You're free to call functions or use arithmetic operations from within your expressions. Let's play with this a little more before we view the result. Since the last name property is a string, we can call the function toUpperCase to capitalize all the letters in the last name. This function is a native JavaScript function. It's not something specific to Vue. Let's refresh the page. The name gets displayed with the last name in all caps. We get the same result, but with one expression. The result is what we wanted. Well, sort of. The expression has become complex, which can be problematic. You want your expressions to be short and simple. It's recommended you perform complex logic in your JavaScript file. It's not ideal to write complex expressions inside the template. It will happen from time to time, but you will usually want to separate the logic from the view. Luckily, we can use something Vue calls methods. Methods are functions that we can call to perform complex tasks. Let's try creating one. Back in the editor, we'll update the JavaScript file. We're going to add a new property called methods. It'll be set to an object. The methods property is where we can define functions for our application. It works similarly to the data object. Functions defined outside of the Vue instance will be ignored. You won't be able to call them from your template. Vue will only use the functions defined inside the configuration object. Let's create a function that will concatenate the first and last name. The name of our function will be called fullName. Inside this function, we're going to return the code we had in the expression. A couple of things I want to point out. First, to access the data from within the instance, we need to use the this keyword. Technically, this shouldn't work, but Vue will allow you to access the data like this thanks to its proxy mechanism. We don't have to worry about logging the object and finding out where the data is. It's accessible directly from the root. The second thing I want to point out is that I'm using a regular function. If you're familiar with ES6, you may be tempted to use arrow functions. However, this will cause errors in your application. It's not recommended to use arrow functions because of the proxying mechanism in Vue. The this keyword will not work if you were to use an arrow function. If you don't plan on ever using the this keyword in your function, then go right ahead with using an arrow function. Otherwise, always use a regular function. Now the question is, how do we use this function inside our template? It's quite simple. Switch over to the document. All you have to do is call it inside the expression. We'll replace the existing expression with the full name function. That's it. Let's try viewing the page. If we refresh the page, we will see the full name appear. The template looks a little cleaner because we were able to move the logic outside of the template. To summarize, methods are functions that you can use inside your Vue instance or template. Functions defined in the methods object are proxied by Vue. They're directly accessible in your template. If you would like to use the functions inside the Vue instance, you can access them via the this keyword. Since we're storing the instance in a variable, methods are also accessible through the VM variable. That wraps it up for this lecture. We'll continue in the next one. The next thing we'll look at is directives. Directives are attributes that change the behavior of the element it's applied to. They're very simple to use. Vue comes with a few built-in directives. You even have the option to create your own. Let's start with some of the built-in directives. At the moment, the application is loading fine. But you may have noticed one problem. If we were to refresh the page, we would see the expression appear as plain text before it's been processed. This is because Vue and our application code haven't been loaded yet. For me, it's not much of a problem because I have a fast internet connection. However, that may not be true for anyone else who uses your application. If they were to see this, they might assume the application is broken rather than thinking it's loading. We can simulate their speeds by opening the Chrome Developer Tools. I assume you already know how the console and element panels function. The other panels are for more advanced uses. One of them is called the Network panel. The Network panel will output what files are loaded and how long they take to load. It'll display information about each request, but we don't need to go that deep at the moment. One feature I like is the ability to throttle the download speed. At the end of the options, you'll find a drop-down for connection speeds. Online would be considered your regular internet speed. We have options for other speeds. It's possible to create custom speeds as well. Let's try using the slow 3G speed option. Then, let's refresh the page by pressing Ctrl F5 on our keyboard. This keyboard shortcut will not only refresh your page, but will clear the cache as well. The expression takes longer to process because the scripts haven't been loaded yet. We have a basic application, but can you imagine what a page would look like with dozens of expressions? It wouldn't be very attractive to present our content like this. This is a common problem. There are multiple ways to fix this. By far, the easiest way is to use a directive. Using one is very simple. We'll switch back to our editors. Inside the document, let's add an attribute called vcloak to the app element. To the browser, this is an attribute, but to Vue, this is a directive. Unlike attributes, directives change how an element behaves. This behavior can be anything from changing the color to removing an element. All directives start with the V followed by the name of the directive. Directives can have expressions as values, but the one we're using doesn't require one. Therefore, we don't need to do anything else with it. This directive performs one single task. It'll wait for our Vue application to mount itself onto the document. The moment it does, it'll remove itself to wherever it's applied to. That seems silly because it's as if it doesn't do anything at all. The intention behind this directive is to help us hide elements it's applied to. However, that job is up to us to handle. Let me show you what I mean. The browser will identify this as an attribute even though it's a directive in Vue's eyes. We can use CSS to select this as an attribute and hide the element. Open the CSS file. Alternatively, you can create a pair style tags if you deleted the CSS file I provided earlier. At the bottom, we're going to add a selector for the vcloak attribute. Attributes can be selected by wrapping their names with a pair of square brackets. Inside the section, we'll set the display property to none. Any elements that have this attribute will be hidden in the document. Since this is the case, the user won't see the ugly expression. Eventually, Vue will be mounted onto the document, causing the directive to be removed. The styling we applied will be removed from the element we have the directive applied to. Anything being hidden will appear. Let's give it a try. Make sure you have throttling turned on. While the page is loading, the expression isn't appearing as plain text. After the page has finished loading, the name is rendered onto the document. This looks so much better and cleaner. Let's refresh the page again with the Elements panel opened. After refreshing, you'll see the vcloak directive attached to the element. The stylings are applied to the element. Once Vue has been loaded, Vue will remove this directive automatically, resulting in the removed stylings. This is the power of directives. Truthfully, this directive isn't very exciting, so let's explore some more directives. We'll learn what else we can do with directives. Before moving on, be sure to remove the throttling. One of the more interesting features of Vue is two-way data binding. Two-way data binding is the ability to update data through the HTML document or JavaScript file. That seems like it would be difficult to manage or pull off, but it's easy with Vue. Before we check out two-way data binding, let's surround the expression with a pair of paragraph tags. Then, we'll add a horizontal line right under it. We're adding these in for better formatting. Next, create two input fields and labels for the first name and last name properties in the data object. Let's refresh the page to see the final result. You will have something similar to what I have. The input fields are ready. Nothing will happen if we type inside them. That's to be expected. Now the question is, how do we tie these input fields to the data? The answer to that question is with directives. Vue provides directives for linking the data inside the input fields to the data inside your Vue instance. Back inside the document, we're going to start with the first name input field. We're going to add the directive called vModel. The value for this directive will be the expression first name. The values for directives are interpreted as expressions. Some directives don't require values, such as the vcloak directive we used in the previous lecture. However, the vModel directive does require a value, which is an expression. The value that gets evaluated from the expression will be used as the input field's value. You may notice that I'm not adding the curly brackets. Directives automatically assume the value is an expression. We don't need to add curly brackets. In fact, let's see what happens if we tried adding in some curly brackets. Afterward, we'll refresh the page. The application will throw an error. The console in the Developer Tools tells us that there was an error with compiling the template. It says that we have an invalid expression. The value for the vModel directive is already prepared to take in an expression. The fact that we're passing in another expression means we're trying to run an expression from within an expression. No wonder Vue doesn't like this. I'm going to remove the curly brackets. Then I'll refresh the page. The application is functional again. The input field is pre-filled with the data from the first name property. If we were to update the input, then the full name above gets updated too. This update is something that Vue will perform automatically for you. Because we're using the vModel directive, Vue will keep track of changes to the input field. If a change occurs, it'll update the data in our application. The data it updates depends on the value we used for the directive. This includes any methods that use the data. We don't have to worry about calling the function again because it's automatically called for us behind the scenes. This automation is what's called reactivity. Reactivity is the process of updating the document whenever the data changes. Once a change happens, Vue will look at the template. It'll identify any expressions that need to get evaluated again. The template then gets updated with the new values. Vue does a good job of keeping track of everything for you. If we were to use vanilla JavaScript, the code would look something like this. First, we would select the input field. Notice how I'm grabbing the input field by its ID. Without an ID, I could mistakenly grab the wrong input field. After grabbing the input, an event listener is attached with the keyUp event. If the event is triggered, the paragraph's inner text is updated with the input field's value. We can achieve the same results with vanilla JavaScript, but there are a few problems with this approach. The first is having to assign IDs and classes to the elements. There's a bit of management that has to go on. We're dealing with an input field and paragraph. What would this look like if we had hundreds of elements? It would get complicated quickly. Vue solves this issue elegantly with reactivity. It's keeping track of the data. It's also listening to events that could potentially change the data. If the data changes, it'll know exactly where to apply those changes without assigning classes or IDs to the document. I'm going to update the name again. As I'm typing into the input field, the name gets updated in real time. This is reactivity in action. In traditional websites, you would have to refresh the page whenever the data was updated. However, with Vue, the updates occur immediately. Vue takes this a step further by allowing us to use two-way data binding. Two-way data binding is the idea where if the data in the document is updated, then the data in the JavaScript code is updated as well. Vice versa, if the data in JavaScript were updated, then the data in the document will also get updated. We can see two-way data binding in action by opening the console in the Developer Tools. In the console, we're going to access the VM object, which contains the Vue instance because that's where we stored it. Then, we're going to access the first name data property. From the looks of it, the value in the instance has been updated. It matches the exact value in the input field. This time, if I were to update the value with JavaScript, I would see the changes reflected in the document. Surely enough, it does get updated. This feature is called two-way data binding. Any changes in the document will be reflected in the instance. Any changes in the JavaScript Vue instance will be reflected in the document. All we had to do was define the data property and attach the vModel directive to the input field. Let's try a simple exercise. The last name doesn't get updated. Try attaching a directive to the input for the last name. Pause the video and give it a try. Welcome back. If you are able to take on the challenge, then that's great. If not, that's fine as well. We'll do it together. Pulling this off is dead simple. On the input element for the last name, we're going to add the vModel directive with the expression last name. That's it. There's nothing else we need to do. Go ahead and refresh the page. If you were to update the last name above would update as well. That's the exact behavior we were looking for. That wraps it up for this lecture. We'll continue in the next one. In some cases, you may want to have dynamic attributes. I'm not talking about directives, but actual HTML attributes with dynamic values. For example, Let's say I had a link below the full name that points to Google. Rather than hard-coding the URL into the attribute, let's store it inside the data object. I'm going to call it URL. We want the href attribute to be set to the data property in the Vue instance. We learned previously that we couldn't use expressions inside an attribute's value. Vue will not process expressions placed inside attributes. Therefore, we'll need to use a directive. Luckily, you don't have to memorize 20 different directives for every attribute there is. Right before the href attribute, we're going to add a directive called vbind. In between the directive and attribute, we're going to add a colon. The vbind directive will allow an HTML attribute to have a dynamic value. You can apply this to any attribute by adding it before the attribute. The colon will act as a separator between the directive and attribute. By adding the vbind directive to an attribute, Vue will process the value as an expression. Therefore, we can set this attribute to URL. That's all we need to do. Back in the browser, we can refresh the page and click the link. The link will open in a new tab. The vbind directive allows for any attribute to have a dynamic value. Throughout the course, you'll see how incredibly useful this directive is. You'll get a lot of practice binding attributes. Because it's so common, there's a way to shorten this directive. Back inside the document, we're going to remove the vbind directive, but leave the colon in place. This syntax is a shorthand way of writing the vbind directive. If Vue finds a colon before the attribute name, it'll assume that you'll want to bind the attribute. Let's test the application. Back in the browser, we'll click the link again. Google will open a new tab once again. As you can see, either method works. Using the longhand or shorthand version is all preference. For the rest of this course, I'll be using the shorthand version. In this lecture, we're going to learn how to output raw HTML. Before we jump into the code, I want to take a moment to talk about some security issues that may arise from doing this. The security risk I'm talking about is called cross-site scripting. You may also hear it referred to as XSS. Cross-site scripting occurs when malicious or harmful HTML is injected into the web page, causing unintended behavior in the application. This usually happens when you output HTML from an external data source. For most of this course, we've been dealing with basic data. None of it contained HTML. The HTML was left inside the template. However, there will be scenarios where the HTML will come from the data source rather than the template. In these cases, you open yourself up to cross-site scripting. This is because your data will not be hard-coded like we've been doing so far. Your data will most likely come from an external source such as a database or API. If those sources are compromised, your application will most likely face issues too. Before we go any deeper into this topic, let's learn how to output raw HTML. Previously, we inserted a link into the template with a dynamic URL. Let's recreate this, but with the HTML mixed in with the data. Inside the data object, we're going to create a property named raw URL. The value will be an anchor element with the URL pointing to Google. Then, inside the template, we'll create another pair of paragraph tags. We'll create an expression inside the tags for the raw URL data property. This expression will not work. Let's see why. Go ahead and refresh the page. Vue will process the expression. However, it will not render the HTML correctly. It'll get escaped, resulting in it being rendered as raw text. This is great in most scenarios. It means that if the data was compromised, then the worst a user will experience is a broken app rather than a malicious one. Now let's say I wanted to output the HTML unescaped. What then? We can render HTML from a data property by using a directive. Back inside the template, we're going to remove the expression. Next, we'll apply the v-html directive to the paragraph tag. The v-html directive will allow us to output unescaped HTML. The value of this directive is an expression. We'll set it to the raw URL data property. Let's give the application a test by refreshing the page. If we did everything correctly, the link will appear like the one above. We will be able to click on it. This is great. Thanks to the v-html directive, we're able to output raw HTML onto the document. Let's circle back for a moment. I want to take a moment to discuss the security risks with outputting raw HTML. There is a reason why Vue will only output data as raw text. It's because it's a safer solution. Let's pretend that a hacker suddenly gained access to the database where the URLs are stored. If they saw we had raw HTML rendering on the page, they could change the links to harmful sites. What would that look like? In the Developer Tools, we'll open the console. We're going to access the VM object, which contains our Vue instance. We will change the raw URL data property from Google to Bing like so. If I press enter, you'll see that nothing changes above. It's because I didn't change the inner text of the link. I only changed the link itself to use Bing instead of Google. If I were to click on the link, I'd be taken to Bing, which isn't what we wanted. This is one example of cross-site scripting. One common method for hijacking an application is done by convincing users to copy-paste code into their consoles. This will give them access to the data in the application. While the user is at fault in this scenario, we don't want our data to contain raw HTML. We should take precautions to ensure the application doesn't output anything we don't intend it to output. There are usually better solutions for handling raw HTML. You need to consider those solutions whenever you have to output HTML carefully. I want to give some final thoughts on this before we move on. Unfortunately, there's not much you can do to prevent cross-site scripting on the front end. Vue already does a good job of keeping us covered by only outputting raw text from expressions. However, that can't solve every scenario. Nowadays, there are browser extensions that modify the HTML on a page. Users may have these extensions installed. There's not much we can do about it. There are two things we can do though. A lot of the responsibility falls on the back-end developer as they have full control over what gets inserted into the database. As long as they're securing their side, it makes our job so much easier. If you're developing on the back end, make sure you're sanitizing and escaping any HTML that goes in and out. Our duty, as front-end developers, is to escape characters. Vue helps us with that. Secondly, make sure you trust the source of your data. Most APIs available are safe, but always make sure you know what kind of data you're receiving and expecting. As long as the back end of things are secure, your front-end application will be safe. Out of the box, Vue supports native browser events such as clicks, key inputs, hovers, etc. We can listen for these events to run a function whenever an event occurs. It's very easy to do. We can listen for events by using directives. Inside the app.js file, let's create a new data property called age. Its value will be 20. Then, let's display this age inside the template. I'm going to place it beneath the links we created previously. Let's say we wanted to add a button that will increment or decrement the age based on which button a user clicks. Below the input fields, we're going to add two buttons for incrementing or decrementing the age. Neither buttons do a thing at the moment. I want to be able to listen for a click. If a click is registered, we'll want to update the age property in the instance. The directive we'll want to use is called vOn. This directive will listen for an event. The name of the event it'll listen to needs to be added after the directive. Like the vbind directive, we must add a colon followed by the name of the event. In our case, this would be the click event. All JavaScript events are supported by this directive. The value of this directive can be one of two things. You can either execute code or pass in the name of the method you like to run whenever the event occurs. Let's try both. For the increment button, we're going to set this to increment. For the decrement button, we're going to use the decrement operator on the age data property. Something you'll notice is that I'm not adding the parentheses after the function name. This is entirely optional. If you don't plan on passing anything to your function, the parentheses can be omitted. Vue can invoke the function without a problem. The increment function doesn't exist. We'll have to define it. Inside the methods object, we're going to define the increment function. Inside the function, we're going to increment the age data property. I'm accessing the data via the this keyword. Inside the template, I'm accessing the data without referencing an object. That's because Vue will automatically assume any data you access in the template comes from the data object. Therefore, we don't need to do anything special to access the data in the template. Alright, let's give this a test, shall we? Refresh the page. We will see the age along with the two buttons. If I were to click either of these buttons, the age will increase or decrease depending on which button I click. By using the vOn directive, we can listen for events on our elements. Listening for events is a common practice in Vue. There's a shorthand available for listening for events. Back inside the template, rather than using vOn, we can replace this directive with the @ character. Be sure to remove the colon too. This attribute isn't valid, but that's perfectly fine. Vue will be able to understand that you want to listen for events with this shorthand method. For the rest of this course, we'll be using the shorthand way of listening for events. Let's explore some more events and dig deeper into what else we can do. If I were to write something into the text input fields, the name would get updated. That's thanks to the vModel directive and the reactivity that Vue brings to the table. However, let's say I wanted a bit more control over what goes on. The vModel directive is a combination of binding and using events in Vue. Let me show you what I mean. For the last name, let's say we wanted to insert ourselves into the update process. We can't do that with the vModel directive. If we want more control over the update process, we'll have to remove the vModel directive. Instead, we'll need to bind the value attribute. Take special note, I'm using the shorthand version for binding a value. The value for this will be last name. By binding the value, this input field will be pre-filled with the default value from the last name data property. If we were to refresh the page, we will see the input field for the last name pre-filled with the data property. However, if I were to update the input field, you'll notice that the last name does not update. The same is true if I were to use the Vue Developer tools to inspect the data. The last name data property stays the same in the application. This is because Vue is setting the value on the initial run. It will not take care of updating the value inside the data property or listen for changes. We'll have to take care of that ourselves. Back inside the document, we're going to bind an event to the input field for the last name. The name of the event we'll listen for is called input. We'll set the value to update last name. This method doesn't exist. We'll need to create it. Inside the methods object, we're going to define the update last name function. How do we grab the value from the input field? In the function, we can update it to include a parameter called event. When Vue calls your function, it'll automatically pass your method the event object. The event object is the typical JavaScript event object you would encounter in plain JavaScript. We can update the last name property to event.target.value. The target object refers to the element that is currently triggering the event. Since it's the input field, we can access a property called value, which contains the current value inside the input field. We can use this property to update the last name data property. Let's give this a whirl, shall we? Refresh the page and try updating the last name. After updating the input for the last name, the expression for the full name will get updated. By using bindings and listening for events, we were able to mimic the same behavior the V model directive performs. The difference being is that we can do more during the process if we need such control. Otherwise, these two do the exact same thing. The V model directive is described as being syntactic sugar. You're free to use either one as you wish. I recommend using the V model directive whenever possible because it means writing less code. In this lecture, we're going to quickly explore how we can pass on data with events. Let's say we wanted to pass along some data to our events. For example, a simple message to log into the console. Let's see how that would work. Let's go back to the template in the editor. Inside the directive, I'm going to pass on the following message: last name event triggered. Unfortunately, this will break our function. It's because we're expecting an event object inside the function. This is one point I want to highlight. If you don't pass on arguments to the function, Vue will pass the event object for you. Now that we're passing in our own arguments, we have to pass the event object manually. We'll pass it in as the second argument to the function. Vue will assign the event object a special name called $event. In our template, Vue will store the data related to the event in an object called $event. You must add the $ symbol because it's the name Vue will assign the event object to. The next step is to update the function in the application to handle the new arguments. Inside the update last name function, we're going to set the first parameter to message and the second parameter to event. Then, inside the function, we will log the message parameter. While we're at it, let's prevent the default behavior. It's normal to want to avoid the default behavior of an event to prevent unexpected behavior. We're dealing with a regular event object in our function. We can call the event.preventDefault method to prevent the default behavior. That'll do it. Refresh the page with the console opened. If we were to input some random gibberish, the last name will get updated. In the console, the message we passed into the function was logged. We can customize the behavior of our event handlers by passing in arguments. Vue will take care of calling the function for handling the event with the arguments you pass in. If we decide to add additional arguments, we will need to update our functions to accept the event object if we plan on using it. Vue will not do it automatically unless you don't provide arguments. We'll continue learning about events in the next lecture. There's one last thing I want to talk about when it comes to working with events in Vue. Let's go back to the function we defined in the configuration object. Inside the function, you'll notice we're calling the event.preventDefault method. This behavior is standard in most applications because you may not want the default browser behavior to affect your application. However, it's kind of repetitive and takes up room in our code. Luckily, Vue provides a way to simplify this. Vue has a feature called Event Modifiers. Event Modifiers do precisely what you think they do. They modify the way an event is handled. In the resource section of this lecture, I provide a link to the official documentation for event modifiers. Here is what Vue says about them. It is a very common need to call event.preventDefault or event.stopPropagation inside event handlers. Although we can do this easily inside methods, it would be better if the methods can be purely about data logic rather than having to deal with DOM event details. To address this problem, Vue provides event modifiers for v-on. Down below are some examples. Let's give one of them a shot. Back inside the template, we'll want to apply an event modifier to the input event. Event modifiers can be used by adding a dot after the event name. This dot is followed by the modifier you'd like to use. I want to stop the default behavior of the event. Vue comes with an event modifier called prevent. I'll add this modifier to our event. Adding this is the equivalent of calling the prevent default method in our function. We can remove the line where we call the prevent default method since we're using event modifiers. This makes our code look a whole lot cleaner and simpler. Let's give this one last test. Refresh the page. If I were to type in the input, everything would still work. As I type in the last name field, the full name is updated above. The console is still logging the message on every change. This is exactly what we wanted. That wraps it up for event modifiers. Handling events in Vue is painless. We can use modifiers to shorten the amount of code we would normally have to write. This allows us to keep our code tidy and organized. In the previous lecture, we discussed how to use events in Vue. Another set of events are keyboard events. Vue provides a lot of out-of-the-box in terms of keyboard event support. We can trigger an event on any set of keys or on a specific key. Let's look at an example. Let's say we wanted to add a field for a middle name. Inside the data object, we're going to add a new property called middle name. Its initial value will be an empty string. We'll update the full name function to include the middle name. The next step is to create an input field that will allow the user to update the middle name. Inside the document, in between the first and last name fields, we'll insert a new input element. Here's what we want to do. Rather than change the value on input, I want to change the value whenever the user presses the Enter key on their keyboard. We're going to listen for an event called keyUp. We'll want to invoke a function called updateMiddleName if the event is triggered. This function doesn't exist. We'll have to create it inside the methods object. Let's do that next. Inside the function, we're going to update the middle name data property with the value of the input field. The keyUp event we're using is triggered every time a user presses a key and then releases it. This means that the function is invoked on every key release. We're looking to limit which key will trigger the event. We only want to invoke the function if the key released was the Enter key. In the resource section of this lecture, I provide a link to the keyboard modifiers documentation page. Keyboard modifiers work similar to event modifiers. They modify how an event works, but with keyboard inputs. It's completely optional to use keyboard modifiers. By using them, you can listen for a specific key. Out of the box, they even provide some aliases for certain keys. You can find the full list in the documentation. They even have an alias for the Enter key. Let's use it. In the template, after the event, we'll add the Enter key modifier. If we were to test the input on the page, nothing would happen. The full name updates the second I press the Enter key. Typically, you would check for something like this with conditional statements. Vue takes a different approach by using modifiers to make things cleaner and simpler. There are times where we'll need to use a key that doesn't have an alias. In cases like these, we can use the code assigned to a key by the browser. In the resource section of this lecture, I provide a link to a site that will tell you the key code for any key. If I press Enter, I'll be presented with information about the key I pressed. In a huge font size, I'll be provided a number to represent the key I pressed. However, this is not the key code we need. The code we'll want to use is provided in the corner. The difference between the two is the number is deprecated in most browsers. The key code in the code box is the official code we need to use in our application. We won't be using this code because Vue sets an alias for the Enter key. If we were using a different key that didn't have an alias, we would use the key code in this box. Key modifiers are not limited to keyboard events. For example, let's say for the decrement function, we only want to trigger the function if the user clicks the button while holding the control key. That's easy to pull off. Switch over to the documentation for a moment. Under the alias keys, there's a section called System Modifiers. This is a list of aliases for a set of keys we can use as modifiers. The modifier we'll want to use is called control. Let's switch back to the editor. Inside the template, we're going to attach a modifier to the click event. The name of the modifier is called control. As you would expect, the expression inside will execute if the user is holding down the control key while clicking on the decrement button. Let's give it a test. After refreshing the page, we should check the console for errors. There are none this far. If I click the decrement button, the age does not decrement. After pressing the control key, does the value decrement like we want? So that's how you would use keyboard modifiers with events. We can use modifiers for events outside of keyboard events. Before I end this lecture, I'm going to revert this change. I'm not interested in having the decrement button only work if the control key is pressed down. In this lecture, we're going to learn about one last set of modifiers. We can apply special modifiers to the V model directive. There are 3 modifiers available. Let's explore each one. We'll continue working on the same project. In our application, we have a data property for the age. The age can be updated by clicking on the increment and decrement buttons. That's fine and all, but we should provide an option for allowing the user to modify the age directly. Let's create an input that's bound to the age data property. Open the index.html file. We'll add an input below the last name. The input will be for the age. Let's add a label to help us identify this input. Lastly, we'll add the V model directive to the input element. The property it should be bound to is the age property. Let's head to the browser to view the app. We can see the input appear below the other inputs. It works great. If we change the value in the input, the age is also updated. We can even click on the buttons to modify the value. One thing that's not noticeable is the type of value we're working with. Let me show you what I mean. Switch back to the editor. Above, we're outputting the age inside a pair of paragraph tags. Before the age, I'm going to add the type of keyword. The type of keyword will instruct our application to output the data type of the variable. Let's go back to the page. Instead of seeing the age, we'll see the data type get outputted. The data type for the age is number. It's because the original value is a number. If I were to press the buttons, the data remains the same. However, if I type in the input, the data type is converted to a string. It doesn't matter if the actual value itself is a number. The reason this happens is because we're using an input. Input elements will always return a string. Even though the input is bound to a value that has the number data type, the browser will convert it to a string. This is the default behavior. It doesn't really affect us at the moment. It can lead to issues down the road. There is one simple way to fix this problem. Let's go back to the editor to find out how we can resolve this issue. There are 2 things we should always do whenever we're working with numbers in an input field. First, we should set the type of input. On the input for the age, we're setting the type to text. Let's change this to number. Setting the type is an HTML feature. It's not specific to Vue. Regardless, it's still something you will want to set when working with numbers. By setting the type attribute, the browser will prevent the visitor from typing non-numeric characters. That lowers the possibility of an error occurring in our application. While it's a great way to add constraint, it doesn't solve our issue. The browser will continue to convert the type to a string. We can convert the type back to a number by using a modifier. The V model directive can use 3 modifiers. One of them is called number. Let's add it to the directive. The number modifier will perform a type conversion. The value will be converted to a number type. Let's view the browser to confirm this behavior. If I type any number in the input for the age, the data type will remain a number. Great. The number modifier will allow your data properties to hold the number data type. This behavior can prevent unexpected issues when trying to perform calculations. There are two other modifiers we're going to quickly look at. They're the lazy and trim modifiers. Let's go back to the editor. We'll apply both modifiers to the input for the first name. It's not required to apply both modifiers to a directive. However, it is an option. The trim modifier will remove excessive white space from a value. It's the equivalent of calling the trim function on a string. The lazy modifier will change when the data property is updated. Normally, the data property in our application is updated on every key press. The lazy modifier will delay the change until the visitor has finished typing in the input and moves away from it. This modifier can be useful if you want to perform less updates on the document. Let's go back to the browser. If we were to type into the input for the first name, the name doesn't get updated. The update won't occur until I click away from the input. I'm also going to add extra white space before I do so. After moving away from the input, the first name changes. The white space is also removed. We're able to change the behavior with these two handy modifiers. That wraps it up for this lecture. We'll continue in the next one. One of the more difficult concepts for a beginner to grasp is computed properties. It sounds like a complicated feature, but luckily it's like a light switch. Once you learn it, then you pretty much know it forever. It's not as difficult as you may imagine. Before we jump into the code, I want to define the word compute. I know some of you are not native English speakers, so you should understand what this phrase means before moving forward. Put simply, compute means to calculate something. This can be any sort of calculation from basic math to concatenating strings to form a full word, phrase, or sentence. Anytime you have to perform calculations on a value or multiple values, you are performing a computation. Combining this with the word properties gives clarity as to what this means. Computed properties are properties that are calculated in some sort of manner. Alright. Just keep that in the back of your mind as we discuss how and what computed properties are in relation to Vue. If we were to look at our Vue instance, would you be able to tell which bit of code would be considered a computed property? If you guessed the full name method, you would be correct. The full name method calculates the full name by combining the first, middle, and last names in the data object. The full name method works better as a computed property. It may not seem like it, but using a method for this sort of situation is costly and inefficient. Let's explore why that is. This method currently works fine. We don't get errors in the console, nor does it give the rest of our application a problem. However, something is going on behind the scenes that we're not seeing. Let's switch back to the editor. Right before I return the value, I'm going to log a message with the console.log function. The message will say the following. Full name method was called. I'm going to comment out the message inside the update last name method so that we don't see it in the console. We want to shift our focus to computed properties. Let's check out our app. Make sure you have the console opened. I'm going to update the first name input field. After inputting a value, the full name is updated. Inside the console, the message inside the full name method was logged. That's to be expected since the first name data property was updated. Therefore, the full name method would have to be called again for the latest changes. Now let's see what happens if I were to click on the increment or decrement buttons. Not only does the age get updated, but the full name method gets called again. This happens regardless if we updated the properties for the name. This is the first problem with using a method for calculating a property. Whenever any of the data properties are updated, Vue will render the template again onto the page. This means that any methods in the template are recalled during the process. To be more precise, this applies to methods that are invoked immediately. We do have methods that are called when an event occurs. We don't have to worry about them being called on every render. The full name method is an example of a method called when we don't want it to. It's more desirable for it to be called only when it's necessary. That's possible thanks to computed properties. Let's learn how to use them. Switch back to the editor. Inside the Vue instance, we're going to create another property in our object called computed. It'll be on the same level as the data and methods objects. The value is an object. Inside this object, we can define anything we want. I want to convert the full name method into a computed property. Converting this is as simple as moving the method into the computed object. I'm going to change the message inside to say the following: full name computed property was called. There's one last adjustment we'll need to make. Inside the template, we have to remove the parentheses from the expression. This may seem strange, but Vue treats your computed properties as data. I'll explain more in a moment, but let's check if this works. Let's view the application in the browser. Everything will work normally. If I update the first name, then the full name updates too. The message we logged in the function appears in the console. However, this time, if I were to update the age, the message doesn't get logged. This means that the function doesn't get called even when the age is updated. There is a benefit to using computed properties. Vue will cache the values of computed properties. Let's discuss what happens when a data property is updated. First, it'll scan the function of the computed property. It'll check what data properties you're using inside the function. If any of those values change, Vue will rerun the function and update the value. If a data property was updated that wasn't used inside the function, Vue will not bother updating the value. Therefore, we save on performance and execution time. Vue is smart enough to know when to call the function based on the data used inside the function, even if it isn't actively used. Let me show you what I mean. Back inside the full name function, I'm going to add this.age. I'm not going to bother doing anything with the value. I won't reset or change it. Normally, we wouldn't do something like this. This is just an example. Once you have that set, refresh the page one more time and update the first name. The message is logged in the console. Now I'm going to update the age. This time the message does get logged. It's because we're using the age data property in the method. Vue was able to pick up on that. Since the age gets updated, then the function gets called. I'm going to remove the age from the function because it's unnecessary to have it there. I want to talk a little more about how computed properties are used in terms of how we write it. The first question is, are computed properties data or methods? The answer is a combination of both. The data property is used to store single values. You can store objects and arrays as well. It's not the kind of object where you would store functions. If you want to store functions, you would use the methods property. If you have a function that calculates a value, you would use a computed property. Let's discuss the differences between methods and computed properties for a moment. With methods, you are allowed to calculate values. We can use them in expressions if we want to. In fact, you could use methods exclusively. However, you would lose out on the performance gain that computed properties provide. Methods provide a lot of flexibility. You can make requests, update elements, etc. With computed properties, they serve one purpose, or at least they should, and that is to calculate a value. Unlike methods, you are always expected to return a value. You're free to take other actions, but you must always return a value. This is because the value is what's stored in Vue. We can even inspect this. Back inside the browser, I'm going to switch to the Vue Developer Tools. Clicking on the root element will show me the data inside my application. A new category will appear called Computed. The full name will be set to the computed value. Vue is storing the value, not the function. That doesn't mean the function is lost forever. It's stored elsewhere. Whenever the value needs to be updated, the function for the computed property is called. This is why we don't add the parentheses in our expressions. It's because we're retrieving the value, not calling the function. The function is called internally by Vue automatically. Another thing you need to be aware of is that you cannot pass data onto the function. If you need to pass on data, then you may want to consider using a method. That does it for computed properties. There's a lot of magic happening behind the scenes to make computed properties work. Using computed properties is simple thanks to that magic. Computed properties can seriously boost the performance of your application with little work. I recommend you play around with them more before moving on to the next lecture. In the resource section, I provide a link to more information about computed properties. I definitely recommend giving it a good read. So far, we've learned about the data, methods, and computed objects in the instance. There is one more property that allows you to manipulate data, which are called watchers. Watchers watch your data for changes. Whenever a change occurs, you can run a function to execute additional logic. In a sense, it's a way to hook into the process of when a value is updated. Something I want to note is that watchers aren't used often. You will most likely use them a few times in your application. It's not something you will use consistently. Throughout this course, you will see real use cases for watchers. Let's learn how to use them. Watchers are pretty easy to implement. On the same level as the data and methods properties, we're going to add a new property called watch. This property will be set to an object. The object will contain a list of properties to watch for. What properties can we watch? It can be any of the properties on the Vue instance. This includes your data and computed properties. The key name must correspond to any of the key names inside the instance. Let's listen for changes to the age property. The value of this property will be the function we want to execute when a change occurs. There are two arguments we can use in the function. They're the new and old values, respectively. We can do whatever we want in the function. We're not obligated to return a value. Regardless of what you do inside the function, Vue will still update the value. We're simply running a function during that process. Developers use watchers to perform additional actions whenever a value changes. This is especially true whenever you want to perform asynchronous tasks. Computed properties are similar to watchers in that they watch our data for changes. It can be confusing as to what the differences are between computed properties and watchers. Computed properties can never be asynchronous, or at least they shouldn't be. Vue expects a value to be returned from the computed properties function. However, watchers don't bear that responsibility. You have the freedom to perform asynchronous tasks. For this example, let's say I wanted to revert the age to its original default value after 3 seconds. Inside this function, we're going to use a setTimeout function. Inside of it, we'll set the age property to 20. Let's give things a test. In the browser, we'll try to update the age. After 3 seconds, it'll revert back to 20 because the watcher function will run when we change the age. By using watchers, we can run additional logic when a value changes. Like I said in the beginning, watchers aren't used as much as data, methods, or computed properties. I wouldn't stress so much about using them. You will learn through experience and throughout this course on when to use them. That wraps it up for this lecture. We'll continue in the next one. We've learned a lot so far. There are still a few things I want to dig into before we dive into an exercise project. In this lecture, I want to talk more about binding attributes. Specifically, I want to get into working with the class attribute. It's common to apply styles conditionally based on the data in our app. In the resource section of this lecture, I provide a zip file with some starter files. We'll be moving away from the previous code base. It's starting to get cluttered. I want to focus on this concept alone. Download, unzip the files, and view them in your editor. Pause the video if you need to. There's nothing special going on in these files. We have the typical HTML, CSS, and JavaScript files. I've already gone ahead with preparing a Vue instance for you. Here is what it will look like in the browser. It's a circle that says, "Hi." Above it is a checkbox. It's non-functional at the moment. We'll want to make it functional by changing the background color of the circle if the checkbox is ticked. Back in the editor, inside the CSS file, we have a class called purple, which will change the background color of an element to purple. How do we dynamically add this class to the element? We can dynamically add a class with binding. We'll switch over to the document. We'll bind a class attribute on the div tag with the class circle. I'm applying two class attributes to the same element. Vue is smart enough to merge them after the template has been processed. We don't have to worry about conflicting issues. The value for this attribute will be an object. The object can contain a list of classes to apply. The key name will represent the class name. The value will be the condition. If the condition is true, the class will be added. Otherwise, it'll be removed. The class we want to add conditionally is the purple class. The value will be the data property isPurple. This property doesn't exist, so let's add it in. Back in the script, we'll define the data function in the configuration object. Inside the data object, we'll add the isPurple property. The initial value will be false. Because the value will always be false, the class will never be applied to the element. We'll want to change that by using the checkbox to toggle the data property. Back inside the document, we're going to use the vModel directive on the checkbox. The vModel directive will work on all form elements, including the select and text area elements. We're going to set this to isPurple. That will take care of toggling the value. If the box is ticked, then the value will be toggled to true. We're finished with binding the input. Back inside the browser, we'll refresh the page. If we look inside the console, we won't find errors. That's great. The initial color of the circle will be green. If we were to toggle the checkbox, the circle would toggle from green to purple. By binding the class attribute, Vue can help us manage the classes for an element. We can use object syntax for dynamically binding classes to elements. In the object, the key names represent the class names. Their value will be the condition to check if the class should be added to the element. Vue will take care of constantly checking the data for changes. It'll swap classes whenever data changes. There is a slight problem with this approach. We're checking for one class, but this can grow to be several classes. Our template would become difficult to read the more classes we add. Luckily, we can use computed properties to solve this dilemma. We're going to copy this object. Then in the Vue instance, we're going to create a computed property called CircleClasses. Inside the function, we'll return the object we copied earlier. We'll need to make one slight adjustment to the object. The isPurple condition will need to be updated to this.isPurple since we're using this in the Vue instance. It's a minor change. Next, inside the template, we can remove the object. We can replace it with the following expression, CircleClasses. Let's go back to the page and refresh it. Toggling the checkbox will toggle the background color like before. We're experiencing the same behavior, but now it's easier to read and format the object. We also gain the performance boost of using computed properties. Computed properties update whenever the data it uses is updated. Let's keep playing around with this. Not every class has to be conditionally checked. Instead, you can jump around different classes. Let me show you what I mean. Let's go back to the editor. We're going to create a drop-down below the checkbox where the text color can be white, black, or orange. For the color white, I left the value blank because the default color is already white. We don't need to specify a class. I've defined classes for changing the text color to black and orange. You can find them in the CSS file. We'll need to bind this dropdown to a value in our data object. We'll use the vModel directive. We'll set it to the selected color property. This data property doesn't exist in our application. We'll need to define it. Inside the data object, we'll define this property. The initial value will be an empty string. The last step is to bind the value to the circle element. Inside the template, we'll change the class binding to selected color. Alright, let's give it a test. Refresh the page. The circle will appear as normal. If I were to select a different color in the dropdown, the text color would change. This is exactly what we wanted. However, if I were to tick the checkbox, the color change doesn't get applied. This is because we're passing in one expression. Unfortunately, we can't use the object syntax since we're not checking if a class should be added. We could refactor the object to check if a specific class should be added, but there's a better solution. Switch back to the editor. Inside the template, we're going to update the class attribute to be an array. For the second value in the array, we're going to pass in circle classes. Vue will loop through the array. It'll apply the first item in the array as a class. The second item will have its properties iterated. It'll run through each condition to determine whether a class should be applied or not. By using an array, we get the best of both worlds. Let's give this application another test. Refresh the page and try toggling between both input fields. No matter what combination we choose, the classes will work as intended. You're free to use array or object syntax. You can even choose neither. It's acceptable to bind one value. It depends on the situation you're in. Alright, that's enough for now. Let's move forward. In this lecture, we're going to look at how we can bind the style attribute on an element. In some cases, you may want to apply stylings directly on the element. For example, let's say I wanted to change the size of the circle. There are three properties we'll need to change: the width, height, and line height. Creating a set of classes that would cover every size possible would be time-consuming. It would be much better to set the styles directly on the elements. Back in the editor, inside the data object, we're going to create a property called size. Its initial value will be set to 150. We're setting it to 150 because that's the initial value in the CSS class. Then, inside the template, below the dropdown, we're going to create an input field with the number type. We'll be dealing with numeric values. The number type will prevent the user from entering non-numeric characters into the input field. We're going to use the vModel directive once again to bind the value to this input field. We'll bind it to the size data property. The last step is to update the circle to use these values. Inside the element, we're going to bind the style attribute. We'll set this attribute to an object. Unlike before, where you're performing conditional checks, we'll be setting the CSS properties dynamically. If I want to set the circle's width, then I would add that in as a property. The value is what will be used as the CSS value. We're going to set this property to the size data property with the pixel measurement. I'll do the same for the height as well. This will make the circle nice and even. However, there is one additional property I'd like to set. In order to make the text vertically aligned, we'll need to set the line height property. If you set the line height to the same value as the height, the inner text will be aligned in the center. However, typing line height is not a valid property name. Therefore, there are two solutions we can use to add this in. The first solution is to wrap it in quotes. This solution is valid and will work. Alternatively, you can remove the quotes and camel case the name. Vue will detect the camel casing. It'll take care of lowercasing the word. It'll add dashes between each word. Either solution works. It's all preference in the end. I prefer to use camel casing because it's easier to read. We're already typing this inside of a string where there is no syntax highlighting. Using quotes can make things difficult to read. We'll set this property to the size data property with the pixel unit measurement. Be sure that your code matches mine. I'm going to refresh the page one more time to test the application. We'll see the input field with an initial value of 150. If I were to increase or decrease the amounts, the circle would adjust accordingly. You can open the Elements panel in the Developer Tools to view the changes in real time. This effect is cool to see. It's possible thanks to Vue. Similar to classes, we can use the array syntax to apply a list of stylings. Let's give it a try. Switch back to the editor. Inside the style attribute, we'll wrap this object with an array. Then, after the first object, we'll add in another object with a transform property. The value will be a basic rotation. We'll take the time to format the code. A lot is going on inside this attribute. At this point, it may be better to use a computed property. I'll leave that as an exercise for you to do. We are using two objects for applying stylings to the element. For the most part, you usually wouldn't have to do this, but it's nice to know you can pass in multiple objects for styles. Let's refresh the page to check out the result. The circle will be tilted 30 degrees. This value isn't dynamic, but it still gets the point across that you can pass in multiple objects with separate stylings if you ever need that kind of control. In the resource section of this lecture, I provide a link to the official documentation for adding classes and styles to your elements. This page goes over everything we've covered thus far. I recommend giving it a good read before moving on to the next lecture. In this lecture, we're going to learn about conditional rendering. Conditional rendering is when elements are added or removed from the document based on a condition. If a condition is truthy, the element is added to the page. Otherwise, the element is removed. Previously, we talked about how to bind classes and stylings to an element. We can use CSS styles to hide an element on the page. This solution can be implemented by toggling the display or visibility properties on an element. While it's a valid solution, there's an alternative solution from Vue for toggling elements. In the resource section of this lecture, I provide a zip file with some starter files. Download it, unzip the contents, and point your editor to those files. Pause the video if you need to. There's not much going on with what I have provided you. In the HTML file, we have the usual div element with the ID app. In the script file, we're creating a new instance. First, we'll look at how to add or remove an element based on the data inside the Vue instance. In the template, we'll add a paragraph tag. The contents will be the following: showing v-if directive content. The goal is to toggle the element by using a directive called v-if. This feature is what Vue calls conditional rendering. If a specific condition is met, the element will be rendered onto the template. We'll apply the v-if directive to the paragraph tag. The value must be the condition. We'll set the condition to the following: mode equals 1. The mode property does not exist. Let's create it inside the data object. In the script file, we'll define the data function inside the configuration object. Next, we'll create the mode data property with an initial value of 1. Time to give the app a test in the browser. The paragraph tag renders onto the document without a problem. If we were to view this in the Elements panel, we would notice that nothing unusual is applied to the element. Vue can keep track of this element based on the data. We're going to switch to the console panel of the Developer Tools. We're going to access the Vue instance through the VM variable. We'll update the mode data property to 2. This value is random. I'm not choosing the number 2 for any reason. After reassigning the value, the paragraph disappears. This is because the condition is no longer true. Therefore, the element gets removed. We can even check the Elements panel to check if it was removed. This is something important I want to highlight. Vue will not hide the element. It will altogether remove the element from the document. I'm going to switch back to the console and reassign the value back to 1. The paragraph element is back. If we were to check the Elements panel, the element was added back in. It appears in the same spot with the same content. This functionality is great. We don't have to use CSS tricks to hide the element whenever we don't want it to appear. Vue will automatically keep track of where the element was placed initially. It'll add or remove elements based on the conditions you set in the directives. The v-if directive is not the only conditional directive we have at our disposal. Back inside the editor, we're going to add 2 more sets of paragraph tags with some dummy content. The second set of paragraph tags will have the v-else-if directive applied to it. This directive can only be used after an element that is using the v-if directive. For example, if we inserted another paragraph above this element, this will break the application. Vue would throw an error because it's expecting the element before to have the v-if directive applied to it. I'm going to remove this since we don't want an error. The value for the v-else-if directive must be a condition that evaluates to true or false. We're going to check if mode is equal to 2. This condition will be checked if the condition inside the v-if directive returns false. If the first v-if directive returns true, this will not be checked even if the condition for this directive is true. For the last paragraph element, we're going to apply the v-else directive. We don't need to add a condition because Vue will not check it. This directive will make the element appear on the page if previous conditions fail. Once again, we are required to have this element appear on the same level and after the other conditional directives. It works the same way as JavaScript conditional statements. One more thing. We're not limited to what elements we can use. The conditional directives don't have to be applied to the same element. We can use different elements. We can change the second paragraph tag to an h3 tag. This structure is considered valid because it's still at the same level. However, I can't wrap it with another tag like a div tag. Even though the condition is provided after the v-if directive, the fact that it isn't on the same level will throw an error. I'm going to undo this. Those are some limitations you should be aware of before using this directive. Before we test our app, we're going to create a drop-down below everything. We'll add an option for each conditional directive. We want to be able to update the mode data property without having to use the console. We're using the vModel directive for updating the mode data property. Make sure you have the same as me before continuing. I'm going to refresh the page. The content in the first paragraph element will be visible. If I were to set the mode property to 2, then the h3 element will appear, thus proving that the elements don't have to be the same. Lastly, we'll set the mode property to 3, which will show the element with the velse directive. This directive will only be triggered if all previous conditions failed. I'm going to switch to the Elements panel. I'm going to toggle between the modes using the drop-down. As I do so, Vue can handle adding and removing elements from the document. This is a powerful feature that takes very little work on our side to make function. Let's take things a step further. Sometimes you want to display multiple elements without having to use numerous conditions. Let's look at an example. In the document, let's say we want to render a paragraph and h3 tag conditionally. We'll add a paragraph tag above the heading. This tag will break the conditional directive chain. Vue will throw an error if we do this. But let's say I wanted both elements to appear if the second condition we have is true. The obvious solution would be to wrap both elements with a div tag. Then, we can move the directive to the div element. This solution will work, but there's one problem with it. It changes the structure of our document. It may be fine if you're working on a simple app. If you're working on a larger app, it may be necessary to maintain the document's structure because of CSS. The CSS may expect the document to be structured a certain way. Your styles may not be so forgiving if you change the structure of the document. If the HTML structure changes, you may have to make changes to your CSS to accommodate this scenario continually. That's not very fun, and it can make our document more cluttered than it has to be. We can maintain the same structure by replacing the div tag with the template tag. This is not an official HTML element, but it is a valid Vue element. Vue will render the contents of the template tag without rendering the tag itself. As a result, we'll still be able to keep our HTML structure without ruining our styling's integrity. Let's see what this looks like. I'll refresh the page one more time. If I were to update the mode property to 2, both elements inside the template tag would appear. That's exactly what we wanted. If we were to switch to the Elements panel of the Developer Tools, we would see both elements appear without the template tag wrapped around it. Vue will take care of removing it while still allowing the content inside to be rendered. This is one way of handling conditional rendering. The vif, velsif, and velse directives can handle conditional rendering. In the next lecture, we'll look at an alternative solution for conditionally rendering content. In this lecture, we're going to learn about the vshow directive. Vue provides an alternative solution to conditional rendering. Sometimes you'll want the element to stay exactly where it is, but hide it with CSS. It's possible to perform this task by binding styles and classes. However, Vue provides a solution out of the box for this specific task. Back inside the template, we're going to add an italics element with a simple message. We're going to apply the vshow directive. This directive expects a condition. We're going to set the condition to the following: is mode equal to 1? By default, the element should appear based on the condition. Let's give it a test. If I refresh the page, the element will appear without a problem. If I were to switch modes, it would disappear. It works similar to the vif directives, but with one noticeable difference. Viewing the Elements panel shows that the element was not removed from the document. Instead, Vue will apply the Display CSS property. The value for this property will be none. This value hides the element from view. That's the main difference between vShow and vIf directives. If I were to set the mode back to 1, the stylings are removed. We've learned about the two ways to render elements conditionally. There are quite a considerable number of differences you should take into account whenever using them. Let's start with the vShow directive. Unlike the vIf directive, the element does not get removed if the condition turns out to be false. Instead, the element will remain in the document. The display CSS property will be set to none. This value will hide it from view. You're limited to using the vShow directive alone. It will not work with the template tag I showed you, nor will it work with the vElse directive. Something you should take into consideration is the performance you may gain or lose from using it. During the compilation of the template, Vue has to decide what has to be rendered. For every element added, you take a small performance hit. It isn't massive. It's not like your users will notice. However, it is a performance loss. After the element is loaded, toggling the stylings of an element is a reasonably cheap cost. It's quick and easy. Therefore, using the vShow directive is expensive on load but cheap when it comes to toggling an element's appearance. Next, we have the vIf directive, which does support the template tag, vElseIf, and vElse directives. Unlike the vShow directive, it will altogether remove or add the element based on the condition. One of the main advantages of this is that the directive is lazy. If the condition evaluates to false on the initial page load, the element will not be added to the page. The browser doesn't have to waste time painting the element. This saves resources on the client's machine because the element is never added to the document. However, it is expensive on toggles. As you can imagine, adding or removing elements in the exact same spot every time is not an easy or cheap task. It does require a bit of power to perform. If you're dealing with a few elements, it isn't that big of a deal. On the other hand, if you have hundreds of elements, you will definitely feel it. Overall, I wouldn't worry about it a lot. Either solution is viable in any application. My personal opinion is that you should use the vShow directive if the element is toggled frequently. Suppose the element is rarely toggled from view. The vIf directive is more optimal. At the end of the day, it's up to you to decide which is the best one to use. In the resource section of this lecture, I provide a link to the official documentation page for conditional rendering. It'll go over everything we've covered so far about conditional rendering. There are additional examples and use cases available on this page. I definitely recommend you give it a good read before moving on. In this lecture, we're going to learn how to render a list. If you think about it, lists are used for a lot of things. Menus, users, posts, etc. It's a common task in most applications. Vue can help us loop through an array of items to render a list of elements. In the resource section of this lecture, I provide a zip file with some initial files. Download it, unzip the contents, and point your editor to the files. Pause the video if you need to. There's nothing special going on in these files. Inside the JavaScript file, I have two data properties. We'll be looping through them. These two properties represent the three scenarios you'll come across when rendering lists. You'll either want to loop through an array of objects, or loop through an object's properties. We can handle these three scenarios in Vue. For our first example, I have an array of birds. Inside the template, we're going to create an unordered list with one list item. To loop through an array, you have to use the v_for directive. I'm going to apply this to the list item. This directive will allow us to loop through an array. The expression will be slightly different than what we've dealt with so far. Vue requires a specific format for the expression. We're going to input the following: bird in birds. The format is as follows. We need to provide an alias to reference the item in the current iteration of the loop. For instance, the first item in the array is pigeons. So in the first iteration, the name bird will represent the value pigeons. In the second iteration, it'll be eagles, so on and so forth. Afterward, we need to type the in keyword. This keyword will tell Vue that you're ready to tell it what array it will loop through. Lastly, we pass in the name of the array to loop through, which is the bird's data property. Be aware that you're not forced to name your reference anything specific. We could have called this flying creature if we wanted to. It's common practice to name the alias as the singular version of the array name. That's the basics of using the v-for directive. We can begin outputting the data. Inside the list item, we're going to create an expression. The expression will be bird. Vue will take care of performing interpolation on this expression. It'll replace it with the current item in the array. We're not limited to using expressions inside the element. We can apply directives to the element. We can use the bird reference. For instance, we can bind the class attribute to the bird alias. We can't use the bird reference outside of the element. We're restricted to using it on or in the element. This would include children elements if we had any. It's time to test the app in the browser. If we did everything right, we will see the list of birds on the page. Inspect the elements and search for the list items. Each list item will have the class attribute applied to it with the bird's name as the class name. These don't do anything, but I wanted to show you that you can use the reference in directives or attributes as well. You're not limited to grabbing the value. Sometimes you'll want to grab the index in the loop. Back inside the template, we're going to wrap the bird alias with parentheses. If we're solely interested in the value of the current iteration, we can provide an alias for the value. However, if we'd like to grab the index and value, we'll need to wrap this part of the expression with parentheses. Vue requires we provide an alias for the name and index. We're going to call this index. We're not required to use this name. We can call it whatever we want. It's common practice to call it index. As a result, the alias bird will be used to represent the value in the current iteration, whereas the alias index will be used to represent the current index of the item. We'll be able to use the index in our loop. We're going to add an expression after the value. The expression will output the index. Let's refresh the page to see what this will look like. The index, along with the name of the bird, will appear on the list. Vue makes it dead simple to loop through an array of items. Next, let's begin looping through an array of objects. I want to quickly review the data in the Vue instance for a moment. We have a data property called people. This property is an array of objects. Each object is storing an individual's name and age. We want to display this information on the page. It's very similar to the last example. Switching to the template, we're going to create a horizontal line. Under it, we'll create another unordered list. We're adding this in to help make things look cleaner. If we want to loop through the objects in the array, we'll have to use the v-for directive. We'll add the directive to the list item element. The expression will be the following: person in people. We can begin to output the contents of the object. We'll create two sets of div tags to output the name and age properties. To access the name and age, we can use dot notation. It's the same as accessing a property in a regular JavaScript object. It's not much different. Let's give things a test. If I were to refresh the page, the list of people would appear below with each person's name and age. This is exactly what we wanted. However, there is a bit of a problem. What if we had dozens of properties to display? Having to type each property name would be time-consuming. Luckily, The v-for directive is capable of looping through objects as well. We're not limited to looping through arrays. Back inside the template, we're going to remove the second pair of div tags. Then, we're going to apply the v-for directive to the div element and set the expression to value key in person. The alias names we set in the parentheses represent slightly different values than when we worked with arrays. In the previous example, the first name would represent the value in the current iteration. The second name would represent the index. However, when you're looping through properties in an object, the first name will represent the property's value, and the second name will represent the key name of that property. Therefore, the index is no longer available to us. If we want to use the index, then we'll need to add one more name. I'm going to set this to index. We'll be given access to the value, key name, and index. We're going to output all three of these inside the current loop. We're essentially looping inside of another loop. It's not uncommon to have to do things like this. It's a completely valid solution. Be careful when performing nested loops. It does require more time to execute. It won't be noticeable in our application, but in larger ones, you'll definitely see the performance difference. Let's give things a test. Refreshing the page will result in the same thing as before. We have a list of people. Each person has their name and age outputted. Fantastic. Keep in mind that you're not required to use all these values. You can stick to grabbing the value of the property. If you don't need the key name or index, it's not required to provide aliases. Keep your code simple. There is one more thing I want to show you before we end things. There is a problem with the loops we currently have. Let's focus on the first loop. You may want to implement a feature that will allow your users to filter the data. Sometimes you may even want to add or remove things from the current array. In any of these situations, you may want to keep track of each item. Currently, that's not possible. You may be thinking, what about their index? That works at the start, but the index isn't wholly reliable. For instance, the last bird in this array is parrots. The index of this bird is 3. Each item in the array will have a unique index, but that doesn't necessarily mean that the index is permanently associated with that item in the array. Let me show you what I mean. I'll open the console for a moment. I'll input the following, vm.birds.shift. This function will remove the first item in the array. Looking at the list again, you'll notice the index for parrots has changed to 2. The index is still unique, but it has changed. Vue is capable of keeping track of these changes for you. For example, we'll change the name of the bird by using the following, vm.birds2 equals robins. This line will change the bird in the second index from parrots to robins. This works without a problem. However, something as simple as this can prove to be problematic down the line. Inside a more complex application, items in the array can move around due to additions or removal of data. This can confuse Vue. It can even lead to an update where you don't want an update to occur. This issue can happen because Vue has lost track of certain elements. That's not what we want to happen. Luckily, there's a way to keep track of items in arrays even if they move around. Back inside the template, we're going to bind the key attribute on the list item. The value for this must be a unique name for each iteration in the loop. We have a basic array where each bird has a unique name. We can set this to bird. Now we have a way to uniquely identify an item in the array even if any of their positions change. Let's give this a try. I'm going to switch back to the browser and refresh. The list will work as usual. You may be a little confused because we can't see the difference in this example. Once again, this is useful in more complex applications. In the next lecture, I'll dive more into why this is important and provide a more realistic example. If you already understand without having to see the problem, you can skip that lecture and move right along. In the resource section of this lecture, I provide a link to the official documentation page for list rendering. I recommend you give this a read before moving on. It also offers a better explanation of the key attribute. If you don't understand, then don't worry. I'll clear everything up in the next lecture. In a previous lecture, I ended things off by talking about the key attribute. It's recommended that you add it to the element that you're looping through. I wasn't completely apparent why you would want to add it. In this lecture, I want to provide absolute clarity as to the reason why you would want to use the key attribute. The main reason is that it'll prevent strange behavior from happening. Let's first look at the problem. Then, we'll see how the key attribute solves that problem. In the resource section of this lecture, I provide a zip file with the files you'll need. Download it, unzip the contents, and point your editor to those files. Pause the video if you need to. Inside the template, we have a div tag with the class card. There's a header and paragraph where the header will contain the name, and the paragraph will contain a message. We'll be looping through this element in a moment. Inside the JavaScript file, I have initialized a Vue instance. Inside the data property, I have a list of people with their names and a message. As for the CSS, I've added a bit more CSS than usual. Nothing in here is related to Vue, but I decided to add more visual information so that things are clearer for this lecture. Alright, let's begin working on the application. It's going to be simple. All I want to do is loop through the people data array and render it onto the template. We'll need to use the v-for directive to loop through the data. Inside the template, we're going to apply the v-for directive to the div tag with the class of card. The expression will be person in people. Next, we'll replace the static text with their respective expressions. The heading will be person.name, and the paragraph will be person.message. We're not going to apply the key attribute yet. Right above the list of people, we have a button. If clicked, I want to move the first person on the list to the bottom. Therefore, we're going to listen for an event using the @ character. The event to listen for is called click. The name of the method to run will be called move. This method doesn't exist, so let's create it. Back inside the Vue instance, we'll add the methods object. After adding it in, we'll define the move function. The move function will perform one simple task. It'll move the first item in the array to the end of the array. That's pretty simple to do. We'll create a variable called first and set it to this.people.shift. As you may know, the shift method will remove the first item in the array and then return that removed item. We can re-add the item by using the this.people.push method and pass in the first variable. This function is how we can move the first item of the array to the end. Let's refresh the page to see if it works. You should have something similar to me. The list of people gets outputted without a problem. If I were to click the button, the first person would move to the bottom of the list. I can click this as many times as I'd like, and everything will work as expected. Everything seems to be working fine. That's because we have a basic UI. Things can become more complicated the moment we add some interactive elements like an input. Let's see what happens if we were to add an input field. Back in the document, we're going to add an input field after the paragraph tag. We're not going to add any events, bind any attributes, or make it functional. For the sake of simplicity, we're going to leave it as an ordinary input field. Let's try testing things out again. We'll refresh the page one more time. Everything works as expected. If I press the button, then everything moves accordingly. Or so it seems. The first person is now Rick. Before I press the button, I'm going to fill in the input field for Rick randomly. If I press the button, you would expect the input to move with Rick, but that's not what happens. Rick moves to the last spot, but the input field doesn't. The text we had inside the input remained. It should have moved down below. Instead, the input now belongs to Amy. What's the problem? Vue is making a performance decision. It'll look at what's happening and decide the best way to approach this. For the most part, we've benefited from this. Vue will notice a change in the array, but it'll also notice that there are 3 items in the array and 3 items in the template. As I stated previously, adding and removing elements from a template is a bit of a performance hit. Therefore, Vue will not move the elements in the template. It won't remove the element, nor will it add a new one afterward, just like we're doing in our JavaScript. Instead, it'll move the data around. What do I mean by this? Currently, the first element has the name Amy. By pressing the button, Vue will not move the element. It will instead move the text itself to the bottom. Only the data is moving around, not the elements. That worked fine previously, but now we have a dilemma. Each card has an input that doesn't get moved. We want the input to move along with the data. The recommended solution is to use the key attribute. Let's try using that, and then I'll explain what's going on. Back inside the template, we're going to apply the key attribute to the card element and bind it. The value should be a unique value on each iteration. Typically, this would be an ID. At the moment, we don't have an ID, but the name is unique to each item in the array. We'll use that as an ID. We'll pass it in. Alright, let's see if this fixes things. I'll refresh the page once more and try moving things around. Everything works as before. We'll input something into John's card and move it around. Vue has not only moved the data, but it has also moved the input. It doesn't matter how many times I press the button, John will be moved appropriately along with the input. Alright, so what's going on this time? Vue will notice that you have a key attribute added to the element. This attribute tells Vue that the data belongs to this element. Therefore, everything inside this element is now related to the person it's displaying. Whenever the data gets updated, and the data has to move around, the elements will also move with it. Even if there's no data attached to the input field itself, since it's inside the element, it'll get moved as well. There are 2 ways that Vue will move things around. Without the key attribute, Vue will move the data around, but not the elements themselves. This process is what Vue calls patching. By adding the key attribute, we're forcing the elements to move. This process is more costly in terms of performance. However, the main benefit is that we don't have to worry about strange behavior. In the resource section of this lecture, I provide a link to more information about keys for list rendering. The overall gist of this is that you should always use the key attribute. The only reason to not use a key is when the list is simple. However, once you start introducing animations, forms, and components into the mix, the key attribute will be a lifesaver. It'll relieve you of many headaches. I always recommend you use it. If you ever experience any elements not behaving the way you expect them to inside a loop, try to check if the key attribute is applied. If not, then add it in and see if that solves your problem. That wraps it up for this lecture. We'll continue in the next one. In this section, we're going to put some of what we have learned into practice. We'll create a tool for playing around with CSS's perspective properties. I've provided the starter files for this project in the resource section of this lecture. Download the zip file, unpack it on your system, and point your editor to the project. Pause the video if you need to. If you open the HTML file, you'll be greeted with this page. On the left, we have input fields for changing various properties of the box on the right. There's also this fun animation playing in the background. We'll change the perspective and rotation CSS properties of the box. The goal is to apply the changes in real time. We should be able to see the box move whenever we move the sliders. At the moment, nothing happens if we move the sliders. Let's view the files in the editor. We'll start with the index.html file. At the top of the file, we're loading in a CSS file called main.css. If we look inside the main.css file, we'll find some basic styles. The styles I've provided are not specific to Vue. We won't need to worry about them impacting our application. Let's go back to the index file. In the body tags, we'll find a div tag with the app class. This element is where we'll be mounting the instance. It'll house the application we're about to build. Inside the container, we'll find pairs of labels and inputs. There are a total of 4 pairs. Each input will change a CSS property of the box. The CSS properties we'll be changing require numeric values. We're using the range input type to restrict the values the user can input. This type will create a slider for us. We're limiting the range because the CSS properties we'll use have limits. Above the input, there's a label that contains the value from the slider. Neither the label nor input is connected with the box. We'll need to add some expressions and directives. We'll get to that in a moment. Below the inputs are 2 buttons. One button is for resetting the box. We'll allow the user to reset the box in case they need to. The other button will copy the properties to achieve this effect to the user's clipboard. We'll be using event listeners and methods to handle this scenario. If we scroll down further, we'll find a div tag with a class called box. We'll be updating this element with the data from the instance. We'll need to bind the style attribute to accomplish this. Below this, we have an element called CSS Doodle. This element will create the background effect we saw on the page. We aren't going to cover how CSS Doodle works. I've added it in to add a cool effect. It's not going to affect how we write the Vue application. At the very bottom of the file, there are 3 scripts that are being loaded. The 2 scripts are CSS Doodle and Vue. The third is the app.js file. Let's open this file next. This file will be empty. We'll be creating the application from scratch. Before we tackle this together, I recommend trying this on your own. It's an excellent opportunity to try testing your knowledge. Pause the video and good luck. Welcome back. If you were able to get the app working, congrats. If not, that's fine as well. We'll work on it together. I want to mention if you came up with a different solution than what I'm about to show you, that's fine. As long as you're using Vue to get the tool working, you can consider the project completed. Let's work on it together. The first thing we'll do is create a Vue instance. We need to tell Vue what element in the document it will mount itself to. Inside the app.js file, we'll call the Vue.createApp function. We'll pass in an empty configuration object. We'll add some properties after mounting the application. After calling this function, we'll chain the mount method. The mount method requires we pass in a selector for the element we want to mount the application to. We'll pass in #app. Next, we'll create the data properties for the box. We'll create the following properties. Perspective 100. Rotate X 0. Rotate Y 0. Rotate Z 0. The 4 properties we created will contain the value for each input. The values we've assigned to each property is the default value assigned by the browser. The properties are ready. We can begin to tie them to their respective label and input. Back in the document file, we'll start from the top and work our way down. The first field is for the perspective of the box. We'll add the vModel directive to the input field. Its expression will be the perspective property. Above the input, there's a label that contains the current value of the input. We'll want to make it dynamic. We'll replace the number with an expression. The expression will be the perspective property. The process is the same for the next field. The field below is for the rotation of the box on the x-axis. We'll add the vModel directive to the input element. The expression will be the rotate x property. We'll update the label to output the rotate X property. We're going to replace the number in the label. We'll do the same for the next input, which is for the rotation of the box on the y-axis. The input will be bound to the rotate Y property with the vModel directive. We'll replace the number with the rotate Y property in the label. Lastly, we have an input for the rotation of the box on the Z-axis. We'll bind the input to the rotate Z property with the vModel directive. The label will output the value of the rotate Z property. We're finished with controlling the inputs with Vue. Let's refresh the page in the browser to check if it works. We're able to drag the slider back and forth. We can tell the properties are bound to the input because the labels above the input get updated. We're finished with the first step. The next step is to bind the properties to the box. After we're finished binding the properties to the box, we'll reset the properties when the Reset button is clicked. Let's go back to the editor. In the document, we're going to bind the Style attribute. I'm going to use the shorthand version of binding the attribute. It's a colon followed by the name of the attribute we want to bind. We're going to bind the property to a computed property called box. We have the option of adding the properties in the expression. However, we're going to be changing 4 properties of the box element. It's going to clutter the template. It would be better to outsource the object into a computed property where we can better read the code. Let's switch over to the app file. We'll add a property to the configuration object called computed. This property will be an object where we can define computed properties. We're going to define a computed property called box. Inside this function, we must return a value. We're going to return an object. The object returned by this function will be bound to the element's style properties. Vue will take care of converting this object into a compatible attribute value for the element. We're going to set the transform property to a string template. The transform property allows us to rotate, skew, and translate an element's coordinates. We can use it to apply the 4 properties we have in the data object. We're going to set the property to the following value: perspective this.perspective px. We're using the perspective function to shift the distance of the element between the user and the z-plane. It can make an element appear closer or farther than it is. Next, we'll add the rotateX function. Its value will be the this.rotateX property with the degrees unit measurement. We must use the degrees unit if we want to rotate an element. This unit of measurement goes for the other rotate functions too. Up next, we'll add the rotateY function with the rotateY property. Lastly, we'll add the rotateZ function with the rotateZ property. We're finished with binding the properties to the box. We'll test our code in a moment. First, I want to work on resetting the properties if the Reset button is clicked. In the configuration object, we'll add another property called Methods. We'll define a method we can call when the user clicks on the button. The name of the method will be Reset. Inside this function, we're going to reset the perspective, rotateX, rotateY, and rotateZ properties to their original values in the data object. Let's update our template to use this function. Back in the document, search for the button in the template. It's located below the input fields. We'll add an event listener with the @ character. This character is the same as typing the vOn directive. It's a shorthand method of listening for an event. We'll listen for the click event with the prevent modifier. The prevent modifier will prevent the browser's default behavior when a button is clicked. It's always good practice to prevent the default behavior in case the browser does anything weird. We're finished with the app. The last thing we need to do is test the application in the browser. As I make changes to the input fields, the box on the right changes in real time. I can use any combination of values. The box will be able to handle it with ease. If I don't like what I have, I can click on the Reset button to go back. Perfect. The last thing we'll work on is the button for copying the properties to the user's clipboard. We'll handle this button in the next lecture. The last piece of the application is being able to copy the changes we made to the box. If we look at the box computed property, the value we're returning in the function is what we want to return to the user. We're not going to add an object to the clipboard. We'll pass in the string version of this property. The browser has a simple function we can run for copying the data to the clipboard. Let's look at how we would do that. Let's switch over to the index file. Search for the second button in the template. We'll use this button to listen for a click. On it, add the click event listener with the prevent modifier. The name of the function we'll run will be called copy. Next, let's define the method in the instance. In the app.js file, we'll define the copy method to the methods object. Inside this function, define a variable called text. This variable will contain the text to copy to the clipboard. At the moment, the CSS's value is stored in a string. However, the property itself is not present in the value. For the sake of convenience, let's add the property name. Set this variable to a template string with the following content: transform, this.box.transform, semicolon. After creating this variable, we can start copying this value to the user's clipboard. After the variable definition, run a function called navigator.clipboard.writeText. The navigator object is defined by the browser. It'll contain various pieces of information about the user's browser. In addition to storing information, we can access an API called Clipboard. In the resource section of this lecture, I provide a link to this API's documentation page. This API is relatively new. It allows us to read, copy, and paste content into the clipboard. It's supported on all browsers and devices. Be warned, it does not work on older browsers. If your app depends on legacy browser versions, you might want to consider a different solution. Let's head back to the editor. The WriteText function will copy text to the user's clipboard. This function is asynchronous. There are different ways to handle asynchronous code. In my opinion, I really enjoy using the async await syntax. It's easy to read and write. If you prefer to chain the then function, that's perfectly fine. For now, let's add the async keyword to the copy function. Now, add the await keyword to the WriteText function. Lastly, pass in the text variable into the function. One more thing. It's a bad idea not to give feedback to the user. They should be informed of the successful action. Below the WriteText function, run the alert function with the following message: CSS copied to clipboard. We're finished. Let's try testing the button one more time. On the browser, refresh the page. Afterward, try changing the values and copying them to your clipboard by pressing the button. We can test if we have a copy by pasting the contents of the clipboard to the console. As you can see, we're able to copy the data to the user's clipboard successfully. We've successfully created our first app in Vue. We were able to utilize a lot of what we learned in the previous section. We have a tool we can use to test how an element will behave if we change its transform properties. That wraps it up for this lecture. We'll continue in the next one. we're going to start diving into more advanced features such as lifecycle functions, the virtual DOM, and components. We're going to begin by talking about mounting the Vue instance. This topic is something we discussed briefly already, but I want to review the topic again. It's going to have relevance in the upcoming lecture. In the resource section of this lecture, I provide a zip file with everything you'll need. Download it, unzip the contents, and point your editor to those files. Pause the video if you need to. The files in this example don't contain a lot of code. It's a simple application. We have the div tag with the ID of app. Inside the element, we're rendering an expression. If we switch over to the script file, we'll find a new app being created. Inside the instance, we have the message data property set to a string value. Lastly, the CSS file contains some basic styles to help make things visually clearer. Just by looking at this code, you probably already know what to expect. The expression will be interpolated into the string hello world. I'll switch over to my browser, and sure enough, the message does get displayed. Everything works without a problem. The process of Vue inserting itself into the document is called mounting. The moment we see the expression interpolated into the document indicates that Vue has been mounted. Let's say we didn't want to mount the Vue instance right away. In some situations, we may want to mount the instance at a later time. We would want to mount the Vue instance later because we may want to load other modules before rendering the application to the user. In some cases, the element we want to render the application in may not be available initially. We'll want to defer Vue from starting the application. Back inside the editor, open the JavaScript file. We're telling Vue to mount itself to the div tag with the ID of app. We're going to remove the mount function we chained. Vue will still work. It'll continue to initialize itself with the data and methods. However, it will not get mounted to any element on the page. Therefore, we can't interact with the instance on the document. We can still interact with it via JavaScript, but the average user will not be able to unless they know JavaScript. By not mounting the application, it will not appear in the document. You may want to do this if you don't want the user to interact with the application right away, but will at a later time. Let's pretend the element we needed didn't appear until 3 seconds later. We're going to set up a set timeout function with a delay of 3000 milliseconds. Inside the callback function, we're going to call the mount method to insert the application into the document. The mount method doesn't always have to be chained after creating an app. We can call it at any point in time after the app was created. Alright, let's give things a test. Go ahead and refresh the page in the browser. Immediately, we'll see the expression on the document. It hasn't been interpolated yet. After 3 seconds, the set timeout function is triggered. The Vue instance gets mounted to the div tag with the ID of app. The mount method gives us the flexibility of presenting the application whenever we need to. Most of the time, you'll want to mount the application immediately, but it's always good to know you have an alternative if you ever need it. Back in the JavaScript file, I'm going to comment out the timeout code. We won't need to mount the application at a later time. We'll call the mount function after creating the instance. This isn't any different than chaining the function. However, I like to do this because it looks cleaner, in my opinion. Constantly chaining functions can be a bit confusing. Call the mount method however you prefer. That wraps it up for this lecture. We'll continue in the next one. Vue goes through a process called the lifecycle. The lifecycle enables us to run code when a new instance is created. We're not limited to creating the data inside our instance. We can run code during the creation process and even after the instance is destroyed. Allow me to elaborate further. Before the Vue lifecycle may begin, the instance has to be created. That's done using the Vue.createApp function. This function is where you pass in your settings and data for Vue to work with. During this process, Vue will begin the lifecycle. Vue will create areas within itself where we can inject code and do whatever we want. The very first thing Vue does is add reactivity to your data. This process is where it begins to watch your data for any changes. Before that happens, you have the opportunity to run some code. The first lifecycle hook that occurs is the beforeCreate hook. At this point, the Vue instance hasn't been fully created. This means you won't have access to your data or any of its methods. Once everything has been initialized, the Vue instance is ready. We're provided another lifecycle hook, which is the created hook. Unlike before, we can access the data and methods inside the Vue instance. However, Vue is not mounted to any template, nor will anything be rendered onto the page. After the Vue instance is created, it'll start looking for a template. This part of the lifecycle starts the moment we call the mount method on the application. Vue will scan the template code and begin processing it. This process is what's called compiling. We haven't talked about compiling in depth in this course, but I promise we will soon. All you have to know is that this is where Vue will scan for directives, expressions, events, and bindings inside the template. Once the template is compiled, Vue will replace the content inside the element we selected with the mount method with the compiled template. Before that happens, you have the opportunity to hook into the before mount lifecycle hook. Once mounting is completed, you can hook into the mounted lifecycle hook. At this point, Vue has inserted itself into the document. We'll be able to see the rendered template on the document. All expressions, directives, and bindings have been processed. After the mounting phase is completed, your application will watch the data for any changes. This usually happens during events such as mouse clicks or inputs. Anytime the data has been updated, Vue will then update the template, and the cycle just repeats. We are provided two hooks during this process. The first hook is the before update hook. This gets triggered after the data has been updated, but has not been applied to the template. The next hook is the updated hook. This hook runs once the template is patched with the updated data. These two hooks I'm introducing are mainly used for debugging. I wouldn't recommend you use them for applying changes to the data. Computed properties and watchers will cover 99% of the scenarios you come across. This is the lifecycle we've been dealing with throughout this course. Soon enough, you will become familiar with the lifecycle process. We're going to dive into the code in a moment, but there is another part of the lifecycle process we haven't been able to experience yet. We have the ability to destroy the Vue instance. This means that any reactivity, events, directives, or bindings will be disabled and gone. You may want to do this in case you want the user to no longer interact with the application. The way you destroy the instance is by calling the unmount method. Once the method has been invoked, Vue will take care of the rest and finally destroy the instance. If you call the method, there's no turning back. During this process, there are two hooks we can use. The first hook is the before unmount hook. This hook is called before the instance is destroyed. Your application is still fully functional and present on the page. You're free to access any of the data and methods in your Vue app. The last hook is the unmounted hook, which is triggered once the Vue instance is destroyed. You won't be able to access the instance anymore. Any data or methods will be gone and inaccessible. That's it. That's the Vue lifecycle. Now that we have an overview of things, let's learn how to use the lifecycle hooks in the next lecture. In this lecture, we're going to look at how to use the lifecycle hooks in our application. We'll be working with the code we had in the previous lecture. The very first hook is the beforeCreate hook. We can use this hook by adding it to the configuration object we passed into the createApp function. This goes for the other hooks too. It will be on the same level as the data property. The value must be a function. This hook is called before the Vue instance is initialized. At this moment, we won't have access to the data because Vue hasn't created the proxy methods. The instance will not be reactive. we're going to console.log a message to prove that this method gets called before create function called. Along with it, we're going to log the message property we have inside the data object. We'll see the results of this soon enough, but let's keep moving forward. The next lifecycle is the created hook. This hook will be set to a function. All lifecycles are functions. I'm going to copy the log message we used in the before create lifecycle. We'll make a modification to the message to help indicate which lifecycle this message is being logged from. Everything else will leave the same. We'll be performing the same test as before. The next lifecycle we'll take a look at is the before mount lifecycle. This hook gets triggered once the template has been compiled, but hasn't been added onto the page yet. We'll paste in the same message as before, but change the name to before mount and set the second log to this.$el. I'm introducing a new property called $el. Its value will be the element Vue is mounted to. It's available once Vue has been mounted. You'll be able to see the value once we run the code. Up next, we have the mounted lifecycle. This hook gets called after the template is mounted onto the page. At this point, we have a fully functioning application. We're going to log the same message we had for the before mount hook, but change the hook's name to mounted. Alright, let's test our code. Go ahead and refresh the page. The application will work like normal. Let's view the console to see what appears. We will have a total of 4 messages. The first message is from the before create lifecycle. This hook gets called before the Vue instance proxies our data and methods. It's the first in the series of lifecycle hooks. Taking a closer look, we'll see that the message property we tried logging is set to undefined. This is because the data property hasn't been proxied yet. Therefore, the this object won't be able to print to our data properly. This limited scope goes for our methods too. The next method is from the created lifecycle. The data and methods in the instance have been proxied. This is proven by the fact that we're able to log the message data property successfully. Then we have the message from the before mount lifecycle. For the second message, we logged the $element property. This property will be set to null because the application doesn't have access to the template yet. Lastly, we have a message from the mounted lifecycle. Unlike previously, the $element property will hold the template after it's been compiled. The expression is no longer present. It's been interpolated to the message data property. These are the first 4 lifecycle hooks. It's pretty clear what each one does. The most important thing to understand is what you have access to inside each of them. Some lifecycle functions will provide you with very little, while others give you access to everything. One of the main questions I get asked by students is the difference between the created and mounted lifecycles. The mounted lifecycle is only triggered once the template is compiled and inserted into the document. We'll have access to the template if we need to make changes to it. If you need the template rendered on the document, you need to use the mounted lifecycle. If you only need the data, then you can use the created lifecycle. Alright, let's move on to the rest of the lifecycles. The next set of lifecycles are for when updates occur. Let's go back to the editor. The first one is the before update lifecycle. This hook gets called whenever an update in our data occurs, but before these changes are applied to the template. I'll log the following message, before update function called. We will not be logging a second message. Unfortunately, we don't have access to which property was updated. This hook will get triggered upon any changes to the data. Like I said before, this is usually used for debugging, but you can also update additional data if you need to. The last lifecycle is called updated. I'll log the message, updated function called. Alright, let's give things a test. I'll refresh the page. We will see everything work as before. The updated lifecycle hooks are called on changes. We don't have a way to change the data inside the document, but we do have the Vue Developer Tools. Inside the Vue Developer Tools, we can access the data inside the application. The Developer Tools allow us to change the data without having to create a UI. This tool can be helpful for quickly debugging an application. We'll change the message property to something else really quick. The changes will be reflected in the document since we're using an expression that outputs the message data properly. If I were to switch back to the console, you would see the new lifecycle messages appear. They are thus giving us a clear indication that the correct functions were called. The lifecycle functions we're using will be called whenever an update occurs. The last set of lifecycle functions we'll look at are for when the instance is destroyed. Let's take a look at those now. Switch back to the editor. Inside the Vue instance, we'll add the before unmount lifecycle. This hook gets triggered before the instance is unmounted. This hook will allow us to perform last-minute changes. We still have access to the data and methods in the Vue instance. The app is fully functional. We'll log the message before unmount function called. The next lifecycle is called unmounted. This hook gets triggered after the instance is unmounted. Any directives or events you previously had are gone. We'll log the message. Alright, let's give things a test. Refresh the page. No errors will appear so far. Now the question is, how do we unmount the instance? Vue provides us with a method called unmount. Inside the console, we'll use the VM object and call this method. The method requires we pass in the element where our application is mounted to. This is because Vue needs to know where to remove the template it renders. This method will unmount the instance from the document. After calling this method, we will see both messages appear. The template has been removed from the document. We won't even see the uncompiled version of the template. The page is completely empty. We will not be able to interact with the application anymore. The data, events, bindings, and directives are all gone. That's the lifecycle hooks in a nutshell. They're pretty powerful and allow us to access different parts of Vue. You most likely won't use all the lifecycle hooks, but they are there when you need them. In the resource section of this lecture, I provide a link to the lifecycle documentation page. It has a diagram like the one I showed you before. It has more info though. The chart I showed you is a more simplified version of the Vue lifecycle. I showed you a stripped down version because there are more topics we haven't gone over yet. This diagram would have been more confusing to explain than what I had. Surely enough, we will go over some of the missing pieces. For now, you will be good with what I've shown you. By the end of this course, you will be able to understand this diagram Vue has provided fully. In this lecture, we're going to talk about the virtual DOM. Learning about the virtual DOM is mostly theory. It's something that's handled for you by Vue. You don't have to worry about it much, but you will hear about it the longer you use Vue. So it's good to know what it is and why Vue implements a virtual DOM. First, we need to understand what the word compile means. To put it simply, to compile something means to take something in and turn it into something else. In the programming world, it usually means to take in your code and convert it into other code so that another program can understand it. One example is the JavaScript language. Machines don't understand the JavaScript language. You need to run it through a compiler that will convert it into machine code. The browser handles that process for you whenever you load a JavaScript file. Vue does something similar. That begs the question, what is Vue compiling? Why does it need to compile anything in the first place? To answer the first question, Vue is compiling our templates. When we use the mount method, Vue will scan the contents of the original template. This includes the expressions, directives, bindings, and anything else inside of the template. It will take it in as a string and convert it into an object. Here is a basic example. On the left, we have an h1 tag with some content inside of it. On the right is what it gets compiled to. It gets compiled into an object. The object will contain the tag name, attributes, and content inside the element. Let's take it a step further. A step up from this would be nested elements. In this example, the template has an additional span tag surrounding the text. Everything is the same on the right except for the content property. Instead of a string, Vue will store the content as an array of objects. Each object represents a child element in the parent element. In this instance, we have one object which contains the same properties as before. To summarize, Vue is compiling our template. It converts it from a string of HTML to a JavaScript object. That leads us to the next question. Why does Vue compile our templates? The two main reasons are that it's easier to manage, and it provides a performance boost, especially for larger applications. Let me explain more. Firstly, you should be familiar with the concept of a DOM. DOM stands for Document Object Model. If you run JavaScript in the browser, you will be provided with an object called the document. Through this object, you can retrieve elements on the page or make changes. In this example, I'm selecting an element by its ID. Then, I'm changing the inner HTML of that element. This process is the fastest way to update the document. Actually, it's the only way you can update the document. Make no mistake, the DOM is pretty darn quick. The problem with this approach is it can significantly slow down your application the more elements you have. Imagine a scenario where we are listing users. We're rendering the list of names onto the page using paragraph tags. Simple enough, right? Well, what if you remove a name from the data? In that case, you would have to scan each individual element. If an element is using the data, you should delete it from the document. You would also have to check for their attributes and children as well. Performing an operation like this would be rather expensive. You would have to continually check each element using the DOM functions like getElementById or querySelector. These functions return properties and methods you wouldn't need to check. That creates a lot more overhead the more elements you have. Going through the DOM and comparing values is costly. That's only the first part of the operation. After you've performed comparisons, you need to update the DOM. This includes adding or removing elements. An alternative to this would be to just render the entire template without having to check each element. But that's also inefficient. Repainting a page is costly, especially if you have an application that's working with data constantly. Rather than replacing the whole template, it's smarter to update the elements and attributes that need to be changed. Alright, so how is the virtual DOM any more efficient? The virtual DOM is a lightweight copy of the actual DOM. It doesn't have as many properties or methods as the original DOM, but that's okay. Its purpose is not to replace the DOM. By having a lightweight copy, the process of checking each element is much faster. Once it's finished, it'll perform what's called a patch. Patching is the term used to refer to the process of updating, adding, or removing elements from the page. This includes the attributes or content of an element. Vue will only update what's necessary. It won't update the whole template. If the text inside an element changes, then that's what will be changed. The entire element won't be overwritten. It does this process in bulk. If multiple changes need to happen, Vue will apply it all at once. This way, changes are smoother. Overall, the virtual DOM is an extra step in the process, but it's more efficient and faster. It scales incredibly well. You can have thousands of elements on the page. Vue will be able to handle the document without a problem. I'm presenting a simple example. Can you imagine an application with hundreds of elements and attributes? The traditional way of doing things would result in a slow app. The virtual DOM is optimized to handle large data efficiently. One of the most exciting things about the virtual DOM is that it's unnecessary to add classes or IDs to an element. I'm not sure if you noticed, but we didn't have to worry about adding classes to our elements to select them. Vue knows precisely where to update the template without using classes or IDs. That kept our code reasonably minimal. Of course, you would still use classes for adding styles to an element. It's just that it's not required to add classes or IDs for selecting an element. This also keeps things minimal in the JavaScript file. We didn't have to query for any elements. Instead, we updated the data. From there, Vue took care of updating the DOM for you. I've talked quite a bit about the virtual DOM. Let's recap everything. The virtual DOM is a JavaScript object. It is a lightweight copy of the actual DOM. Whenever a change occurs in your data, the virtual DOM will also get updated. After the virtual DOM is updated with your data, it'll sync itself with the actual DOM. It won't add or remove anything if it doesn't have to. It'll patch certain areas wherever the data is used. As long as you understand that, then you will be good to go. In the next lecture, we'll get back into some coding. In this lecture, we're going to get a basic understanding of how Vue implements reactivity with our data. This information can be useful if you're ever in an interview. You'll be able to explain Vue's reactivity better compared to other candidates. From what we understand so far, reactivity is when a program is able to react to changes. One famous example is Excel. Excel is a spreadsheet program. One of the more useful features of Excel is it's able to calculate results on the fly. I have Excel opened on my machine to give an example. I'm going to write two numbers in a single column. If I want to get the sum of both numbers, I can highlight the two cells. Then, I'll right-click to bring up the menu. I'll select Quick Analysis. This option will bring up a list of calculations we can perform on the two values. Under the Totals option, I'll select Sum. The sum will be outputted below the other two cells. I can freely update any of the two cells. The third cell will be reflected with the changes. Excel is able to react to changes on the fly. Vue replicates this behavior with our app. Whenever our data changes, the document will be updated to reflect the changes. Under the hood, Vue is using something called Proxies. I've mentioned Proxies a few times already, but how exactly do Proxies work? Let's dive into Proxies. In the resource section of this lecture, I provide a link to CodePen. CodePen is a playground for quickly prototyping projects in the browser. We're going to be using it quickly to look at how proxies work. We don't need to set up a new project for this demonstration. Let's create a new pen. We don't need CSS for this example. It's safe to minimize this section. We're also going to open the console to help us with debugging. In the JavaScript section, we're going to create an object called data. You can imagine this object the same as the object we would return from the data function. We'll add one property to this object called name. The object we created is very plain. We can directly access its properties and update them too. In a complex app, we'll most likely want to observe this object. When I say observe, I mean watch for changes or how it's accessed. By becoming aware of how the object is treated in our app, we can perform additional actions. At the moment, we can't observe the object. We don't know when it's accessed or if the values have been changed. One way to force our app to observe the object is by using proxies. Below this object, let's create a new variable called observed data. Its value will be a new instance of the proxy object. The proxy object was introduced to address the exact problem we're facing. It allows us to observe an object. A proxy can be created by creating a new instance out of this object. It has two arguments. The first argument is the object that should be observed. We'll pass in the data object. The second argument is another object. We'll pass in an empty object. We'll talk about this object in a moment. The new instance that's returned is a copy of the object we passed into the first argument. We can treat the observed data object as if it were the data object. For example, let's log the observed data.name property. In the console, the name property was logged. The observed data object is the same object we had previously. The main difference is that we can add additional functions to it that will be called based on how the object is being interacted with. We can define functions in the object we passed into the second argument. The first function we'll look at is called set. The set function will be called whenever any of the object's properties are about to be updated. This function is called before the update occurs. There are 3 arguments we can accept in the function called target, key, and value. The target argument references the object we're accessing. You can think of it as the equivalent to the this keyword. The key argument is the name of the property that's being accessed. The value argument represents the value that the property will be set to. By defining this function, the property will never be updated. The reason it won't get updated is because the set function will be responsible for updating the property. If it didn't exist, the default behavior would occur. In our set function, we can have the default behavior back by setting target to the value. As you can imagine, this gives us a lot of power. The set function will always be called for any of the properties on the object when they're updated. We can use this opportunity to perform additional actions. For example, let's try updating the document with the new value. In the HTML section, we'll add a div tag with the ID of name. Next, back in the set function, we'll select the div element with the document.querySelector function. We'll update the inner text property to the value argument on the element selection. Lastly, let's update the name property. The set function won't be called until we update one of the properties on the object. We only have one property, which is the name. We'll update the name property on the observed data object to a different value. On the preview, we'll be able to see that the name gets outputted after changing the property. The great thing about this proxy is that the document will always reflect the latest value no matter how many times we update the name. It'll always output the most recent change. By using proxies, we can create our own reactive JavaScript framework. Luckily, we don't have to. Vue comes with Reactivity out of the box. It even introduces edge cases that we haven't even accounted for in our example. We don't need to recreate the wheel. Behind the scenes, Vue is using the proxy object to help it keep track of changes to our data. In the resource section of this lecture, I provide a link to the proxy object documentation page. We aren't limited to watching for changes. We can watch for when the object has been accessed or if any of its properties have been deleted. Feel free to read up on this object. This information can be handy if you're ever in an interview and want to stand out from the other candidates. Understanding how reactivity works can really set you apart. There are 2 ways to create a template. Up until now, we've been creating the template inside the HTML document. We have the option of creating the template inside the Vue instance. Let's try creating the template inside the instance instead of in the document. Starting with the document, let's cut the code inside the div tag with the ID of app. We'll leave the parent element alone. It's still required to have an element on the document for Vue to start the mounting phase. Then, switching to the JavaScript file inside the configuration object, we're going to remove every lifecycle function. We're going to get rid of any commented code since we no longer need it. Templates can be directly loaded in the Vue instance by adding the template property. The value for this property must be the template Vue will compile. I'll paste in the code we cut earlier as a string literal. I'm adding this in as a string literal to take advantage of multi-line code in ES6. You can use regular quotes if you wish. Let's view this in the browser for the outcome. Refresh the page on your browser. The template is compiled and rendered onto the page. The expression interpolates into the value we had in the data. So what's the difference? Well, there's not much of a difference. They both accomplish the same thing. You may want to use the template property if the HTML is stored inside a different file. You would need to make a request to grab that file. Then you would use the response from the request as the value for the template property. That's just one scenario. Usually, I don't recommend using the template property for two main reasons. The first reason is that most editors won't be able to pick up on the HTML syntax inside a JavaScript file. Even my editor will highlight everything as a string. The second reason is that you can't do multi-line templates easily. I'm using a string literal, but string literals are not compatible with older browsers. Therefore, you'll have to use quotes and append each string together for each line. That makes things harder to manage. I always recommend storing the template inside the document and let Vue take it from there. There is another option, which is usually the preferred option for more complex applications. There are multiple versions of Vue available for download. However, all of them can be broken down into two categories. There are the versions with the compiler and the versions without the compiler. Notice how the only difference between these two types is the compiler itself. The compiler, as we learned previously, is responsible for taking in your template as a string. It'll convert the template into an object for the virtual DOM. Whenever you use the template property or the mount method, the compiler will be used. Throughout this course, we've been using the version with the compiler. Vue grabbed the contents of the element we passed into the mount method and compiled it. However, we do have the choice of using Vue without the compiler. The main advantage of using Vue without the compiler is the size reduction of the file. By removing it, Vue will be reduced to about 30% of its original size. This reduction will, in turn, increase loading times. Vue is also much faster since it doesn't have to worry about compiling your templates. The downside of using Vue without the compiler is that it's harder to read and manage without the proper tools. Fortunately, the development team behind Vue has made using Vue without the compiler simple. They have an official toolset we can leverage. This toolset gives us the performance boost of using Vue without the compiler. We'll be diving into how to use the proper tools soon enough. First, I want to take the time to explore with you the compilation process. The difference between the two versions is the compiler. Even if you use the version without the compiler, you still have access to features like directives, expressions, bindings, and events. Every feature is available to you except the part where Vue will process your template and convert it into an object. In the resource section of this lecture, I provide a link that describes the different versions of Vue. It's referred to as builds in the documentation. There are a number of builds here, but as I said before, it's narrowed down to two different categories, the one with the compiler and the one without the compiler. The build with the compiler is referred to as the full build. The build without the compiler is referred to as the runtime only build. For most of this course, we've been using the Vue.js build. It's the full version, meaning we've been using Vue with the compiler. Below are definitions for the words used in the documentation. For the word compiler, Vue defines it as the following: code that is responsible for compiling template strings into JavaScript render functions. What exactly are render functions? Let's look into that. In my browser, I'm going to open the Vue application we've been working with in this section. To save some time, we're going to run the examples in the console panel instead of writing the code in a file. Let's create a variable called res. The value of this will be the Vue.compile function. The Vue.compile function is the exact function Vue uses internally to process your template. You're required to pass in the template as a string. By default, Vue will pass in the template you select in the mount method. However, since we're calling it manually, we'll need to do that ourselves. We'll pass in some paragraph tags with some random text. For fun, I'll throw in a v-if directive with the expression set to true. We're storing the value since the compiler only compiles the template. It does not store it anywhere for us. Running this line will not do much. However, the res variable will be available, and we can call it next. The value assigned will be an object. The object will have a property called render. I'm going to log this property next. This function will return what's called a render function. It's a function that will take care of rendering the template in the document. This is the compiler in action. It takes in raw HTML as a string. It'll return a function which Vue calls a render function. The render function is responsible for returning an object that represents the template you passed in. We have the option of completely removing the compiler by using the runtime build. The only downside is that we're required to build the object ourselves and provide it to Vue. Let's learn how to do that. Let's go back to the editor. Back inside the document, we're going to create another div tag below the first one. We'll give it the ID of app2. We're going to create two applications and compare them side by side. The first one will use the compiler, and the second one we're about to create will not use the compiler. Switching to the script file, we'll create a variable called vm2. Its value will be the vue.createApp function. Then, we'll chain the mount method. The element we'll mount to is #app2. The data for this application will be the same as the first one. We'll have two applications with identical data. This example will help us see the difference. Now the question is, how do we create the object without the compiler and pass it on to Vue? We can do that by creating our own render function. The Vue instance allows us to create a render function by using the render property. Set this to a function. This property is optional, but if you provide it, then Vue will allow you to create the object yourself. Inside this function, we're required to return an object. We could create that object ourselves, or we can use the vue.h function. The vue.h function will help you create the object in the correct format. It'll also take care of filling in the blanks for us. Therefore, we'll return the vue.h function. H is short for hyperscript. When we think of HTML, we know that it means hypertext markup language. That's what it is. It's a document made up of text. Hyperscript is similar, except you're using JavaScript to create HTML. The development team behind Vue uses H instead of spelling the full name to reduce file size. This function has some parameters, but we're going to use the first two. The first parameter is the name of the element. Let's pass in an h1 element. The second parameter is the content inside the element. You can set this to a string, but I want to output the message inside the data property, just like the first application. During the render process, we have access to the proxy methods, and properties Vue sets up for us. Since that's the case, I can pass in this .message. It's not necessary to use an expression. Alright, let's give things a test. Refresh the page to view the results. We have two identical applications. The difference between them is that the first application is using the compiler. The second tab is manually creating the object. We are skipping the step of compiling a template from a string. Let's see what happens if we remove the compiler from the build. In the resource section of this lecture, I provide a link to CDN.js. CDN.js is another CDN platform. We are on a page for different links to different builds of Vue. Search for the link that says vue.runtime.global.js. This build is the version of Vue without the compiler. Its file size will be considerably smaller. We are going to copy this link. In the document, we will replace the current CDN link for Vue with the link we copied. Go ahead and refresh the page. This time, only the second application will load. What happened to the first one? Since we're using the build without the compiler, Vue will not bother compiling the template we had earlier. This will ultimately result in a broken application. This makes it very clear as to what the differences are between the two builds. The runtime build is the preferred build to use. It does have a major downside. We have to write render functions to build our templates. It isn't very appealing. It would be so much nicer if we could continue writing the template as we always have, but continue to gain the performance benefit of the runtime build. Luckily, there is such a way. We can use the Vue CLI. I'm getting a little ahead here, but I want you to be aware that there is a way to make this process easier and still gain the performance boost. I promise we'll dive into the Vue CLI later in this course. There are still a couple more things I want to discuss. So for now, I'm going to comment out the second application inside the JavaScript file. Then I'll change the script back to the full build. Lastly, we'll cut the value inside the template property from the first application back inside the document. I find this the simplest way of doing things. If you want to use the template property or the render function, then by all means, go for it. Lastly, we'll remove the second div tag. That'll do it. In the next couple of lectures, we'll begin diving into components. Components are the most commonly used feature in Vue. They're not hard to understand or use. First, we must ask ourselves, what are components? Components are the pieces that make up your application. It's stuff like the header, footer, and content. It's basically the sections inside your HTML. Storing the template for an application in a single file can be hard to manage. Therefore, it's ideal to split the template into separate files. This is what's called components. Components are templates, but they're a bit more than that. They can contain their own data, methods, computed properties, and watchers. By themselves, they can't do much. They're meant to be used in the main application. On top of allowing you to split your code into separate files, they are reusable. That part is optional. For example, you would create a header component but only use it once since most sites only have one header. On the other hand, you can have a post component but use it multiple times because sites can have various posts. It's up to you in the end how you use components. Alright, let's see a component in action. Components must be created before we mount the application. That's important to note down. We're going to write the code before we call the mount method in the app.js file. The component we're going to create will be simple. It will render a message. We can create a component by calling the component function. This function is available after we create the Vue application. This function has two parameters. The first parameter is the name of the component. You can name your component whatever you want. There are two naming conventions Vue encourages, kebab case and Pascal case. Kebab case is when all characters are lowercase and words are separated with hyphens. Pascal case is when every word is capitalized. On top of Vue's naming convention, I'm going to recommend you namespace your component names. Namespacing is the idea where the name you give something is unique to your project. Some people will use the initials of their project or their name. Then you would follow it up with the actual name of the component. For example, if we were creating a blog application and creating a post component, we could name this blog-post. There are plugins you may end up using in your application that provides their own components. To ensure you don't face any name collision issues, It's recommended you namespace your components. In the end, it's all up to you. Since this is just an example, there's no need for namespacing. We'll keep the name simple. We're going to call this component hello. The second parameter for this function is a configuration object for the component. The settings are the same settings you would use in a regular Vue instance. This means we can add the data, computed, and methods property. The main advantage of using a component is that these properties values are unique to this component. Even if we have another component with similar named values, we don't have to worry about naming collisions between components. Not every property is available. For example, the mount method can't be used with a component. Even though components are created similarly to Vue instances, they can't be used to create an application. If you tried using the mount method, then you would receive an error. Components are meant to be used as pieces for your Vue application. One of the problems with writing a component is not writing the template in the document. This restriction forces us to use the template property. Let's create the template. We'll add the template property to the configuration for the component. The value will be a string literal. We're going to add an h1 element with the message data property. The message doesn't exist because we don't have any data in the component. Let's work on creating the data property next. We'll set the data property to a function where we'll return an object. Inside this object, we'll create the message property with a value of hello world. That's it. We've created our first component. By using the component function, we've registered a custom component. Custom components can be used in the Vue instance or in other components. Let's use it inside the Vue instance. From the Vue instance, we're going to remove the data function. The message will come from the component. We don't need to store it in the instance. I want to be clear that even if we kept the property around, the application would still work. The instance data and our components data are isolated from one another. Vue will not throw an error for having data properties with similar names. Moving along, to use a component, you create a set of tags. The name of the tag will be the name you gave the component. It's the same value you passed into the first parameter of the component function. In our case, this would be hello. We're going to create 3 copies of this component. Vue will replace this tag with the template you passed into the component. We have the option of using self-closing tags. Let's refresh the page to view the final result. The hello tags were replaced with the components template. The expression we had in the components template was interpolated. Currently, each component has the same value for the message property, but the data is unique to each component. We can prove this further. Opening the Vue Developer Tools, we will find the root component along with 3 hello components. The hello component may be called an anonymous component because we haven't registered a name for our component. We will learn how to assign a name in a future lecture. It's not something we have to worry about at the moment. The root component will not have any data because we removed it. Each hello component has the message inside its data property. We'll select the second hello component. Then we'll update the message property to something else. After updating it, the message expression inside the second hello component was updated, thus proving the data is unique to each component. Alright, that does it for components. There's so much more you can do with components, but we'll get to that later. As your application gets bigger, you'll want to split your code into various files. Components help us with that. Before we dive deeper into components, it's time that we start considering the tools necessary to scale an application. Things are starting to become difficult. It's only going to get increasingly difficult to explore other parts of Vue. We also should be using the build of Vue that doesn't come with the compiler. Using the build without the compiler means we have to code objects rather than regular HTML. How do we overcome this? The next section will cover these tools to get you up to speed. If you're as excited as I am, then I'll see you in the next section. In this section, we're going to step away from Vue for a moment. If you're interested in creating small widgets for your site, you've learned everything you need to know. Loading Vue with script tags will suffice for small widget projects. However, if you're looking to build full scalable web applications, there's still much more to learn. It's possible to make apps by loading Vue through a script tag, but it's not the most efficient way. You will want to use the proper tools to help you with debugging and scaling the application. That's where we're headed next. The development team for Vue has curated a set of tools for building Vue applications. These tools are built on top of other tools. They'll help us face challenges such as optimizing bundles, code splitting, and managing assets. In this section, I want to discuss the tools Vue uses under the hood to make our lives easier. While it's not completely necessary to know the underlying tools, it may help you in future projects. A lot of job postings require that you have some basic understanding of the tools. You don't have to be a pro. The fundamentals of each tool are enough to get you started. Keep in mind that Vue takes care of many more technical and challenging parts for you. The goal of Vue is to simplify the development experience. You don't need to stress over every detail. Here are the following tools we will be reviewing in this section: Vite, Webpack, Babel, PostCSS, SASS, and ESLint. These are the primary libraries we'll be dealing with in most advanced projects. I want to stress that if you're already familiar with these tools, you may skip this section. I'm not going to be teaching anything groundbreaking or new about these tools. My main goal is to give an overview of what these tools are and how to use them. We won't be able to dive deep into these tools, as it would take up too much time. Before you proceed with this section, there are a couple of things you should know. You should have some knowledge of ES6, things like arrow functions, constants, modules, etc. We will be using modern JavaScript to build our applications. If you're ready, I'll see you in the next one.
Hey peeps, it's Aldo here again. In the coming videos, we are going to assume that you have a general understanding of basic command line functions, how to run JavaScript files with Node.js in the command line, and lastly, a basic understanding of how common JS modules as well as ES6 modules work. For our ZTM Academy members, we do have an appendix section in the full course called Extra Bits, where you can go and get yourself caught up on this and more. That's it for now. Let me hand it back over to Luis. Enjoy.
In this lecture, we are going to get started with Vite. Vite is going to bring everything together. It's one of the newest packages to enter the JavaScript ecosystem. Despite that, it's already gained a considerable following. Hundreds of thousands of developers are integrating Vite into their workflow. So, what is Vite? Vite is a module bundler for applications. During the development process of your app, you're going to be creating dozens of files. They can range from JavaScript files to images. Once you're ready to push an app into production, you may want to optimize, compress, and minify your codebase. For example, let's say you had 20 JavaScript files in a project. As we know, it's considered good practice to split your code into separate files for manageability, but the user shouldn't be forced to download dozens of files. Ideally, they should download as few files as possible. That's what Vite is for. It'll compact your project into as few files as possible. However, it can do so much more. Vite is not the only tool that accomplishes this task. If you do your research, you may come across other module bundlers such as Webpack, Parcel, Snowpack, or Rollup. Currently, Webpack is considered the industry standard. So, why are we going to use Vite? Performance is highly critical for development. Webpack is starting to show its age. As your project grows, bundling a project can take longer. Makes sense, right? Bundling hundreds of files can take a while. Unfortunately, most tools struggle with bundling large projects. Vite does not have this problem. You can always expect a project to bundle within seconds. Another advantage of Vite is its immense support for third-party libraries. A lot of bundling tools focus on JavaScript. Support for images, CSS, or other file types requires plugins. It's up to developers to add support for different types of files. Out of the box, Vite supports the most popular tools for front-end development, from TypeScript to SASS. This feature allows developers to focus on their projects rather than configuring a set of tools. This leads me to my next point. You may need a specific tool to be supported in your project. If Vite does not support it out of the box, that's perfectly fine. Vite is easily extendable. You can add support for other tools by updating the default configuration. In my opinion, configuring Vite is easier than configuring other tools. For these reasons, Vite is gaining traction among the community. It wouldn't surprise me if it became an industry standard within the next few years. Best of all, the creator of Vite is the creator of Vue. Both packages are easy to integrate together. Let's try creating a project with Vite. This process is straightforward. It's not recommended to create a project from scratch. Instead, the Vite package has a tool for quickly scaffolding a project. In your editor, open the command line. I highly recommend pointing your editor in an empty directory. We do not want the files generated by Vite to conflict with existing files. Inside the command line, type the following command: npm create vite@latest. The npm create command will initialize a package's executable. After this command, we must provide the name of the package. In this case, we're trying to run the Vite package. Let's run the command. After doing so, npm may ask us to confirm our decision to run this command. It can be dangerous to execute a package straight away. We can safely run this package. Let's proceed with the installation. Up next, Vite will ask us a few questions about our project. Firstly, it'll ask us for the project name. You can freely change the name. For our example, let's stick with the default name. After setting a name, we can select a framework. Vite is compatible with most JavaScript frameworks. It's not a tool exclusive to Vue. Even though we're learning Vue, we're not going to select it from the list. Instead, let's stick with the vanilla option. The reason is simple. The main objective of this section is to focus on Vite, not Vue. After we have a good understanding of Vite, we'll look into integrating both packages. The vanilla option will create a project with plain JavaScript. No frameworks will be installed. We have the option of using TypeScript. However, I think plain JavaScript works best. After selecting our options, a new directory has been created with the same name as our project. In addition, the Vite package will provide a list of additional commands to run. Let's move into the directory with the cd command. Next, let's install the packages with the npm install command. This process may take a while. Once the packages are finished installing, let's talk about the files and directories in the next lecture. I'll see you there. In this lecture, we are going to explore the project scaffolded by the Vite package. Before getting started, you should point your editor to the directory created by the package. It'll be easier to inspect and run commands from this directory. Pause the video if you need. Once you've got that sorted, let's begin. In the root directory of the project, there are a few files. The most important file is the index.html file. This file is considered the entry point of our application. What is an entry point? The entry point refers to the file responsible for launching an application. The entry file can import other files from images to JavaScript files. This step is important to highlight. If the entry file does not import other files, it's possible that they may not get bundled with our project. If we look closely at the HTML file, two files are being imported. They're the favicon and script files. However, our CSS file is nowhere in sight. In the project, a basic CSS file was created. Despite not being imported from the main HTML file, it will get bundled with our project. To find out why, open the main.js file. The very first line of code in this file is an import statement for the CSS file. Typically, import statements for CSS files are not supported. The JavaScript language does not allow this behavior. By using Vite, CSS imports are allowed from within a JavaScript file. During the bundle phase, the CSS will be extracted into a separate file. The CSS will not be embedded into our script file. We do not need to worry about bloat. Not all dependencies need to be imported into the entry file. Since the script file is imported into the HTML file, our script is allowed to import additional files. There isn't a limit as to how many files can be imported. Let's try running our project. Open the package file. Overall, the package is very simple. There's nothing abnormal about it other than the script's object. From the beginning, we're given 3 commands for running our project. The first command is called dev. This command will launch a server for development. You may not want to constantly manually build your project. The dev command will force the server to watch your files for changes. If a file changes, the build will reflect those changes. The process is completely automated. Let's give it a try. Open the command line. I recommend moving the command line into a separate tab. I find it easier to read the command line as a tab as opposed to a separate panel. You can drag and drop the terminal by its name. After moving the terminal, let's run the npm run dev command. After a few moments, the package will create a temporary server for viewing our application. Let's visit this URL in our browsers. Voila! We've got a fully functional development environment. We can start working on our project. As we do so, the package will refresh the page during updates. Let's head back to the command line to explore the other commands. The next command in the package file is called build. Unlike the dev command, the build command will build our project once. If we look in our projects directory, nothing has changed. What if we want to grab the final bundle? The build command will output the files for us. Let's give it a try. Back in the command line, you may need to exit the current command. By launching the server, Vite does not allow us to run additional commands. In the command line, run the npm run build command. In a few moments, the command will produce a bundle in a directory called distribution. We can check out this folder for the final output. These files can be uploaded to a server for production. You do not need to include files outside of this directory. As I mentioned before, only files imported directly or indirectly from the entry point file will be included. In the assets directory, we will find the CSS file. What if we removed the import statement for this file? Let's find out. In the main.js file, remove the import statement. Next, run the npm run build command. If we look at the distribution/assets directory, the CSS file is missing. Since our app is not importing CSS, this file is not included with the bundle. Before uploading our project to production, we may want to verify that the app is fully functional. However, we can't because the server is not running. In the command line, we can run the npm run preview command to launch the server for the distribution directory. The preview and dev commands are similar. There's one huge difference. The preview command does not watch our files for changes. The purpose of the preview command is to launch a server for the build directory. It allows us to quickly inspect the final build. The dev command is for the development phase of a project. Now that we have an overview of our project, let's start exploring some of the features of other tools. Along the way, we'll learn more about Vite. When you're ready, I'll see you in the following lecture. In this lecture, we are going to start exploring a second tool called SASS. This lecture will be a brief overview of the language. SASS is a topic that deserves a course of its own. I encourage you to look at other courses or tutorials to learn more about SASS. In the resource section of this lecture, I provide a link to the official site for SASS. SASS is a programming language for CSS. CSS is not known for being an intelligent language. Features like functions or conditional statements are non-existent in CSS. SASS was introduced for extending CSS. We can perform various actions, from defining functions to looping through an array of data. SASS is an extremely powerful language. However, SASS is not supported in the browser. It must be compiled into CSS. Luckily, there's a package for handling this process. In your editor, open the command line. Let's install the SASS package with the following command: npm install SASS. Out of the box, Vite supports SASS. We do not need to configure SASS. This means we can start writing SASS right away. In the previous lecture, we removed the import statement for our CSS file. Rather than importing a CSS file, let's import a SASS file. In the project, rename the style.css file by changing its extension to SCSS. The extension for writing SASS is SCSS. Next, let's open the main.js file. At the top of the file, import the main.scss file. Next, let's launch the server. In the command line, run the npm run dev command. For the rest of this section, you should always have this command running. Let's check out the app in the browser. As you can see, the styles are being applied to our elements. Otherwise, the text would not be centered. Vite was able to import the SASS file, compile it, and include it with the bundle. We can prove this behavior by opening the Elements panel with the Developer Tools. Search for a style tag in the head section of the document. If you know CSS, you already know SASS. SASS supports all CSS features from selectors to variables. It does not attempt to override the language. It simply extends it. Head back to the editor. In the SASS file, let's start exploring some of the cool features that SASS has to offer. The first feature is functions. It's common to apply color effects to an element during an event. For example, if a visitor hovers their mouse over an element, the color might change. Let's give that a try. Add an H1 selector. Set the color property to the following value, #cc3244. Next, add another selector called H1 hover. The value for the color property will be a function called darken. The darken function is not available in CSS. It's defined by the SASS language. This function will return a new color with a darker shade. Functions are written similarly to JavaScript functions. It's the name followed by a pair of parentheses. It has two arguments, which are the color and the percentage. Let's pass in the same color as before, which was #cc3244. The second argument is a percentage value. The higher the value, the darker the color. Typically, I like to use any value between 5 and 15%. Let's use 15%. Switch over to the browser. You shouldn't have to refresh the page. Vite will automatically reload the page for you during updates. If we look at the heading, the color is red. We can hover our mouse over the color to view the new color. As you can see, we do not need to calculate a darker color ourselves. SASS is capable of picking a color for us. In the resource section of this lecture, I provide a link to the list of functions you can use to change colors. Admittedly, the official documentation isn't that easy to read or navigate. I encourage you to take your time with it and experiment with some of them. Alright, let's continue exploring other features. Another cool feature of SASS is nesting. Head back to the editor. Switch over to the main.js file. Let's wrap the word Vite with a pair of span tags. It's not uncommon to style nested elements. Back in the CSS file, we can change the color of the span element by creating a selector called h1span. With SASS, we can take a different approach. Instead of typing this selector, we can add the span selector from within the h1 selector. Nested selectors are allowed. During compilation, the selector will be transformed into h1span. Initially, this syntax may look weird, but there are two benefits to this feature. Firstly, the precedence in CSS becomes clearer. When your code is formatted like this, it can be easier to see which CSS properties will dominate others. The second benefit is that you won't end up repeating the same selectors since it's easier to tell where you've written them. Inside the span tag, change the color property to blue. In some cases, you may need to reference the parent selector. A perfect example of this scenario would be the hover pseudo-selector. We could nest this selector inside the h1 selector like so. However, this solution won't completely work. This selector will produce a weird selector. It would be transformed into h1:hover. We don't want this. We want the same selector we had before. SASS provides a selector called the ampersand selector. Replace the h1 selector with the ampersand symbol. The ampersand symbol will represent the parent selector. SASS will replace this symbol with the parent selector. This will result in the selector being h1:hover. Let's try testing our code by switching to the browser. The span tag content will be the color blue. We can hover over this element to change the color to a darker color. Great! We've successfully learned another feature of SASS. SASS is a great language. It's definitely worth learning. I encourage you to play around with it and see what you can do. A single lecture doesn't do it justice, but it should suffice for now. Before I end things, I want to say that you don't have to be a master of SASS. We won't be using it heavily in this course. Just because Vite supports a tool doesn't mean you're forced to use it. We'll be focusing mostly on Vue, but it's always good to know what SASS is and how it works. In this lecture, we are going to move on to another package called PostCSS. SASS is a dominant language in the development world for extending CSS. As the years go by, it's starting to lose popularity. Another package was introduced called PostCSS. It takes an entirely different approach from SASS. You can use PostCSS over SASS, or a combination of both. Before getting into PostCSS, let's talk about how SASS works. SASS is a preprocessor language because it's a language that gets compiled into CSS. It's because browsers don't understand SASS code. There are dozens of preprocessor languages available, like Less or Stylus. In the end, they all get compiled to CSS. PostCSS takes a different approach. It is not a language. There is no special file extension. Instead, it's a library written in JavaScript. It'll convert your CSS into an object. The object it generates can be manipulated and transformed with JavaScript. Once you've made your changes, the object will be compiled into CSS. The advantage here is that we can use JavaScript to interact with our CSS code. This is why it's called PostCSS. It is a library that can modify your CSS code after you've written it. PostCSS is popular within the Vite and Vue community. Unlike SASS, we do not need to install the PostCSS package, nor do we need to configure this package. It's installed and configured by Vite. This feature gets activated by creating a specific file in our project. In the root directory of our project, create a file called postcss.config.js. PostCSS will search for this file. If it finds this file, it'll load the configuration settings. Inside this file, we must export an object. The object will contain our configuration settings. There are several things we can do, but we'll keep it simple. By default, PostCSS does not apply changes to your CSS. You must install plugins for manipulating the output of your CSS. There are two options at our disposal. Firstly, we can install plugins from third-party developers. Secondly, we can develop custom plugins. For this demonstration, we are going to use a third-party plugin. Vendor prefixes are an important feature of CSS. They allow us to use experimental features in our CSS. However, we may forget to use a vendor prefix. There's a plugin for automatically applying vendor prefixes to your CSS code. There's a vast repository of plugins available. In the resource section of this lecture, I provide a link to a site called PostCSS Parts. This site provides a list of plugins from the community. I highly recommend bookmarking it if you plan on using PostCSS in future projects. Let's switch back to the editor. Inside the command line, input the following command: npm install autoprefixer save-dev. This module is a plugin for PostCSS. It'll scan our CSS properties for missing vendors. It'll add vendor prefixes to properties that require a vendor prefix for older browsers. After installing this plugin, we must load it from within the configuration file. In the configuration file for PostCSS, we'll add a property called plugins. Its value will be an array. Inside this array, we can load a plugin by calling the require function. This function accepts the name of the package to load. Let's pass in autoprefixer. Great! The plugin should get loaded into our workflow. To test our code, let's update our CSS. Open the style.scss code. PostCSS does not work with SASS. Luckily, Vite will process SASS first. After the SASS file has been compiled into CSS, the CSS will be passed on to PostCSS. It's perfectly fine to continue using SASS. Alternatively, you can switch back to CSS and remove SASS from your workflow. Either option is at your disposal. Inside this file, let's add a selector called : placeholder. Next, change the color property to red. The placeholder selector will allow us to manipulate the properties of an input's placeholder. Developers will add this selector to change the color of the element. This selector has a prefix for Firefox. What if we forget to add the prefix for this browser? No problem. The autoprefixer plugin will add it for us. Let's save our file. Next, we may need to restart the server. Otherwise, the plugin may not be applied to our project. In the command line, restart the npm run dev command. So far, we shouldn't receive errors. Let's view the application in the browser. Nothing has changed. In the Developer Tools, open the Elements panel. Search for the style tag in the head section of the document. The placeholder selector was duplicated. The second copy of this selector has the Mozilla prefixer applied to it. That's great. We never have to worry about forgetting to add a prefix to our CSS. In addition, we can purposely leave out prefixes from the original codebase. It'll keep our code clean. PostCSS can handle adding the prefixes during compilation. That's all there is to PostCSS. It's a tool you can configure with plugins to transform the output of your CSS. In this lecture, we are going to explore a tool called ESLint. Code quality is an important part of development. We should always be consistent and error-free. JavaScript is a great language, but it does not enforce strict rules for formatting our code. For example, open the main.js file. Inside this file, we're using single quotes. Let's say our team wants to use double quotes. From time to time, we may forget to use double quotes in a file. It's not uncommon for developers to be inconsistent with their formatting. JavaScript will not complain. As far as JavaScript is concerned, everything in the file is valid. This is where ESLint joins the picture. It'll enforce stricter standards in our code. We can create a set of rules to apply to our code base. If we break a rule, we'll be informed by ESLint. We can catch problems that normally won't be caught by an environment. Let's give it a try. In the resource section of this lecture, I provide a link to the official site for ESLint. On this page, we're given an example of a command for installing ESLint into our project. Let's copy this command to our clipboard. Next, switch over to the command line. Paste and run the command. Vite does not provide support for ESLint. This is one of the instances where a package is not automatically installed or configured for a project. We must manually integrate ESLint into our workflow. Luckily, it's really easy. Vite is easy to extend. In the command line, run the following command: npm install vite plugin ESLint save dev. This package will instruct Vite to run our JavaScript code through ESLint for code quality. While not necessary, it'll be easier to use this plugin. Next, in the root directory of the project, create a file called vite.config.js. This file can contain the configuration settings for Vite. The name is very important. Otherwise, Vite will ignore our settings. Creating this file is optional. If this file does not exist, Vite will stick to its original configuration. In our case, we're trying to add support for ESLint, which is not part of the default configuration. In this file, we must export an object. Inside this object, we can add a list of settings. While exporting an object is not a bad thing, there's an easier way to configure Vite. I'm going to add a property called plugins. As I do so, I don't receive help from the editor for correctly spelling this property. What if I make a typo? It does happen from time to time. We should try our best to avoid wasting time. Vite has a function for helping us with code completion. At the top of the file, import a function called defineConfig from the Vite package. Next, we can wrap the object with this function. This function will return the object passed into it. Seems redundant, but it does offer code completion. Let's try typing the plugins property again. This time, the editor will be more helpful with the property name. It'll offer to complete the line of code for us. It's a simple workaround, but you can never be too careful. I prefer to use this function to avoid errors. Let's set this property to an array. In this array, we can start adding plugins from other packages. Before uploading this array, we must import the ESLint package. At the top of the file, import the ESLint function from the Vite plugin ESLint package. Next, call the ESLint function from within the array. That's all there is to it. ESLint will check our code during development. Let's switch over to the command line. In the command line, start the server with the npm run dev command. The command line is going to throw an error. This is to be expected. We installed ESLint, but we haven't configured it. ESLint will search for a configuration file from within our project's directory. In the next lecture, let's work on configuring ESLint with our project. In this lecture, we are going to configure ESLint with our project. We took the first step by installing ESLint. The next step is to configure ESLint directly. Keep in mind, ESLint is a separate package from Vite. This package requires a separate file for configuration. There are various ways to configure ESLint. We can add the settings directly to the package file. Alternatively, we can create a separate file. I prefer to create a separate file. This reduces clutter in the package file. It'll be easier to focus on ESLint by using a separate file. In our project's root directory, create a file called .eslint.rc. Inside this file, we'll input an empty object. This object should contain your settings. In this object, add another object called rules. In the resource section of this lecture, I provide a link to an official list of rules in ESLint. We have the option of picking and choosing which rules should apply to our codebase. We're not forced to use everything at once. ESLint does a great job of providing a description for each rule. If you need more info, you can click on a rule for code examples. For this demonstration, we are going to enable a rule for enforcing double quotes. Head back to the editor. In the rules object, add a property called quotes. This rule will enforce double quotes. The value for this property can be one of three values. We can set this rule to off to prevent the rule from being applied to our codebase. This is the default value for most rules. The second possible value is warn. ESLint can cause our project not to be built. The warn value will allow errors to go through, but will display the problem in the console. The last possible value is error. Unlike the warn value, the error value will not allow our project to be built. We must address the issues thrown by ESLint before building our project. Let's set this rule to error. The rule is ready. However, we're not finished yet. Below the rules object, add an object called environment. There are dozens of environments JavaScript can run in. ESLint doesn't assume which environment our code will run in. We can specify the environment through this object. In our case, our app runs in the browser. This property will be set to an object of environments we can turn on or off. Add the browser environment and set it to true. By enabling this environment, ESLint will not throw errors related to the browser. Next, add an object called parser options. In our script, we're using import statements. We must add explicit support for ES6 import statements by configuring the parser. In this object, add a property called ECMA version. This property's value should be the version of JavaScript. Set the version to 2022. Next, add the source type property. This property's value should be set to module to support import statements. Our configuration is ready. The next step is to start the server. If you have it running, you will need to start it. The configuration settings will not take effect until the server has been restarted. In the command line, run the npm run dev command. After a few moments, an error will get produced by Vite. The error stems from the code quality check by ESLint. As you can see, the error informs us of the file name and line numbers. In addition, a description is given for each error. In the main.js file, we have strings created with single quotes. Let's open this file. While it's great that ESLint caught these errors, we have one problem with the presentation of the errors. We must constantly switch to the console to check for errors. It would be great if the editor could point these errors out from the file. Fortunately, there's an extension for adding this feature. Switch over to the Extensions tab for Visual Studio Code. In the search box, search for an extension called ESLint. This extension is managed by Microsoft. Let's install this extension. You may need to restart your editor after installation. I'm going to quickly do so. After enabling this extension, red lines will appear under our code. We can hover our mouse over these errors to inspect them. As you can see, we can read errors directly from the file. We do not need to switch to the console to discover errors. That's great. The question becomes, how can we fix this error? There are two options. Firstly, we can manually fix these problems. But what if we had dozens of errors? It would be a nightmare to fix our issues. The second solution is to allow ESLint to fix our errors. Open the package file. Under the scripts object, add a new command called lint with the following value: ESLint main.js fix. The ESLint command is available from the ESLint package. This package will perform the linting process. If you want to use ESLint without tying it to a specific tool, you can use this command. After this command, we must specify a file to lint. Lastly, we're chaining a flag called fix. By default, ESLint will only output errors. However, we can force ESLint to fix any errors found by it. Fixing errors is not always guaranteed. If it fails to fix an error, you may need to manually fix the error. Let's try running the command. In the command line, run the npm run lint command. After a few moments, the file should have been updated. If you switch to the main.js file, the errors have gone away. ESLint swapped the single quotes with double quotes. Awesome! We've successfully fixed the problems with our file. Technically, single quotes do not produce errors, but we are enforcing a standard in our project. Overall, ESLint is a powerful tool for checking the quality of our code. We've only scratched the surface. As we dive into Vue, it'll help us catch basic problems, such as unused variables or import statements. Let's continue exploring tools in the next lecture. In this lecture, we are going to get a brief overview of Webpack. Throughout this section, we've dedicated our time to learning about Vite. Vite is going to be our primary choice of a module bundler. However, you may encounter Webpack during your career as a developer. This lecture will give a quick overview of what Webpack is and how it works. In the resource section of this lecture, I provide a zip file. Download this file, unzip the contents, and point your editor to the directory with the files. I recommend uploading these files to an empty directory. Pause the video if you need. Once you're ready, let's try installing the dependencies. Open the command line. Let's run the npm install command. While the packages are being installed, let's explore the files. The script and CSS files are copies of the files from the Vite project. The project I've provided will output the same behavior as the previous project. However, these files are bundled with Webpack instead of Vite. Let's open the webpack.config.js file. Unlike the Vite configuration file, there are dozens of lines of code. Webpack is more hands-on than Vite. As far as Webpack is concerned, only JavaScript code is supported. Support for other languages like CSS or SASS is not supported. Every tool must be configured in the bundling process. For this reason, Webpack has a higher learning curve. To save time, I've provided the configuration code for you. Let's review it together. During the bundling process, Webpack will search for this file. If this file exists in our project, it'll apply the settings exported by the file. There are 4 properties that can be configured. The first property is the entry point. Previously, Vite configured the entry point as the HTML file. For Webpack, we must set the entry point to a JavaScript file. The entry property allows us to specify the entry point of our application. In this example, we're passing in a relative path to the index.js file. Up next, we have a property called output. In addition to setting the entry point, we must tell Webpack where to save the bundle. In this object, there are two properties called path and file name. The path property should point to the directory. The value must be a full system path. To help us generate a full path, we're using a constant called directory name to point to the current project directory. This constant is defined by node. Afterward, we're appending a relative directory called distribution. This directory doesn't exist, but that's okay. Webpack will create it for us during the building process. As for the file name property, we can set the name of the file produced by Webpack. In this example, we're setting the name to bundle.js. Let's move on to the modules.rules property. As I mentioned before, Webpack supports JavaScript. Other languages or file types are not supported. We must add explicit support for other types of files. Loaders are packages that will help us support different files. In this example, we're adding support for two types of files, JavaScript and CSS. Each object in this array can represent a file type. In the first object, we're adding support for JavaScript. Hold on a moment. Didn't I say Webpack supported JavaScript? Well, that's true. The support may be lackluster. New versions of JavaScript are released annually. You may want to start using newer features from the language. However, these features may not be available in the browser. There's a package called Babel. This package adds support for new and experimental features in JavaScript. Oftentimes, developers will integrate Babel with Webpack. This is why I've included this object. This object has three properties. The first property is called test. Before a file is given to a tool, Webpack will test the file name against this property. Babel does not process CSS or image files. To avoid Babel from processing the wrong file, we can test the file name. The value for this property is a regular expression. It'll check the name for a JS extension. If this extension exists on the file, Babel will process the code. Up next, we have a property called exclude. It's not uncommon to import code from packages in the node modules directory into our project. There are thousands of files within this directory. To speed up the bundling process, we'll skip files in this directory. They should already be optimized for the browser or node. Lastly, we have a property called use. This property can be set to the name of the package that contains a loader for processing a file. In this case, we're using the Babel loader package to process JavaScript code. Let's scroll to the second object. The properties are going to be similar. The second object is testing for a SASS file. There is no exclude property. It's completely optional to add it in. Lastly, the use property is set to an array. We're not forced to apply a single loader. We can apply multiple loaders. In this example, we're applying loaders for SASS, CSS, and post-CSS. There is an additional loader called mini CSS. By default, Webpack will bundle our CSS and JavaScript into a single file. However, that's not ideal. We may want to separate both languages into their respective files. The mini CSS loader will handle extracting CSS from a JavaScript file. This loader can be configured through a plugin. Below the modules object, we have an array called plugins. Within this array, we can add plugins for extending Webpack with additional behavior. In this example, the mini CSS package is being configured by setting the file name of the CSS file. The last setting in our file is the watch property. By default, Webpack will build your project once. However, you may want Webpack to constantly watch your files for changes. Setting the watch property to true will enable this behavior. I know I flew through the configuration. This lecture was meant to give an overview. We're not going to be using Webpack. I included this lecture for those of you who are curious as to what the hype is about for Webpack. Let's try running Webpack. In the command line, run the following command: npm run start. In a few seconds, Webpack will watch our project. we can update our code for a new bundle to be produced. The bundle will be created in the distribution directory. If we look inside this directory, we're going to find the JavaScript and CSS code. There are some things missing from the Vite project. For example, an HTML file is not available. We don't have a server for previewing a project. It is possible to generate a server, but I wanted to keep this lecture brief. For that reason, I only included support for JavaScript and CSS files. In addition, ESLint is not checking the quality of our code. Webpack can support additional tools. Feel free to add support for these features. Anyway, that about does it. In the next lecture, let's wrap things up. I'll see you there. Congrats! You've made it to the very end of this section. We've only gone over the basics of each tool and its concepts, but it should be enough for you to tackle complex Vue projects confidently. For the rest of this course, we're going to use Vite. There are other tools Vue uses internally than the ones I talked about in this section. We'll review them as they arise, but the ones I mentioned in this section are the primary tools you'll most likely be dealing with from within your project. As always, I encourage you to continue your studies in each of these tools and libraries to make you into a better Vue developer. Now that we have an overview of things, let's get back into Vue. It's time to start developing applications. I hope to see you there. It's time to scaffold a project with a package called Create Vue. It's the official tool for building, compiling, and managing Vue applications. It's completely optional, but I absolutely recommend it if you plan on building complex Vue apps. Before running this package, let's talk about it briefly. The Create Vue package is a tool manager. Its purpose is to help you organize your files, pre-configure tools, and let you start building your application right away. The code base of an application can be broken into two parts. There's the application code and code from external libraries. Code from external libraries can be considered code from libraries like Vue or Axios. It's code we didn't write, but are using in our application. Application code is the code we've written to get a functioning application. Splitting your code base into different files is ideal for development. It makes things easier to manage and track. It allows for flexibility when you need to update files. The problem with this approach is the amount of files that can be present in an application. They can be scattered across several directories. This introduces the necessity for tools like Vite, PostCSS, and SASS. Tools can help us manage an application. Best of all, we can bundle files into as few files as possible. A new problem is introduced. These tools are independent from each other with separate configuration settings. On top of developing our application, we would have to take the time to manage a tool set. They need to be configured to work alongside each other. The more tools we introduce, the more complex configuration can get. It's a lot of work just to get an app up and running. This is where the Create Vue package comes into play. This package will help you with setting up a Vue project with Vite and other tools. Sounds redundant, but it makes the process massively simpler. It'll even provide you with a basic setup if you wish. Alternatively, you can create a custom setup for future projects. By using this package, our project will be ready for development and production. If you watched the previous section, you learned how exhausting it can be to configure tools. There's a lot that needs to be done before diving into app development. It's not a pleasant experience to go through every time you want to start a new project. Vue will expedite this process by asking you a few questions about your project. Based on your answers, it'll configure the tools necessary for running a Vue project. This tool will allow you to jump straight into your project. You also have the option of adding additional features you may need as your development workflow progresses. What took an hour to set up in the previous section will only take a minute with the Create Vue package. In the resource section of this lecture, I provide a link to the official Create Vue repository. Here you'll find more information about this tool and what you can do with it. At the bottom, we're given some commands to get us started with this tool. Let's try running the CLI together. Switch over to your command line. Inside the command line, input the following command: npm init vue at latest. After the at character, we can input the version of Vue. For example, we may want to create a project with version 2. We can input this version like so. If you're not interested in specifying the version, you can type latest for the most recent version of Vue. Before you run any commands, I recommend you place yourself in a directory exclusively for development projects. Vue will need some room to build the project when we run the command. Let's run this command. It can be dangerous to run packages. As an extra precaution, npm will ask us to verify our actions. In this case, I think it's safe to run this package. Afterward, we need to provide a project name. The name of our project will be called Components. The topic we'll be discussing in this section will be about components. The name will reflect that. Feel free to use a different name if you'd like. Up next, we're going to be asked a series of questions for specific packages. In the future, we are going to integrate several packages. For now, let's select No for everything. After selecting this option, Vue will begin creating, preparing, and configuring your project. This may take a while for some of you, just be patient. After some time has passed, Vue will tell us the project has been successfully created. From here, it'll tell us to execute a couple of commands to start the server. Let's move into the directory first. Before we start the server, let's briefly look at the files and directories. Some of these files should be familiar to you. If you know what these files do, then that's great. If not, that's fine as well. We'll review them shortly. We were able to get a starter project with a single command. It created a list of modules, configured them, and generated files for getting started. It saved us time from having to do this ourselves. From the beginning, you can see the benefits of using this package. We're free to edit any of these files. We can make changes to the current configuration at any point. We're not forced to use the default configuration settings. We'll dig deeper later, but let's try running on the server. Under the hood, the project has been configured with Vite. We have access to the same features as the previous project. This includes the server. We didn't use a server for most of this course. This is because we were dealing with 1 or 2 files. We weren't making external requests. We're going to be discussing more advanced topics. A server will be necessary because browsers impose limitations on files opened directly in the browser. To remove any limitations, we'll need to deliver the files via a server. Fortunately, we don't have to worry about the code that makes the server function. It works completely out of the box. This allows us to focus solely on the project itself. Switch over to the command line. First, we must install the packages from the package file. Packages are not installed for us. They must be manually installed. In the command line, run the npm install command. Next, type the following command: npm run dev. This is a command you can find inside the package file. This command will start a server. The server will bundle our project and serve the bundle for us. We can preview our project with this command. After a few moments, Vue will tell us that the project was successfully compiled. This is something important I want to highlight. If you can recall, there are 2 versions of Vue, one with the compiler and another without it. The one we're using in our project is the one without the compiler. Vite has been configured to compile the template during the build process. The template will be transformed into a render function. The final bundle outputted by Vite will not need to be compiled on the client. We can continue writing HTML and not worry about having to code objects for the virtual DOM. Below this log will be presented links to view our application. We can click on them to open a new tab in the browser. You will see something similar to what I see. There are links we can click on to learn more about the tools that were installed. One of the main selling points of Vue is its simplicity. However, for quite some time, in order to create complex projects, you had to learn and configure various tools. Vue was designed to allow us to focus on our project. There may be times when you'll want to configure Vite differently, but we'll take a look at that later. For now, the default configuration works fine. Therefore, we'll be jumping into the project very soon. In the next lecture, we'll go a little deeper into the files scaffolded by the Create Vue package. In this lecture, we're going to briefly talk about servers. In the previous lecture, we ran a command that started a server for us. We were able to view our application in the browser by visiting a special URL. Let's examine the URL closely. Our browser is pointing to a URL called localhost followed by some random numbers. What is localhost? What do these numbers represent? Our application is being served by a server. Let's explore what that means. A server is a machine similar to our personal computers. One of the major differences between a server and our computers is that there is no GUI. We can't click on icons, buttons, or view graphics in general on servers. So what's the point of having a server? A server can have software installed on them for handling network requests. The job of a server is to listen for incoming requests. Whenever we type a URL in the address bar of a browser, the browser will initiate a request to a server. The server is responsible for responding with some data. This can be a file like an HTML, image, CSS, or JavaScript file. The job of a server is to hold a copy of our application. The main benefit is not having to maintain the server on our machines. We don't have to purchase the hardware, set up, or maintain a server. There are services available that specialize in hosting applications on servers. Up until now, our application has been working without the need for a server. We've been opening files directly in the browser. We're going to be using some advanced features of the browser. Browsers limit features if we open files directly in the browser. This includes HTML files. Here's where our problem begins. We need a server to host our application. Luckily, we won't need to write a server. Vite provides a server out of the box. It allows for developers to continue writing Vue applications without having to worry about running a server. In the address bar, our app is delivered by a URL called localhost. Localhost is a special URL we can type in the address bar. If we type localhost, the browser treats the request differently. Instead of sending the request to a server located somewhere in the world, the request will be sent to our computer. This allows our computers to handle the request. Vite will run a server on our computers that can handle the request if we type in localhost. The server will respond with the HTML, CSS, and JavaScript files we have in our project. We don't need to write a single line of code to get this functionality working. That's great because it allows us to focus on our app. The CLI adds additional features to our project that make the development experience easier. The server will watch for file changes in our project. If a file is updated, the server will refresh the browser to show the latest changes. That saves us time from having to refresh the browser ourselves. There's a whole lot of other things the CLI can do for us which we'll learn about as the course progresses. There's one last question. What do the numbers represent? This part of the URL represents the port number. You can think of ports as doors to a house. A house can have numerous entrances. One door leads to the kitchen, another leads to the bathroom, so on and so forth. Similarly, servers have ports for accessing different parts of a server. The browser needs to know which door on the server leads to the application. Multiple applications can exist on a server. We need to assign a port for our app. By default, the CLI will assign the app to a port for us. The port can be specified in the URL by adding a colon after the domain. This character is followed by the port number. Normally, we would never have to add the port number to the URL. For example, let's change the URL to google.com. The port number is not necessary for this URL. The reason we don't need to add a port number is because most browsers will default to port 80. Most applications are configured to be delivered over port 80 on the server. Port 80 is the recommended port when shipping an app to production. So why does CLI use a different port? Only one application can be assigned to a port. You can't have multiple apps using the same port. On most personal computers, it's possible that port 80 may have been taken. Luckily, computers have thousands of unused ports. The CLI will search for an unused port. It'll reserve the port for our application. This way, we can view the app on our machines locally. That wraps it up for now. We can tell the browser to access our server by typing in localhost in the URL. We don't have to worry about the restrictions imposed by the browser because we have a server to deliver our app. In the future, we'll look at how we can upload the app to a server for production. For now, we'll be working locally. In this lecture, we're going to review the files generated by the Create Vue package. We'll start with the root files. Then, we'll move on to the directories. The very first file is the gitignore file. This file is for those who plan on using Git or GitHub. It'll instruct Git what files should be ignored when you push files into the repository. You don't want to upload every file in your project. The CLI has taken the opportunity to list files you shouldn't upload. Files that shouldn't be shared with others. If you plan on using Git for this course, then this file is beneficial to keep around. For this project, we won't be using Git. Feel free to delete or ignore this file. The following file is called index.html. If you were to look inside this file, it'll be the same HTML file from the vanilla JavaScript project with minor modifications. Overall, the index file serves as the entry point to our application. It's importing the script file from a directory called source. We'll look at this file in a moment. Up next, we have the package file. There are some interesting things going on in this file. Firstly, the dependencies object contains the Vue package. Previously, we installed Vue through a CDN. This time, we're going to work with a local copy. In the development dependencies object, we have an additional package called plugin Vue for Vite. Naturally, Vue does not work with Vite. Vite does not assume which front-end framework we're using. For this reason, we are installing an additional plugin for integrating Vue with Vite. Moving forward, we have the README file. The contents of the README file has information about how to run the project. Basic information to help you get up and running. There's even a link on how you can configure the project created for you. The topics covered in the documentation are things we'll go over as the course progresses. Lastly, we have the vite.config.js file. There are two noteworthy things about this file. Firstly, Vue is configured with the project by importing the Vue function. This function is called directly from the plugins array. Luckily, we don't need to dive into the inner mechanics of this plugin. All we need to know is that the plugin will help Vue understand Vue files. If we were to view the files inside the source directory, we'll find some files with the Vue extension. The Vue plugin will help Vite process these files. We'll explore what Vue files are later in this course. You may have noticed it already, but a configuration file for post.css is not present. It's one of the tools we discussed earlier. Despite that, the Vue plugin will configure post.css for us. It may not look like it, but our project's CSS will be processed by post.css. Regardless, you may want to configure post.css. We are allowed to configure post-CSS by adding the post-CSS property to the package file. Vue will prioritize the settings in the package file over its own. Feel free to add it. For this project, the default configuration will work fine. The second noteworthy thing in this file is the resolve.alias property. You can think of an alias as a shortcut to a directory. Throughout this course, we're going to be importing dozens of files in nested directories. It can be tedious to write paths to files. To keep things simple, we can create an alias to a specific directory. In this configuration file, we're provided an alias called @. This alias points to the source directory. Here's an example. Let's say we had a file called example.js. There are two options for importing this file. Firstly, we can type the path to the file. Alternatively, we can replace the source directory with the character. Vite will handle replacing this character with the appropriate path. Keep in mind, the alias is only available with Vite. We can't use the alias outside of it. Using the alias is completely optional. That concludes the files in the root directory of our project. Up next, we have 3 directories. The Node Modules directory will contain the modules installed for this project. The public directory contains your static assets like images and HTML files. By default, the project will provide us with a favicon file. There's not much going on in this directory. Next up is the source directory, which is probably the most important directory. It will contain most of your application's logic, templates, state management, etc. We will be spending a majority of our time in this directory. Let's start with the main.js file. Inside this file, we're importing 2 things: the createApp function from the Vue package and an object called app. The createApp function is what will create the application as we've learned in previous sections. The Vue module can be found inside the Node Modules directory. The project is set up to automatically look for the Vue module. You don't have to worry about the path. The app module is a bit peculiar. We're not loading a plain JavaScript file. We're loading a Vue file. Vue files are considered components. They all end with the Vue extension. Upon inspecting the file, you will find a lot is going on. Before I break down what's going on, you may not have syntax highlighting for this file. If you're using Visual Studio Code, you can install a plugin called Volar. This plugin will enable syntax highlighting for Vue files. I recommend installing it if you have Visual Studio Code. If you're using a different editor, search for a plugin that will enable syntax highlighting. Let's break down what's inside a Vue file. Files that end with the Vue extension are called single file components. Single file components are made up of 3 blocks. There's the HTML, JavaScript, and CSS. The HTML is placed inside the template block, the JavaScript is placed inside the script block, and the CSS is placed inside the style block. All 3 blocks are compiled into a JavaScript object. This way, when we're importing the object in other files, it'll be usable because it's an object. The object exported will contain all 3 blocks. Let's examine what a single file component looks like after it's been compiled. Inside the command line, we'll run the command npm run dev and open the page in the browser. Next, I'm going to switch back to the app component and make a small change. I don't expect you to follow along, just watch. After making this change, I'll switch back to my browser with the developer tools opened. Inside the network panel, there will be a request that we can click on. This request will contain the changes made to the file. I'm going to copy everything inside this request and paste it into a random file. Alright, as you can see, I've stripped down what was returned by the request. I've removed most of the references to Vite. They're not needed to understand this example. This is the only part that matters to us. I know I went through a lot to get to this point, but this is the main thing I want you to focus on. Don't worry about the other stuff. This bit of code is what the template inside the app file gets compiled to. it gets turned into a render function. Inside the render function, there's a lot of confusing things going on. However, understand one thing. The value returned by the render function must be an object that represents the elements we want to render on the document. This function has been produced by Vite and the Vue plugin. The purpose of writing single file components is to make this process easier. If you had to pick between writing out your application between a render function and the single file component, then you may lean towards the single file. That's the basics of it and all you really need to know. We're going to continue using single file components as it makes our code readable and manageable. Let's go back to reviewing the files. Back inside the main script file, we're using the createApp function to initialize the app. We're passing in the app component to the createApp function. Vue will run the render function because that's what the single component file will be compiled to. The last thing going on here is the Vue application being mounted. The mount method is called to start this process. This wouldn't work without Vite. Thanks to Vite, creating components has been simplified. This has been a basic review of everything. Of course, there's way more to it, but we'll dive into other topics as the course progresses. It's time to start writing some code. When we installed the project, we were given a few starter files inside the source directory. It provides a basic example on how you would create components and structure them. That was nice and all, but I want to start from scratch. We'll clean up the project so that we can focus on the basics. We're going to delete the components and assets directories. Neither are necessary. Then inside the app component file, we're going to remove the style block. Adding CSS to a component is completely optional. If you decide not to have stylings for your component, then Vue will not throw an error. We're also going to reduce the code inside the script and template blocks. On the script block, remove the setup attribute. This attribute is a shorthand syntax for the composition API, which we won't be using in this section. Unless I state otherwise, this attribute should always be removed from the script block. The bare minimum requirements for a single component file to be valid is the template block. The template block must contain at least one root element. We're allowed to have multiple root elements in an application. Inside the template, we're going to add a simple greeting in the form of a paragraph. Let's make the greeting more dynamic. Inside the script block, we're going to export an object. The object we're exporting will be used for the component settings. This is where you should add your data, methods, computed properties, and watchers. Everything's the same as before. Before we jump into adding the data, I want to assign this component a name. We'll add a property called name. The name property isn't required, but it can be useful for debugging. The Vue Developer tools will use this property for the name of the component. Sometimes Vue will display components as anonymous when it doesn't know what name to give it. By assigning a name to your components, it'll become easier to identify them in the developer tools. We'll set the name option to app. You can name your components whatever you want. Generally, you should keep it to alphanumeric characters and hyphens. Next, let's set up the data function. Inside this object, we'll add the property message with a value of hello world. Next, we'll replace the static text in the template with the expression message. Let's give things a test. Inside the command line, run the command npm run dev. You shouldn't receive any errors thus far. We'll preview the app in the browser. We'll see the message get outputted in the browser. This confirms the component is working. Almost everything we've learned so far still applies to components. The main difference is that we have a better separation of logic. It's much easier to work with components when the template has syntax highlighting. If we were to open the Vue Developer Tools, we would find the component with the name we gave it inside the name property. Once again, this is useful for debugging. The Dev Tools tend to give some components the name anonymous. Assigning a name to your component will stop that from happening. The Developer Tools will capitalize the name for you if you decide to keep it lowercase. That's the basics of creating a component with single file components. We'll continue exploring what else we can do with component files in the next lecture. In this lecture, we're going to move on to the next step, which is creating child components. We already saw how to do this previously, but there are a couple of additional things I want to show you. What we'll do is put the greeting into its own component. It shouldn't be difficult to pull off. In fact, why don't you give it a try? Try creating a greeting component with a dynamic message. Then try loading it inside the app component. Pause the video and good luck. Welcome back. If you were able to take on the challenge, then congrats. If not, that's fine as well. We'll do it together. The first step is to create the file. It's always good practice to keep your components organized. We'll place our child components inside a separate directory. Inside the source directory, create a folder called Components. Inside this newly created directory, create a file called greeting.vue. It's common practice to use camel casing for your component names. It's not required, but recommended. Inside this file, we'll want to add the template and script blocks. We can type those blocks out, but there's an easier way to create them. Switch over to the Extensions tab. There's an extension created by the community of Vue for creating components. Search for an extension called Vue VS Code Snippets by a user called Sarah Drasner. Install this extension on your editor. It's going to be helpful. After installing it, switch back to the greeting component. If I start typing Vue, then Visual Studio Code will provide me with a drop-down of snippets I can add to the file. This is possible thanks to the Vite extension we installed. If you're not using either of those, then you'll need to type out the blocks manually. You can select any of these options and Visual Studio Code will pre-fill your file with the snippet you selected. I typically like to go with the very first one. After selecting it, all three blocks are inserted for us. We're going to remove the style block because we won't be using it. In addition, the setup attribute can be removed. For the rest of this course, I'm going to use this shortcut whenever we create single file components. Unless I say otherwise, I will also remove the style block whenever I do so. It's not something we will use often. Let's continue working on the component. For the template, we're going to cut and paste the paragraph element from the app component to the greeting component like so. Next, we're going to copy the contents of the script block from the app component. We'll paste it into the greeting component. We're going to need to make one change to the greeting component. We'll change the name to greeting. We're finished with prepping the greeting component. The next step is to load this component inside the app component. Switching back to the app component, we don't need the data property anymore. It has been moved into its own component. Therefore, we'll remove the data function. The next step is to load the component. There are two ways to load a component. You can do it on a global level and on a local level. We learned how to do it on the global level previously. To register a component globally, we need to use the component method. Let's use this method inside the main.js file. This is the file where we are initializing the Vue application. We'll need to make some adjustments to the way we initialize the application. Currently, we're chaining the mount method. However, we need to register the component before we mount the application. We'll separate this by assigning the returned value from the function to a variable called VM. Afterward, we'll chain the mount method to the variable. In between these two lines, we'll register the component. Components must be registered after a Vue instance. We'll call the component method on the VM variable. At the top, we'll import the greeting component. There are two things I want to quickly note about this import statement. We're including the Vue extension in the import statement. We need to make sure Webpack understands we're importing a single file component. Be sure to include this extension in the import statement. Secondly, the name of the import is called greeting. This is the same name in the component's name property. This is common practice so that it's easier to find the component, but you can call it whatever you want. You don't have to use the name you assigned in the name property or the file name. From here, we can pass in the name of the component, which will be greeting, and then the component itself. We don't have to worry about passing this in as an object. Webpack will compile it into an object. Vue will understand what we're trying to do. This is how you register a component globally. Global components can be used anywhere in Vue. This includes children components. However, this usually isn't recommended. Global components tend to make optimization harder for module bundlers like Webpack. Our application will still work, but it's best practice to register a component locally. That way you don't end up loading every single component in your application, even the ones that aren't active. Let's learn how to do that. We're going to comment out both lines. Local components can only be used in the component it was registered in. The app component is the only component we have that will be using the greeting component. To register a component locally, we can add a property to the configuration called components. The value for this property is an object. The object will contain a list of components that can be used inside this component. Like last time, we'll need to import the greeting component. Next, we'll add a new property to the object where the key name will be the name of the component and the value will be the component itself. The key name will be greeting. The value will be the greeting component. Thanks to ES 2015, we can shorten this to greeting. It'll automatically be interpreted to what we previously had. This is how you register a component locally. The components property allows you to specify what components the current component can use. The last step is to use the local component. In the app components template, we'll add a pair of tags with the name greeting. Let's refresh the page in the browser. We will still see the greeting in the document. Using the Vue Dev Tools, we'll find the greeting component nested inside the app component. This confirms that our app is using the greeting component we registered. Checking the Dev Tools is a great way to verify if a component is being registered successfully. Vue gives us the flexibility of registering a component globally or locally. I always recommend local registration unless you know for sure that a component will be used in multiple locations. In the end, it's completely up to you. It's all preference. In this lecture, we're going to discuss how to add styles to a component. There are a total of 3 blocks in a single file component. The template block is for your component's template code. You can insert expressions, directives, and use other components. The script block is for your component's options. This includes the data, methods, and business logic of your application. You will most likely use both blocks in almost every component. There is one additional block, which is the style block. Its purpose is simple. It's where we can define the styles for a component. We previously removed it. Let's add it back into the greeting component. From here, we can apply any stylings we like. Let's change the color of the paragraph to the color red. Next, let's try viewing the page again. Make sure your server is running by running the npm run dev command. After viewing the page, we will see the paragraph with the text color changed to red. This works, but it's not perfect just yet. We're going to inspect the element to view the paragraph styles. The color change is going to apply to all paragraph elements. It would be more ideal if the color change would apply to the paragraph elements in the component. The first solution would be to use IDs and classes. That would work, but Vue provides another solution you may want to consider. In the future, browsers will support something called the Shadow DOM. The Shadow DOM makes it possible to have multiple DOMs inside your document. The main benefit of the Shadow DOM is that it lives in its own little world. Any changes you make to that part of the page will only be reflected on that part. Vue is able to do something similar with its virtual DOM. You saw an example of this with the data property. Any data defined in a component is isolated to that component. Vue is able to isolate styles to a component. It borrows that idea from the Shadow DOM. The Shadow DOM is not to be confused with the virtual DOM. The virtual DOM is a JavaScript object that is a copy of the real DOM. The Shadow DOM is an isolated DOM from the real DOM. Let's learn how we can isolate styles to a component. First, let's create a paragraph tag outside of the greeting component. We'll add one inside the app component above the greeting component. It'll contain some static text. Next, switch back to the greeting component. We're going to add one simple attribute to the style block. The attribute we'll want to add is called scoped. By adding this attribute, Vue will compile the template while making sure the styles are only applicable to the component. To better understand what will happen, let's read the documentation. In the resource section of this lecture, I provide a link to the scoped CSS documentation page. Here is what Vue has to say about scoped CSS. When a style tag has the scoped attribute, its CSS will apply to elements of the current component only. This is similar to the style encapsulation found in Shadow DOM. It comes with some caveats, but it doesn't require any polyfills. Below are some examples. In the first code snippet, the scoped attribute is added to the style block. The second code snippet shows what the final result will be. Vue will add a data attribute to the elements from the component. The CSS selectors are modified to select an element based on the data attributes added to the elements. It's done for you automatically behind the scenes. This allows you to keep your code fairly minimal. We don't need to use ID or class names to achieve the same results. The styles we apply to a component will not affect elements outside of the component's template. Let's view the application one more time to see the result. There are two paragraph elements, one from the app component and another from the greeting component. We added a scoped style to the greeting component. It'll change the color of any paragraph elements to the color red. The paragraph inside the app component doesn't get changed to the color red. Only the paragraph tags inside the greeting component are changed. If we were to inspect the element, then we'll quickly find a data attribute has been added to the element as noted in the documentation. This was added in when the template file was compiled. One question I get asked is why does Vue choose to mimic the behavior of the Shadow DOM instead of actually using the Shadow DOM? The Shadow DOM is not completely supported in all browsers. Therefore, Vue will simulate the behavior of a Shadow DOM by adding additional details to your component. Despite the change, the concept is still similar. We can continue to make changes to the paragraph tag or any other elements inside the component. Those stylings will only be applied to the component itself. Sometimes you may want to check if the stylings are correctly loading in the document. If we were to go to the head section of the document, we'll find a style tag that's been dynamically added. Vue will generate a style tag with the CSS you've written for the component. That's the basics of adding styles to your components. We've learned how powerful scopes styles are. One of the major benefits of using scoped styles is that we didn't have to worry about dealing with classes or IDs. We didn't have to worry about stylings leaking into other areas of the page. This keeps our stylings clean and concise. We're using plain CSS at the moment. What if we wanted to use SASS? We'll look at how to use SASS in our application in the next lecture. In this lecture, we're going to learn how to use SASS in our project. The CSS we've written in our components is being processed as plain CSS. If you watched the previous section, you may be aware that I introduced SASS. The project we are currently working in does not have SASS installed, but it's easy to add if you prefer to use SASS. If you have the server running, then you will need to turn it off. Otherwise, we won't be able to install additional modules. Afterward, inside the command line, run the following command: npm install SASS, save dev. Next, open the greeting component inside your editor. We'll add an attribute called language to the style block. Its value will be SCSS. Our project is now using SASS. The great thing about using the preset that came with the Vue CLI is that it's configured to use most CSS preprocessors like SASS. Adding the language attribute will instruct the compiler to use the preprocessor for the language you're specifying. Let's give it a try. Update the selector with the hover pseudo-selector. Next, set the color property to the darken function with the following arguments: #cc4444 15%. Lastly, we'll turn on the server. We'll refresh the page one more time. Sure enough, the stylings still get applied. The SASS code gets compiled into CSS. It's a very simplistic approach to writing CSS. There's a lot more to using CSS in Vue, but we'll get to those subjects later. I encourage you to read the documentation to help you get a better understanding on how to use CSS in Vue. The more advanced topics are things we'll get to once we need them. We've learned how to create components and use them within one another. Any data you put inside a component will belong to that component. This means that you can have two components with the same property names without having to worry about naming collisions. This works for some scenarios, but there will be other scenarios where you'll want to communicate data between each component. Let's look at this diagram for a moment. We have three components. Component A is the parent component to component B and C. Component A is also known as the root component because it sits at the top of the hierarchy of components. Components B and C are not just children components to component A. They're considered sibling components to each other. This is because they sit on the same level in the hierarchy. Parents, children, and siblings are all terms you'll hear when discussing components in relation to each other. Let's take a look at how this will apply to what we're going to do. We're going to have three components for this example: the app, greeting, and user components. The user component currently doesn't exist in our project. We'll be adding it shortly. In this application, the user component will have a property called age. The greeting message will be based on the user's age. If their age is below 25, then we don't want to greet them. If they're above 25, then we will greet them. The question is, how do we send the age to the greeting component when it's stored inside the user component? The solution may be to send the data over to the sibling component, but that's currently not possible. Vue doesn't offer a way for components to send data to their siblings. If it isn't possible to send data to sibling components, then how do we share data? The real solution is to store the data inside the app component. We'll be able to send it down to the children components. Parent components are able to send data down to their children components. Therefore, it would make sense to store the data inside the parent component. From there, we can send data to components that need them. Data that is sent to components are called props. They're another way of adding data to your component. Let's learn how to use them in the next lecture. In this lecture, we're going to learn about how to use props in our components. You can think of props as custom attributes for our components. We can use props to customize the behavior of a component similar to how HTML attributes change the behavior of an element. Let's prepare our project. We'll start things off by creating the user component. Inside the components directory, create a file called user.vue. We'll add the template and script blocks. Next, export an object with the name property assigned to the value of user. We'll keep the template simple. It'll be a set of paragraph tags with the following text. The user is X years old. The user component is ready. The next step is to register it inside the app component. Inside the app component, we'll register the user component. The user component has been registered to the app component. We'll add the user component below the greeting component. Something I want to note is that the component can be written differently than how you define it inside the components object. Vue will use the name of the property as the name of the tag. You have the option of writing the tag name with lowercase letters even if the property name is using uppercase letters. In this example, we're using the lowercase version for the tag name. Vue allows you to write it either way, which can be nice since most element names are lowercase to begin with. We're going to change the greeting component to use the lowercase version. From here on out, we'll use the lowercase versions of components names inside the template block. One final adjustment. We're going to change this paragraph tag to an H3 tag. We're doing this so that it can stand out a little more when we're working on the application. Before we start adding data into the mix, let's confirm that the code is working. We'll refresh the page. Surely enough, everything is working properly. The user component is loading in just fine. We'll open the app component. We're going to add the data to the app component, not the user component. This way we can pass it down to both the greeting and user components. We'll add the data function using ES6 syntax. Inside this function, we'll return the object with the age property. We're giving the age property a value of 20. With the dataset, let's pass it onto the user component. Inside the template, we're going to add an attribute to the user component. In order to pass down data, we need to pass it in as an attribute. The attribute name can be whatever you want as long as it doesn't conflict with other attribute names. I recommend naming it something relevant. Since we're passing down the age, I think it would be appropriate to call it age. The value of this attribute is what will be passed onto the component. We want to pass down the age data property. You can hard code the value or you can make it dynamic. It's important to understand that the value will not automatically be interpreted as an expression. You have to bind it if you wish for it to be an expression. If we were to pass it like this, then Vue will assume you want to pass down a string. Therefore, we'll have to add a colon before the name to bind the attribute. Now Vue will send the age property inside the data object. We're not finished yet. The user component needs to accept the age. Switching to the user component, we're going to add a new property to the exported object called props. Props is short for properties. This will be set to an array. The array should contain a list of properties that the component will accept. We're going to accept the age. It's important that the name inside the props array matches the attribute name. This is how Vue connects the two. The age property is now available in our component. You can use it in expressions, directives, and methods. Inside the user components template, we'll replace the X in the static text with an expression that'll use the age. There's nothing more we need to do. Let's refresh the page. The user component displays the age dynamically. Even though there isn't a data property inside the user component, it's still able to use the age as if it were its own. The great thing about this is that the age will automatically be updated if the age in the parent component changes. Any changes are trickled down to children components. I can even prove this to you. Using the Vue Dev Tools, view the list of components available. The app component will have the age under the data category. If we were to view the user component, it'll have the age listed under the props category. Despite being in a different category, we can still use the age like any other data property. If I were to switch back to the app component, I'll be able to edit the age. If I increment or decrement the value, then you'll notice the age up top changes as well. If the data inside the parent component changes, then all children components will reflect that change too. Vue handles that process for you. However, it doesn't necessarily work in the reverse. If we were to attempt to edit the age inside the user component, then we'll quickly discover it's not possible. There are a couple of reasons for this which we'll explore in the next lecture. In the previous lecture, I showed you how to pass down data to a component. Once the data has been passed down, the child component can use the data in expressions, directives, and methods. However, there are some limitations you should be aware of, specifically on how you update the data. Before we review the limitations, let's pass the age onto the greeting component too. Inside the app component, we're going to pass on the age to the greeting component. It'll be the same as before. We'll bind an attribute called ageSet to the age data property. Inside the greeting component file, we'll add the props property and accept the age property. The next step is to use the age. Right after the first paragraph element, we'll add another one with the following message. You must be 25 years or older to view this message. For the first paragraph, we'll add the VIF directive. The condition will be age greater than 25. The second paragraph will have the VElse directive. The first paragraph will be rendered if the age property is greater than 25. By default, the age is set to 20. This will return false. As a result, the first paragraph will not be rendered. The second paragraph should render since it has the VElse directive. This is a very simple use case of conditional directives. This will always display the second message because we have no way to change the age in the application. Let's add a button that will do just that. Inside the app component, we'll add a button below the heading. We're going to listen for the click event and increment the age whenever the button is clicked. With those changes made, let's check out the application. Initially, we'll be greeted with the second message. If I were to click the button, then the first message will eventually appear. Both the greeting and user components are updated with the latest changes. This works fine. We don't need to make any adjustments to either component since the change is occurring in the parent component. However, you may want to change the data directly inside the child component. Let's try moving the button from the parent component to one of the children components. Back in the editor, we'll cut the button and place it directly inside the user component. This will result in an error because we are not allowed to mutate props. The reason we aren't allowed to do this is because the parent component will not be notified of the change. The changes will not be reflected in other components too. Another downside to updating a prop in a child component is not being able to hold on to those changes. If the parent component updates the age, those changes will override the changes in the child component. The parent component has priority over changes to its data. This means that the user component will use the age inside the app component instead of using its own version of the age. This is a problem, as you may want to make changes to data inside children components, but have those changes reflected in all components. This includes sibling components like the greeting component. How do we let the greeting component know the age was updated? We'll discuss a solution in the next lecture. In this lecture, we're going to learn how to update props from the child component. Props are not allowed to be updated in child components. This introduces bugs and unexpected behavior in our application. But what if we need to update a prop from a child component? We're going to be doing something called emitting events. The word emit means to produce or trigger something. When you click on a button or element, JavaScript will emit a click event. It doesn't call any specific functions. Instead, any code that listens for that event will run. We're not limited to the standard JavaScript events. We're allowed to emit custom events. Vue makes this process easy by providing a function that does just that. After emitting a custom event, we can listen for those events in our application. We already know how to listen for events. All we need to learn is how to emit them. It's quite simple. Inside the user component, we're going to change the expression inside the click event. Rather than incrementing the age, we're going to call the function onClickAge. Next, create the methods object and define the onClickAge function. We'll be using the shorthand ES6 syntax version for defining the function. The next step is to emit an event. Vue has a special function for doing this. We can emit an event by calling the $emit function. This function will emit an event that other components can listen for. Something I want to point out that I mentioned before is the function starts with a $. Vue likes to name its own functions and properties with a $. This makes it easy to tell the difference between an official Vue function and some function by other components or libraries. It's a simple way to differentiate between things. Alright, moving forward, this function requires one argument. It requires the name of the custom event. You can call this whatever you want, but I always recommend keeping it simple and concise. We'll set this to age change. We're almost finished. Any parent components can listen for the event. The next step is to have the parent component listen for this event. We're going to listen for the event inside the app component. This is because only parent components can listen for events from children components. This event is inaccessible to the greeting component. That's fine, as the app component is a parent component to the greeting component. If we change the age inside the app component, then all children components will update as well. To listen for an emitted event, we can use the vOn directive. We'll apply this to the user component, but with the shorthand syntax. The name of the event is the name we used in the first argument of the emit function. In this instance, this would be age change. Listening for a custom event is the same as listening for any standard JavaScript event. From here we can run an expression. We'll increment the age. This is what will happen. When the user clicks on the button inside the user component, this will run the function onClickAge. The onClickAge function does one single thing. It will emit an event called age change. Any components that are using the user component will be able to listen for any custom events emitted from it. That's exactly what we do in the app component. To listen for an event, you use the vOn directive or the shorthand version @. You listen for the event like any other event. If the event is triggered or emitted, then the expression inside it will run. In this example, the age is incremented. Let's test if this is true. Try clicking on the button in the browser. Initially, the age will be 20. The age will increment by 1 on each click. If it surpasses 25, then the greeting component will update with the appropriate message. This is exactly what we wanted. We're no longer updating the age inside the user component. We're simply emitting an event. The app component is what changes the age. Since the age gets changed inside the app component, then all children components get updated with the age as well. Admittedly, it's quite a few steps to do, but you'll get used to it the more you practice it. Let's take it a step further. In some cases, we may want to pass data from the event to any listeners. For example, let's say we wanted to pass on the value that should be added onto the age. Inside the user component, we can pass an additional argument to the $emit function. The additional arguments will be passed onto any listeners. We'll pass in the number 3. This is what will be passed onto any listeners. To use this value, we'll need to update the code inside the app component. Instead of incrementing the value, we'll call a function. The name of the function will be updateAge. Next, we'll add the methods property to the object below. We'll define the updateAge function. We'll accept the number passed in as num. Lastly, we'll add the number to the age. Refresh the page and try testing out the button. Instead of incrementing the value by 1, it will increment by 3. Passing in values is very simple. There are 2 steps to the process. First, you pass the data as you're emitting the event. Second, you can update your expressions to run functions that accept in the data. In the console, we'll receive a warning by Vue. It's telling us that we should add the emits option to the user component. This is because Vue wants to know what events the parent component can expect from the child component. Back in the editor, we'll update the user component. We'll add the emits option. This will be an array of events that will be emitted from the component. We'll add the age change event to the array as a string. The reason Vue recommends adding emits option is because it helps document what the component does. It's a recommended good practice. One last thing I want you to be aware of. This process is only necessary when we need to make changes to any of the props. We can continue to use props inside computed properties or methods. It's perfectly fine to use props as read-only values. Let me show you an example. Inside the user component, we want to display the age doubled. Switching to the user component, we'll create a computed property called age doubled. Inside the function, we'll return the age property multiplied by 2. Every prop is accessible directly via the this keyword. Vue will take care of proxying the value. In this example, we're not directly changing the prop. Instead, we're grabbing the value and using it to create a whole new other value. We'll create an expression inside the template to output the age doubled computed property. Refresh the page after making those changes. The age has been doubled. This is because we're not directly changing the value. If I press the button, then the age gets incremented like before, but the user component is still doubling the value. With every change, we still don't get any errors. Once again, this is because we're just grabbing the value. We're not changing it. If you plan on using the value, but not changing it, then it's not necessary to use events. That's very important to know, as you don't want to end up writing too much code. We've learned how to add props to our components. Their data passed down from a parent component to a children component. We can take it a step further by validating the values. Validating a prop can be useful for debugging your application. If you have a component that's used in dozens of locations, then you may want to make sure that a prop is a specific data type. By adding validation, you can catch if a component is passing in the wrong type of data, allowing you to fix it before shipping your app to production. Validating props is very easy. Inside the user component, we're passed down a prop called age. The age should always be a numeric value. Let's validate it. Rather than passing in an array, we can pass in an object of props to accept. Each property in the props object will represent a prop. The key name is the name of the prop. We have one prop called age. The value of this should be an object. The object will contain the validation rules, if any. The first rule you can set is the type. The type is the data type the prop should be. All JavaScript types are supported, such as string, number, object, array, etc. In the resource section of this lecture, I provide a link to the types you can use. There are additional types like date and symbol available. If we scroll up above, we'll find examples on how to validate props. Feel free to read over this once you're finished with this lecture. Let's switch back to the component. We'll set the type to number since we want numeric values. We're not limited to one data type. You may want to allow multiple data types. If this is the case, you can replace this with an array and then add the data types you'd like to accept. I can add in number and string. I'm going to revert this back since I want to restrict this to numeric values. I just wanted you to be aware that it is possible to check for multiple data types. We're not limited to checking the data type. We can make the prop be a required value. In the object, we'll add a property called required. Its value will be set to true. Anytime a component uses the user component, they're required to pass down an age. If they don't, then it'll throw an error. Let's test out both rules. Switch to the app component file. Let's remove the age prop from the user component in the template block. Next, let's refresh the page. Upon refreshing the page, we will get an error inside the console. It's telling us that the user component is missing the age prop. It's also telling us that this error can be found inside the app component file. Pretty useful information for debugging the application. Let's add the age back in. After making that change, the error inside the console will disappear. Now let's try testing if the type rule works. We're going to open the Vue Dev Tools. The age can be found inside the app component. We're going to change the value to a random string. After changing the value, an error will appear in the console. It says the following: invalid prop. Type check failed for prop age. Expected number got string. This shows that the type rule works. Once again, I want to stress that this is really useful for debugging purposes. If you're using a prop that is generated by user input, then there's not much you can do to prevent them from passing in an invalid type. Even with form validation, there's still a possibility for this error to appear. Just be aware of that when using props. There's more we can do with validation. We can set a default value. Back inside the user component, we'll add a new property called default and set it to 20. Since there's a default value, we don't need to have the required property. We'll comment it out. With the default key set, we're always assured that the prop will have a value even if one is not passed down. Something I want to note is that the default key must be set to a function if the type key is set to be an object or array. The function must then return the object or array. This is one of those weird quirks of using the default key. So far we've covered the three main ways to validate the prop. Sometimes this may not be enough. You may want to have custom validation. That's possible with the validator property. We'll comment out the default key. Then we'll add in the validator key. the validator key must be set to a function. The function is passed in the value of the prop. We'll be able to perform validation on the prop value. The function expects you to return either true or false. If true, then the validation passes. If false, then the validation fails. Inside this function, we're going to return the following: value less than 130. The condition will check if the value of the prop is less than 130. If it is, then the condition will pass and the value returned will be true. Therefore, the validation will pass and the application can proceed like normal. The reason I'm checking if the age is lower than 130 is because there isn't anyone who is over that age. It wouldn't make sense for anyone to be older than 130. We'll refresh the page to test this out. We'll continuously click the button until the age exceeds 130. Surely enough, we get an error in the console saying invalid prop. Custom validator check failed for prop age. Fantastic! As you can see, Vue provides a lot of flexibility for validating your props. You could probably add a mechanism for preventing the age from exceeding the maximum age to prevent this error from being triggered. Try doing that on your own as a fun side challenge. One last important note I want to add in before I end this lecture is that the validator functions run before the instance of the component is created. Therefore, you won't have access to the data, computed, or methods properties inside the function. For example, back in the editor, we'll try calling the onClickAge method inside the validator function. Switching back to the page will tell me that the method is undefined. This is important to know, as you may try to access other parts of your components and run into errors after doing so. It's because the Vue instance hasn't been created. Therefore, you won't have access to any proxy methods or properties. I'll comment out the line before proceeding to the next lecture. Emitting Events has proven to be the best way to update data in a parent component from a child component. There are libraries out there that make sharing data between components easier. We'll get into those later in this course. In this lecture, I want to introduce an alternative solution for updating data in the parent component from the child component. Callback functions can be used to update data. If you are familiar with React, then you will feel right at home with this method of sharing data. Creating callback functions is a very simple process. Let's explore how to create one. Inside the app component, let's create another method called updateAgeCB. It will do the exact same thing as the updateAge function. I'm creating two versions of the same function so that we can compare the difference. We're going to pass this function down to the user component. You heard that correctly. You're not limited to sending down primitive values. You can also send down functions, objects, and arrays. We can pass this function to the user component just like we would for any other prop. Inside the template, we'll bind an attribute to the user component called ageChangeFN with the value of updateAgeCB. The letters FN are short for function. Let's switch over to the user component to accept this function as a prop. We're going to set this to function. We're not setting this to an object like we did with the age. If you are only planning to check for the type, then you don't need to set this as an object. Instead, you can directly set the type. That'll work fine. With the function added, we can use it in our code. Inside the template, we're going to make a copy of the button. However, this time we're going to directly call the callback function. We'll pass in the number 3. We're going to update the text inside both buttons. We want to be able to tell the difference between the two. Let's refresh the page to see what happens. If I were to click on the second button, then we will see the age increment by 3. The app component will continue to update the age. Both children components are provided with the changes. When we use the callback, We're basically passing in the function to the child component. However, when we call the function inside the child component, it's not like the child component has a copy of the function. Instead, it's calling the function inside the parent component. The function inside the parent component will have access to the data. Therefore, that is where the data will change. At this point, you may be wondering, which is better? Should you use callback functions or emit events? It really comes down to preference. As far as performance goes, both methods of communicating data are about the same. You won't see any significant performance gains from using either one. According to Vue, it's recommended to use events. Most examples you'll find in the documentation use events. For consistency reasons, I recommend using events. There is one advantage to using emitted events. I'm going to refresh the page. Then, inside the Vue Dev Tools, I'll switch to the Timeline tool. The Timeline tool will display a list of events emitted by our app. It'll even display events emitted by the browser. There are 3 categories of events. I'm going to click on the button that emits an event. After clicking this button, an event has been logged. We can click on this event and view the details of what the event was. We're given the name of the event. We're also provided the source. It tells us that the event was emitted from the user component. Lastly, we're given the payload. The payload is the data that was sent with the event. All of this information is useful for debugging the application. If I were to click on the callback button, then nothing will get logged, not even in the console. This makes things a bit harder to debug. Of course, you could log this manually, but that can cause more headaches than it can solve. If you were to change any names, then you would have to change the log information. With events, the names are already logged for you, so there's no need to do it yourself. This is one of the main reasons you would want to use events. On top of that, most tutorials and documentation use events for communicating data between components. Therefore, you'll see a lot of applications using that practice. At the end of the day, it's up to you. You can use callback functions or emit events. In this lecture, we're going to learn how to use slots in our component files. Slots are a great way to pass down content from a parent component to a child component. They are an alternative to using props. Slots are very popular among library developers. It would be beneficial to understand how they're used. They can be really useful when you need to make your code more reusable. What do I mean by that? Well, let's look at a real use case example. We'll be working on a new project for this example. In the command line, run the following command: npm init vue at latest. During the setup process, set the name of the project to slots. Next, select no as the response to all questions. We're going to be working with the bare minimum. Lastly, we'll move into the new directory. The packages must be installed. Run the npm install command. Next, let's start the server with the npm run dev command. Let's do some cleanup. In the components directory, delete all component files. We won't need them for this demonstration. Up next, we'll update the app component. We're going to remove the style block from the component. Then, we'll strip the template and script blocks to the bare minimum. From the script block, export an object under the default namespace. Set the name property to app. We're ready. Let's start working with slots. Inside the template, we're going to create a simple form. The form will have 3 intersections. We'll use div tags to create these sections. The sections will be called help, fields, and buttons. The help section will contain some help text to inform the user on how to fill out the form. The fields section will hold the input fields. Lastly, The Buttons section will hold the submission buttons. We're going to fill out each of these sections quickly. This is how forms are typically built. You split everything into sections to keep your markup structured. It's a common methodology of approaching forms. I'm not using any expressions or directives inside the form. It's just plain HTML. You can think of this as a login form. We can improve the form by putting it into its own component. It's getting rather large, so placing the logic in a separate component would be a good idea. Let's do that. Inside the Components directory, create a file called form.vue. We'll add the template block to the file. We're not going to bother with the script block at the moment. The goal is to move the form into a separate component. We'll cut the form element from the app component. Then, we'll paste it into the template block of the form component. We'll want to register the component locally. Switching back to the app component, we'll import the form component. Next, we'll register the component by adding the components object to the exported object. We're prefixing the name with the word app. That's because there's already an element called form. We don't want to have a naming conflict. This is another reason why it's always considered good practice to namespace your component names. Back in the app component file, we'll add the form component where the form was originally located. I'm lowercasing the words and adding a dash between them. This is an alternative way to write components. In an earlier lecture, I talked about how you can use kebab case or Pascal case for your component names. If you opt into using Pascal case, Vue will allow you to write the component with lowercase letters. It'll add a dash before each letter that was capitalized with the exception of the first one. We can use the original name, but I like to use the lowercase version because it keeps things consistent inside the HTML. Native HTML elements are always lowercase. Alright, let's move on over to the browser. Surely enough, the form gets rendered. There's nothing wrong with the form, but there are some limitations with the component. A form is a common UI element in any application. It's likely that you'll have multiple forms. Some examples would be a login form, register form, contact form, etc. They may have different input fields and objectives. However, they may look visually consistent. This means you're probably using the same markup structure and classes. It isn't just forms that suffer from this problem. Most UI elements are reusable. If we were to go back to the application, we wouldn't be able to reuse the component. Instead, we would have to create another component if we wanted to reuse the form. Let's say we wanted to create a contact form. The contact form would use the same base HTML, but with different input fields. I want to be able to reuse the form component. We could do this a number of ways. For example, we could use props and pass down the stylings and fields. That's a viable solution, but passing down HTML through props isn't really fun. This is especially true if you have complex markup. The recommended solution is to use slots. We'll create the second form in a moment, but first let's explore how to create a slot. Before using slots, you need to identify which parts of your component are reusable or unique. Inside the form component, the markup that will be unique are the 3 sections inside the form. I'm going to cut all 3 sections. Then I'll transfer them over back to the app component. We're going to paste the markup inside the app form component like so. Vue allows us to pass down markup in between the components tags like we're doing here. However, this won't work just yet. We have to instruct Vue where to render the markup in the child component that's receiving the markup. Switching to the form component, we're going to insert a tag called slot. We'll insert it inside the form element. The slot tag we're using is a component created by Vue. It'll get replaced by the content that gets passed from the parent component. Let's move over to the browser to view the result. The form renders normally. Slots are a way to pass down markup from the parent component to the child component. In this instance, we're passing down these sections to the form. The slot tag we have inside the form component will be replaced with the content passed in. There may be some scenarios where no content will be passed in. We have the option of rendering default content. Back in the editor, in between the slot tags, we can add some default content. We'll add the following: no form to render. If content is not passed down from the parent component, Vue will use the content inside the slot component. We can test that out by switching over to the app component and using the form component twice. For the second copy, we'll leave it empty. Hopping on over to the browser, we will see the first form rendering. The second form will have the message inside the slot rendering. Having default content is optional and can be useful just in case you forget something. This is the basics of creating slots. We'll stop here. In the next one, we'll look at how we can further improve this solution. In this lecture, we're going to explore how to create named slots to optimize our component. First, let's update the second form with some inputs. We'll turn it into a contact form. Inside the app component, we'll copy the content passed into the first form. We'll paste it in as the content for the second form. Next, for the second form, we'll change the help desk and the input fields. We have two forms using the same component, but with different inner content. Let's test if this works. Inside the browser, the two forms will render without a problem. The main benefit of using slots is the ability to create one component that will act as a skeleton. The form component is some base markup with a slot for the parent component to insert content into. By having a skeleton, we only need to create one component. We didn't have to create two separate components like a login component and contact component. We have a generic form component instead. In a sense, this makes the component more reusable. This is what slots are mainly used for. To be truthful, this component isn't the best example. In a real-world example, your skeleton would most likely have much more markup than just a form element. It would be beneficial if we could distribute the content better. That's possible with something called named slots. For instance, inside the app component, the markup between both forms have the same three sections. It would be better if we could leave these sections inside the form component. We'll switch back over to the form component and add in these three sections again. They were the help, fields, and buttons sections. Inside the help section, we'll insert the slot component again. This time, we'll add an attribute called name. We can assign slots unique names by adding the name attribute. We'll give this slot the name of help. By assigning a name, we're given more control over where the slot content is distributed and placed. This also allows you to have multiple slot locations. We'll add slots to each section with the name attribute. We can call our slots whatever we want. I recommend giving them something relevant. There will be a slot for the help, fields, and buttons sections. We can go back to the app component to use these sections. Instead of using the class attribute, let's change each of these to the vSlot directive. The vSlot directive can be used to tell the child component where the slot content should be placed. We need to add a colon after this directive followed by the name. The name corresponds to the value we used for the name attribute in the child component. We'll assign this part of the content to the help section. The second div element will be for the field section. Lastly, the third div element will be for the buttons section. We'll do the same for the second form. By using the vSlot directive, Vue will be able to identify where to load the content in the child component. There's one problem with this. The vSlot directive may only be applied to template tags. This is a limitation you should be aware of. We can't use this directive on the div element. The solution is simple. We'll replace the div tags with template tags. Let's check if everything worked. Switch over to the browser to check the application. Both forms are functioning correctly. Thanks to named slots, we have more control over how content is distributed from within the component. We aren't limited to using named slots. We can use a combination of named slots and default slots. Let's go back to the editor. Inside the form component, we'll add a slot at the bottom of the form. By having a slot with no name, any elements that aren't assigned to a specific slot will be put there by default. Back inside the app component, we'll add a paragraph tag at the bottom of the first form with some dummy text. If everything I said was true, then the paragraph tag should be placed at the default slot location. Upon refreshing the page, we'll find the paragraph element added to at the default slot location. We can use a combination of named slots and a default slot. It's up to you. We can take this a step further. One advantage of slots is the ability to use data from the parent component. Let's try that out. Inside the app component, we're going to create the data function. We'll create one property called help that will contain the help text from the first form. We can use this data property inside the content itself. We don't have to use a prop to pass it on. Inside the first form, we'll replace the help text with the expression help. This will work because technically we're still inside the app component. Since that's the case, then we still have access to the data, computed properties, and methods inside this component. Therefore, there's no need to pass this down as a prop. Hopping back to the browser will show that the expression works as expected. If you don't plan on using the data inside the child component for functions or computed properties, then there's no need to use a prop. This is a perfectly fine alternative. As you can see, slots can provide for a more interesting way of structuring your application. In the resource section of this lecture, I provide a link to learn more about slots in Vue. I recommend giving it a good read if you want to know what else you can do with slots. The last thing I want to go over in this section are dynamic components. A dynamic component is a component that can be swapped with other components. This allows you to toggle between components. Using dynamic components isn't difficult, but there are a couple things you should be aware of when using them. I'll discuss everything you'll need to know in this lecture. We're going to work in a new project. Using the command line, run the following command: npm init vue at latest. Set the project name to dynamic components. Select no for all questions. Lastly, let's move into the newly created project. Inside the new project, install the packages with the npm install command. After moving into the new project, be sure to turn on the server with the npm run dev command. Since this is a new project, we'll need to clean things up a bit. Inside the components directory, delete any components created by the CLI. Open the app component file next. We'll want to remove a lot of the content. We'll delete the style block. The template and script block will be emptied out. Lastly, export an object with a property called name with a value of app. We're starting fresh to focus on the idea of dynamic components. We'll need to create some new components for showing how dynamic components work. You'll see what I mean in a moment. We'll create two components called About and Home inside the Components directory. For the About component, we'll add the template block. Inside of the block, we'll output a message. We'll do the same with the Home component. We have two distinct components. I want to display the component depending on a user selection. We'll create a drop-down where the user will be able to select what component they'd like to view. Switching back to the App component, we'll create a drop-down menu. We'll add two options which will be Home and About. We'll use the drop-down to select the component we currently want active. First, we'll need to import the components. We won't be able to use them if they're not imported. Inside the script block, import both the Home and About components. Next, register them by adding the Components option to the configuration object. After registering the components, they're available to use in our template. However, we don't want to load the components. We want to load them depending on the value inside the drop-down menu. We'll need to store the selection in the drop-down menu to keep track of what component to load. We're going to define the data function inside the exported object. Inside the data function, create a property called component name with a default value of Home. There's nothing else we need to keep track of. The component name is all we need. You'll see why in just a moment. We're going to update the drop-down next. It's what will allow the user to toggle between components. Inside the Select Form field, we'll add the vModel directive. The expression will be the component name data property. We have the drop-down working and we have the components registered. The last thing we need to do is actually load the components dynamically. Vue provides a component called Component. We'll add that right below the drop-down. The Component component allows you to dynamically load in a component dynamically. You can think of it as a placeholder for the actual component. To set the component to load, we need to add the attribute is. We'll bind it. The value for the is attribute must be the name of the component that's registered globally or locally. If we want to be able to toggle the component, then we'll need to bind this attribute. If you don't bind it, then the component will always load the same component passed in. The value for this should be component name, which holds the value inside the dropdown. That should do it. Let's test the application by opening it in the browser. The app is running normally. The dropdown should have the Home option selected by default. The Home component is rendering because it's the default value for the dropdown. If we were to toggle the value to About, the About component will appear. We can continuously toggle between the two components without a problem. This is how we can create dynamic components. We can use the component inside our template. Then, we can pass in the component name into the is attribute. We can create some interesting interactions with this component. For example, a tabbed component or menu navigation. There is something you should be aware of though. When a component is toggled out, it gets unmounted. This means that any data inside of it will not be available anymore. If the component gets reintroduced on the page, the data will be reset to its default state. We can even view the component getting unmounted by using the Lifecycle hooks. Let's use the Lifecycle hook to confirm that. Back in the editor, inside the Home component, we're going to add the Lifecycle function. Inside of it, we will log a message indicating that the component was unmounted. After making those changes, let's refresh the page. If we were to toggle the components, the message should appear in the log. This will inform us that the home component was unmounted. Every time I toggle the home component, this message will appear. This is important to understand, as any data you have in a component will also be destroyed. Any events you may have attached to that component will become unavailable. The default behavior can work fine. Other times, you may want a component to persist. Vue provides the option of allowing persisted data. Back inside the app component, we're going to wrap the component with a component called keepAlive. This component does one simple thing. It keeps the component that's inside of it alive. Even if it shouldn't appear in the DOM, this will make sure the component lives in memory. If the component needs to be added onto the page again, Vue will use the one in memory rather than creating a new component. Back on the page, we can toggle the selections like last time. Everything works, but behind the scenes things are different. We won't see the message being logged inside the console because the component is not being destroyed anymore. Instead, it's being kept alive in memory, therefore the unmounted lifecycle hook is no longer triggered. Switching over to the Vue Developer Tools, we can see that both components are still inside the app component. Instead of completely removing one, Vue will set the component as inactive. This will mean that the data will still persist, but it won't appear on the page. This can be useful for when you don't want to make an additional request for the same data. Of course, this does have one disadvantage. Since the unmounted lifecycle function doesn't get executed anymore, then you won't be able to run code if the user switches off the component. You may want to run code when this occurs. Luckily, Vue compensates for this by introducing 2 additional lifecycle hooks that weren't available before. Inside the home component, we'll add the 2 lifecycle functions called activated and deactivated. Inside both functions, we're logging a message. The activated function is called when the component is active. With both functions set up, let's refresh the page. As I toggle the components, the activated and deactivated lifecycle functions are called, thus giving you the opportunity to execute code when the components are toggled. That's about it when it comes to using dynamic components. I'm sure you'll find a lot of uses for this in your applications.
Aldo here again. What do you think? We'd greatly appreciate you smashing that like button if you enjoyed the video. But either way, drop us a comment to let us know your thoughts. If you enjoyed this Vue Crash Course, make sure to check out Luis's complete Vue Developer Bootcamp course, where you'll go a lot deeper and gain the skills to get hired as a Vue developer. You can check it out using the link in the description below, or watch that video right there on your screen to see what it's all about.